Hi, welcome to Code Eater's Blockchain channel. My name is Kshitij Srivastava and I will be your instructor for this blockchain course. In this blockchain course, we are going to talk about a lot of different things. I have divided this full course, this full blockchain course into three modules. That is module A, which will be all about blockchain, how blockchain work, why do we need to study blockchain, each and everything we are going to cover in module A. Then we will have module B, which will be all about cryptocurrencies. What are cryptocurrencies? What is the difference between a token and a coin and a protocol? All those things. If these things sounds unfamiliar to you, so don't worry, we are going to for each and everything in depth. And then we are going to talk about smart contracts. What is a smart contract? Where do we deploy our smart contract? Each and everything about smart contract we are going to talk about in module C. Is there any prerequisite to take this course? There is no prerequisite to take this course. Anyone having no knowledge of blockchain, having no knowledge of any technical topic can take this course. Okay. And now let us talk about what are the contents that we are going to see in each module. Because I have divided this course into three modules. But what are the contents that we are going to see in different modules? Let's see that. So in module A, we are going to talk about what is blockchain. Then what is a hashing algorithm, because this is one of the important concepts that you must know when you are starting with blockchain. Then what is immutable ledger, then distributed P2P network, because our whole blockchain network is actually working on distributed P2P network. So we will see that. Then we will talk about what is mining and then consensus protocol. Okay. Then in module B, we will start with Bitcoin. What is Bitcoin? Bitcoin monetary policy, mining, nonce, and let me tell you, we are going in depth of mining because I know mining is one of the most I will say most demanding topic, or people wants to know about what is mining. So we will look in mining a great detail, and nonce is related to mining, so we will talk about that. We will see the different technologies that we use in order to do mining, like CPUs, GPUs, ASICs, and all those things. Then we will talk about mempool, very important thing. If you do not understand what is mempool and all those things, don't worry, you will understand at the end of this course. Then we will talk about the different type of transactions and all those things. Then wallets and how wallets works, what are UTXOs, each and everything. And at the end of this module, we are going to see what is a public key, what is a private key, what are digital signatures, what is the importance of cryptography in blockchain. We are going to see that. Then in module C, we are going to talk about what is Ethereum. Then smart contracts, because smart contracts are programs that are written on Ethereum. So we will see that. Then we are going to talk about decentralized applications, EVM and gas. Now this is something might be a new term for you, but don't worry, you will understand at the end of this module. Then what are DAOs, decentralized autonomous organizations? We will see that. What is hard fork, what is a soft fork? We will see that. What is DAO attack? There was an attack on DAO on Ethereum. We will study about that so that we do not end up in the same place. And then we are going to talk about ICOs. That is just like IPOs. We have IPOs in our traditional world. In blockchain world, we have initial coin offering. So we will talk about ICOs. And at the end, we will talk about alternate coins, or altcoins means coins other than Bitcoin. So you can clearly see that all these modules, if you will see, it is a pretty big course. We are going to see each and everything in this course. So it will be a lot of fun. You will learn a lot, that I can guarantee. So I hope I will meet you soon in the next video. I hope you are excited for the next video. And I think this is one of the most fundamental question that everyone must ask whenever he or she is starting with a new course, right? So let's start with why study blockchain? What is the reason for studying blockchain? Let's see that. And we will understand this with the help of story of internet. Okay, let's see how internet came into existence and where internet is actually lacking and what gap can be fulfilled by blockchain. So if we talk about our communication, if we talk about early times, so this is how we used to communicate using pigeons. If you have watched I will say Harry Potter. In that case, you might have seen that owls were being used in order to communicate, in order to send messages, right? In order to send a message from one place to another. So these were the times when we have this mode of communication where pigeons were used as a transporter of our letters, right? Then we have post office, right? Mailboxes that we started with writing letters and to our friends, to our relatives. But it was also a time taking process, right? It took around months or sometimes even more than a month when we have to use these post offices, right? And today, if we talk about in the era of internet, everything is so easy, right? Communication has become so smooth. Now we can talk to so many people at once. We can talk to our relatives or to our friends who may be in a different part of the world, and still we may be able to communicate with them just with the help of emails, right? And then we have another great invention, that is Facebook, or I will say social media, through which we can communicate with thousands of people in just a click, right? Now, currently, I'm able to communicate with you. Definitely, it is a one-way communication, but still, I'm able to communicate with so many people at once, and this is all because of internet. So, one thing is for sure here, that internet has bring a revolution when it comes to communication, right? Internet has made our communication part so easy that we cannot even live without internet, right? Today, if we have to live without internet, it will be a disastrous day, right, for us. But there is something where internet is lacking. Definitely communication part has so easy now, but there is one point where communication, where actually our internet is lacking, and that point is trust. We cannot trust the internet, and let me explain you this with the help of an example. Now let us understand this with the help of an example. Let's say this is an NGO where you want to donate some money, okay? And for donating money, what you did a internet transaction, okay? So now you have donated some money to this NGO via internet transaction, but the problem is you do not know whether this NGO is going to use this money that you have transferred to this NGO via internet, whether this NGO is going to use this money for a good cause or not, whether this NGO is going to use this money for women education, child education, or some good welfare work, or this NGO is going to do some money laundering, or let's say funding some terrorist attack. So you do not know, right? And this is one of the reason that many of the times we do not donate to different organizations, because we have a fear in mind that what happen if they are using our money for some bad practices. So that's why we do not donate. So the thing is, in this whole picture you can clearly see that we cannot trust this NGO. And why we cannot trust this NGO? Because we cannot trust our internet, because we do not know the internet transaction that we are doing, where this money is actually going. So one thing is for sure, internet cannot provide trust to us. So the only technology that can provide trust to us is blockchain. With the help of blockchain, we can bring trust on the table. And how this blockchain works, you will understand, because I'm not going into depth of blockchain currently. But one thing is for sure, you can trust this blockchain technology, and trust is the thing that internet cannot provide you. Once we will move on to blockchain application, you will understand how blockchain is actually bringing trust to the table. Okay, so if we talk about blockchain is a disruptive technology, just like internet. Internet made our communication part very easy. One of the most important human element, right? Human thing that we need to talk to people, we need to communicate to people. If we talk about blockchain is bringing trust to this communication. Now we are not just communicating, we are doing communication while trusting someone. And how this is so, we will talk about it. But this is the reason why blockchain is getting so much popular, and this is the reason, if you will see in these two pictures, blockchain is just acting like internet, acting in the sense like internet brought a revolution to the communication part. Blockchain is bringing revolution to this trust part, and that's why blockchain is getting famous day by day, and it will be famous just like internet, or more famous just like internet. So there will be huge opportunities when it comes to blockchain in the near future. Currently there are also a lot of opportunities, but in the near future you will see exponential growth opportunities in the blockchain domain, and that's why we need to study blockchain. Now in this video we are going to talk about what is blockchain. This presentation will be a very, I will say, interesting presentation. You will enjoy a lot. Let's start this presentation. So before talking about blockchain, it is very necessary that we should know who are actually inventors of blockchain. Now if I will ask you, what do you think? Who is inventor of blockchain and who are inventors of blockchain? Please let me know in the comment below. I want to see what is your answer. I hope you have commented your answer, but I know most of you like what have actually commented there. Most of you might have thought that inventors of blockchain or inventor of blockchain is Satoshi Nakamoto. But let me correct you here. Satoshi Nakamoto is inventor of Bitcoin, but not blockchain. Inventors of blockchain are Stuart Haber and W. Scott Stonetta. So these are the two people who are actually inventors of blockchain. They have written a paper on it. I think the paper was of around related to digital signatures or something. I will share the link in the description so that you can also read it. It was around 1990. They have published this paper. So remember, inventors of blockchain are Stuart Haber and W. Scott Stonetta and not Satoshi Nakamoto. Okay, many of the times you will see this false information on the internet, but I want to correct you here only so that you do not get, incorrect information. Now let's talk about what is blockchain. So as you can see on your screen that we have this blocks, right, connected with each other, and hence we have something like a blockchain, right? Means chain of blocks, but definitely you cannot define blockchain like this, right? So let us see a definition of blockchain. Let me tell you, there is no fixed definition of blockchain, but this is one of the definition which I think identify the blockchain in the most good way. So that's why we will take this definition. So blockchain is a distributed immutable ledger which is completely transparent. Okay, let me repeat it for you. Blockchain is a distributed immutable ledger which is completely transparent. Now let us understand the meaning of this definition. Let us understand the meaning of each keywords that I am using in this definition. That is ledger, immutable, distributed, transparent, everything. Okay, so I will start from ledger, then we will go to immutable, then distributed, and then we will talk about transparent. Okay, so let's talk about what is a ledger. So a ledger looks something like this. So ledger is actually a place where you write all your debit as well as credit entry. So let's say you might have seen that whenever you go to a shop, let's say, or if you have, let's say, went to McDonald's or something. So what they are doing is they are actually writing each and every transaction. Like if we talk about a normal shopkeeper, okay, so in that case what they are doing is they are writing each and every transaction in their notebook, that what amount they owe you or what amount you owe to them. Each and every transaction is actually being written in this ledger book. Okay, so this is the traditional approach which people used before computer. Sometimes you might see this, but now in most of the at this point of time, what you will see that people are using computer in order to write down all the transactions. So you might have seen that whenever you go to McDonald's and you buy something, they are writing each and everything in their calculator type of thing, right? And that's how they are providing you receipt and everything. So what they are doing is actually they are recording the transactions, like how much you are paying, how much the change they have given you. Each and every transaction is being recorded in that ledger. Okay, so ledger is a place where transactions are recorded. Now this is how real world operates. Okay, this is the real world ledger. If we talk about blockchain, in blockchain the blocks of the blockchain act as ledger. So we have seen, right, that our blockchain is formed by various blocks connected with each other via chain. And this block in the blockchain works as a ledger for the blockchain where each and every transaction are being recorded. So let's say you are paying some Bitcoin to your friend. Let's say A sent 5 Bitcoin to B. Now this transaction will be recorded on this block of the blockchain. And then like this only, if C is sending some transaction to D, some Bitcoin to D, in that case, that transaction will be recorded on this block of the blockchain. So this is the meaning of our first keyword. Second keyword is immutable. Now, the problem with this ledger is that this ledger is mutable, or if we talk about databases, right, the centralized databases, all those type of ledgers are actually mutable. Mutable means you can erase the data, you can manipulate with the data. Like for example, I can just remove this one of the pages from this notebook, right? I can completely erase one of the written handwritings over this notebook. If we talk about a database, so the person who is in charge of that database can completely erase one of the transactions from the database. So the thing with these ledger is that they are mutable. You can mute them, means you can change them. But when it comes to this block of the blockchain, these are totally immutable, means once a transaction is recorded on this block of the blockchain, you cannot change that transaction. Nobody can change that transaction. That transaction is like permanent on this blockchain. And how this is done, we will talk about it, so don't worry about it. But now I just want to tell you like what is the meaning of these keywords and why blockchain is so special. Okay, so now we have understood the meaning of two keywords, ledger as well as immutable. Now let's look at the third keyword. So if we talk about a blockchain network, this is how a blockchain network looks like. Okay, so we have different computers here. These computers are connected via P2P network, which we will talk in our upcoming videos. For now, just imagine that these computers are connected with each other. Okay, and each of these computers, as you can see, that they are actually holding blockchain. So A is holding a blockchain, and exactly like whatever A is holding, like the exact copy is held by B, means A and B are carrying the same blockchain. C, E, and F are also carrying the same blockchain, means all of these people are having the exact copy of the blockchain. Okay, so all of these people are having the exact copy of the blockchain. Let's say a new block is created. Now, how this is created, we will talk in our upcoming videos. Just for now, let's say that A creates a new block. Okay, now he will add this block to his blockchain. Now, what will happen? A will start communicating this information to B, C, E, and F. Okay, saying that, okay, now I have created a block. Please see this block. Please verify and validate this block, whether this block is right or not. So what B, C, E, F will do, they will start verifying and validating this block, whether this block is a malicious block or not, or whether this block is a suspicious block or not. If this block is a correct block, what they will do is they will simply add this block to their blockchain. If you will see, right? All of these people have added this block created by A to their blockchain. And this is how blockchain is distributed in nature. You can clearly see the block is getting distributed all across the network. And that's why we call blockchain a distributed immutable ledger. So this is like A is holding a ledger, a notebook, and A is distributing this notebook to all the people who are connected with him. Okay. Now, what is transparent here? So the ledger, as you can see, that ledger is totally available with everyone, right? Whosoever is the part of this blockchain network. So the ledger, the transaction that these ledger will contain is totally transparent to the public. Anyone can see that transaction. But there is a catch here. These transactions are in encoded format. So definitely people can see the transaction that, okay, someone has done some payment to someone, but nobody will know who that someone is. Each and every data is encoded on the blockchain so that nobody can read it. Okay, but the data is transparent in nature. Everything is totally public. Everyone can see everything, but nobody will able to decode everything. Okay, and that's why we call blockchain as a distributed immutable ledger, which is completely transparent. Hi, now in this video we are going to talk about the different applications of blockchain. Let's start. So there are a lot of applications of blockchain. First application of blockchain is product tracking. Another application of blockchain is smart contracts. Third application of blockchain is healthcare system. Fourth application of blockchain is international wire transfer. And we are going to have a close look up at all these applications, like how blockchain is actually being used in all these different domains. So let's start with product tracking. So let's say you want to buy a coffee. Okay, so you went to the shop and you bought this coffee. Now, according to this coffee, like according to the packaging of this coffee, it claims that this coffee is, let's say 100% pure coffee. And let's say this coffee is, let's say, for example, brought from Brazil. Okay, just an example. and you trusted this coffee package, but after some time you realize that, okay, no, this is not that coffee. It is not the Brazilian coffee. Like, this coffee that I have in my hand is a fake coffee. Means this is completely, false advertising, I will say. Now, how we can prevent from these type of situation where we are buying something, and how to know whether the product that we are buying is actually a legitimate product or not? So for that, what we can do is we can use blockchain. Now, with the help of blockchain, what we can do is we can simply track this product. So this product, let's say this product has been tracked using blockchain. So this product will have a barcode. So you might have seen, right, barcode in various shops. Now, once you will scan this product will tell you each and every thing. This barcode actually tells you each and everything about this coffee, where it started, like you can clearly see, if you can see, some of the details are mentioned here, like what is the name of this coffee, from which country it is originated, like what are the different mode of transportation was done in order to bring this coffee, let's say from Brazil to India or Brazil to USA. So each and everything will be mentioned in this in this application. Now you must be thinking, like, how it is different from Amazon. Like, Amazon also does the same thing. When we buy something, we have all the details. But if you will see Amazon, so Amazon does not provide you the details of a particular product. Amazon only provides you the tracking ID, like where your product is, where your product will be, and all those things, right? So your product is already ready in the shelf, and from that shelf, each and every movement of that product is being tracked. But what we are talking here is, we are talking about complete product tracking. And how it is different when it comes with blockchain, because as we talked about blockchain, right, blockchain is a distributed immutable ledger. So once a transaction is recorded on the blockchain, no one can erase that transaction. So in the case of product tracking, once we have noted that, okay, this product was at this location on the blockchain, no one can erase that data from the blockchain. Now this is the beauty of blockchain, and that's how it is used in product tracking. And you can also see here that each and every information about the product is being mentioned in this application. Now let's talk about another application of blockchain, and that is smart contracts. Now this is one of the most beautiful, I will say, applications of blockchain. So please be aware, just be alert here, I will say. So how smart contracts are being used in blockchain? So first of all, let me tell you one thing, that smart contracts are simply programs that you write on blockchain. So like you have written program in C, C++, Java, Python, or if you have written in that case, so just like these programs, right, we have smart contracts, a program written on blockchain, simple as that. Okay, and if you still do not understand what are smart contracts, just don't worry, you will understand it after this example. So let's say let's take an example. Let's say there is a person A, he has this food delivery truck, and he delivers fruits. Okay, so he's a fruit supplier. We can think of it as fruit supplier, and he does this food delivery to this shopkeeper B. Okay, so this is our shopkeeper B who has a shop XYZ, and once he receives these fruits from A, B sell these fruits to his customers. Now once the delivery is done, B pays some money to A, right? This is how a business transaction is done. But after some time, B realizes that the apples sent by A are actually rotten. So now B is in loss. He cannot use those apples to sell his customer, right? Because if he will sell these apples to his customers, then their customers will be highly disappointed in B, because now the fruits are rotten, right? Now what B can do in this type of situation? Now in this type of business transaction, for example, what B can do is B can install a smart contract. Okay, B can install a smart contract, and we are assuming that the temperature to keep the fruits fresh is less than 30 degrees Celsius. So this delivery truck, you can think of this delivery truck as a refrigerated truck. Okay, this container that you're seeing, right, where delivery is written, it is actually a fridge. Okay, we are just assuming that this is a refrigerated truck, and the temperature in order to keep these apple fresh actually is less than 30 degrees Celsius. Okay, so this is our assumption. Now let's write some logic to our smart contract, because smart contracts are nothing but programs, right? So we will draw a flow chart here. that if IoT detected a temperature greater than 30 degrees Celsius. Now, what is this IoT? IoT is, for now, you can think of as temperature detecting device. So they detect the temperature. So we are assuming that this IoT is installed to that container of the truck. And if IoT is detecting a temperature of degree less greater than 30 degrees Celsius, and this is not good for our foods, right? Now, if this happens, in that case, we will definitely cancel the delivery and we will not pay to A, right? B will not pay to A in this scenario, and this is good. If this is false, if this condition is false, in that case, delivery will be done and B have to pay to A, means B cannot then deny that I will not pay to A because now I have received the fruits and I do not want to pay to A. This is not how this will be done when it will come to smart contracts. So this is how the logic of our smart contracts will work, and I think this is a very good logic also. Now, some of you might be thinking that how it is different from any other program, because we write programs in C, C++, Java. How it is different from any other program? What is so special about smart contracts? The special thing about smart contracts is that smart contracts are actually immutable in nature. Just like blockchain, you cannot erase the data from blockchain, right? So this smart contract will be deployed to the blockchain, and you cannot change anything from the smart contract once it is deployed to the blockchain. Now, this is one of the beauty of smart contracts. It means once this logic is written, no one can erase this logic. First thing. Second thing with the smart contract is that you do not require any human intervention. Means when I'm saying that if the temperature is detected is greater than 30 degrees Celsius, if this condition is, let's say, false, then we are transferring money to A, right? So in this case, money will be actually cryptocurrency. So these cryptocurrencies will be transferred from smart contract balance to A's account. Now, there is something very, I think, a little bit complicated to explain currently, because currently we are just progressing towards our blockchain codes. For now, just assume that smart contract is acting as a bank where some cryptocurrency is deposited. If this condition will be false, in that case, cryptocurrencies from a smart contract account will be deducted and will be transferred to A. And who has transferred this cryptocurrencies to smart contract account? And that is actually being done by B. Okay. And we will see this in more detail in our smart contract module. But for now, I think this makes sense to you also, right? So this is also one of the applications of blockchain. Now let's see the third application of blockchain, that is in international wire transfer. So let's say you want to send some money to one of your friend. Okay, so you went to your bank, sender bank, and you want to transfer some money to your friend. But in order to transfer this money to your friend, which let's say lives in USA, let's say you are living in India and you want to transfer this money to USA. This transfer of money cannot be directly done to USA. Means if this is a Bank of India, you cannot transfer this money directly to USA. So let's say if this is our bank in USA, this is our receiver bank because your friend is in USA, you cannot transfer this money directly to this bank. There will be so many banks in the middle of this change between the sender bank and between the receiver bank. Now the problem with this approach is you have to pay a huge amount of commission to these banks in order to do an international transaction. So let's say, and this international transaction fees can be around 10 to 25%. Just it can be 10 to 25%. So let's say if you are sending $1,000 to your friend, for example, $1,000 to your friend, in that case, if the percentage is, let's say, 10%, then $100 will be deducted and your friend will only receive $900. And the reason is because there are so many banks involved here, so they charge some commission. Now this is a very heavy commission, right? Now, if you are going to use blockchain in this case, and one more thing, that this process can be a slow process. It can take 2 or 3 days. Definitely it can be less than that, but it can take up to 7 days also, 7 to 10 days also, because let's say there are banks that are involved between these two banks. They are slow. They are working very slowly. In that case, definitely your transaction will take a huge amount of time. And then your friend, let's say, might receive the money after 10 days of the transactions. Now, this is a very slow process, right? So what you can do is, instead of going like this, what you can do is you can do transaction on blockchain. Now, transactions on blockchain are very fast. took around, let's say you are doing some international transaction, it will take around some minutes and your transaction will be done. And top of that, that transaction fees will be very less. So that's also one of the beauty of blockchain. So we have cryptocurrencies, which we will discuss in much more detail in our cryptocurrency module. So cryptocurrencies, these cryptocurrencies you can transfer from one place to another in so much time, like in less time and in so much less amount of transaction fees. Now let us look at fourth application of blockchain, that is in healthcare system. So normally, let's say if there are two hospitals in city A and city B, okay, and let's say you are born in city A, so all of your medical history is actually stored in the database of city A, right? So since you are born in city A, so all your medical history documents, each and everything is actually stored in the database of your city A hospital, right? It can happen. Now, the problem in this approach is that, let's say you went to city B for some work, okay, and you met with an accident. Now in that case, what will happen? In that case, city B does not have your medical history. Now, in order to fetch your medical history, they need to call your parents, or let's say they have to talk to different hospitals, because they do not know you. Might definitely, they will not call to hospitals until they will call to your family, right? So your family will then go to the hospital of city A, and then they will fetch your records, medical history, and then they will provide to city B, right? Because you can have different type of diseases. Let's say you might have some sugar or some diabetes, or let's say you have some life-threatening type of disease. Now, in that case, city B needs to check your medical history before doing any type of procedure, or it might be too late for you to survive from that accident, right? So this is a problematic thing, right? So with the help of blockchain, what we can do is we can share this data. Definitely do not think that blockchain is a centralized database here. This is just for representation. What you can do is you can share your information, your medical history on the blockchain, and you can provide access to anyone who wants to have a look on that data. So let's say you have a key and you have logged that key on the blockchain, and the beauty of blockchain is that once your data is there, it is there, so it will not be erased or manipulated. It will always be there. And let's say in the case of prices, you can transfer your keys to let's say in this case city B, and city B then can go and unlock your medical history documents and can see your data and can provide you a good I will say good treatment, right? So that you can recover fast. So this is also one of the applications of blockchain, and this is also getting so much, I will say, popular, and I think in near future we are going to see this a lot. Okay, so we discussed 4 applications of blockchain, right? In the international wire system, healthcare system, smart contracts, and product tracking, right? But definitely there are various other applications of blockchain, and now this is your homework. Okay, you have to comment below and you have to tell me what are other applications of blockchain. Okay, you have to tell me like what other places blockchain can be used, and let's other also know that what are the other applications of blockchain, and I will be waiting for your homework, so please do not forget to do that. Okay, now let's talk about hashing algorithm, because this is the term you are going to see a lot, you will hear a lot when it comes to blockchain. So let's talk about this. What is a hashing algorithm? So if I will show you a block of the blockchain, this is how a block of the blockchain looks like. So we can see that these are the different blocks connected with each other, and this single block looks something like this. Definitely there are various other fields also, but for demo purposes I am considering 4 fields for now. That is block number, like at which number this block is present. So if you will see that in this case, this is block number 1, block number 2, block number 3. Then we have data. Data means transactions. So let's say if A is doing some transaction to B, that transaction will be noted here. If C is doing some transaction to D, that transaction will be noted here. So each and every data is present in this data field. Then we have this previous hash, which we will talk in our upcoming slides. And then we have this hash. Okay, now this is very important. What is this hash all about? Right, 000, some alphanumeric characters you can see on your screen, but what is the meaning of this alphanumeric characters? So this hash that you're seeing here is actually a unique identifier to this block of the blockchain. Okay, so this is a unique identifier to this block of the blockchain. What do I mean by that? So every human being has a fingerprint, right? And this fingerprint is a unique fingerprint. So no two human beings can have a same type of fingerprint. Okay, and now this is according to science. Okay, so just don't believe, if you do not believe me, just search on it and you will see a lot of scientific researches on this, that no human being can have identical thumb impressions, or impressions of your fingers and all. And the same thing happens in case of a block of the blockchain. So this hash act as a unique identifier to this block of the blockchain. So let's say it is like giving a name to a block. Okay, so this is like a name given to this block, and with the help of this name I can identify this block. Now why do we need this identifier? You will understand in our upcoming slides, in our upcoming videos, so just don't worry about it. So this hash is acting as a fingerprint to this block. Okay, so this hash is acting as a fingerprint to this block. And how this hash is actually being generated, like how do we get this hash? So for hashing, what we use is a hashing algorithm. So this SHA-256 is a hashing algorithm. We have other hashing algorithms also, like we have KCAC-256, we have SHA-512, ND5. There are various hashing algorithms, but in case of blockchain, most of the time we use SHA-256 algorithm. Okay. Now, when we give some input to this SHA-256 algorithm, that input can be in document, audio, video, in any form. This SHA-256 algorithm convert this document, audio, video, etc., anything, in a 64-digit hexadecimal characters. Okay, so if you will calculate, there are 64 characters here. Okay, and you have to trust me on this, or you can read this also. It's up to you. And why it is called SHA-256? Because there are 64 hexadecimal characters. One hexadecimal character is of 4 bits. And that's how we have this 256 bits. Okay, so one hexadecimal character is of 4 bits, and each character is of since there are 64 characters, so 64 into 4, we have 256 bits. Okay, what are hexadecimal characters? Just search on Google, you will easily find hexadecimal characters, just like a number system, right? Like we have a decimal number system from 0 to 9. In the same way, we have hexadecimal number from 0 to F. Okay, that's why you are seeing these letters coming up here. Okay. Now, in case of a blockchain, what are the inputs? Because as we have seen, right, these are the inputs to this SHA-256 algorithm, and that's how this is actually being, generated. Now, in case of blockchain, what are the inputs? So in case of blockchain, these different fields that you are seeing on the screen act as a input, and these inputs are given to this SHA-256 algorithm, and this SHA-256 algorithm then produces this hash. And remember one thing, this is a very important point. SHA-256 algorithm always and always produce a unique identifier, unique hash. Okay, there will be never a time where for two different input you will have a same hash. Okay, remember this thing. Now let me demonstrate you this SHA-256 algorithm, because I know many of you might still be confused. Let me demonstrate this in real life. So here we are on this site. Just type SHA-256 generator and you will be on this site. And in this site, you can clearly see that we have an input and this is our output. Let's say I have written something. Let's say I have written H. So as you can see that as I have written this H, you can see that we have a hash of 64 hexadecimal characters. And one important point that you should notice here is a small change in the hash, not in the hash, actually, in a small change in the input will completely change this hash. There will be a totally random hash which has nothing to do with this H. Like, let me show you. Let's say I have written A here. Now you can see that this hash generated in the previous case, these two hashes are completely different from each other. Now, this is one of the beauty of SHA-256 algorithm, because this is very important characteristics of a good hashing algorithm. Like for each and every input, we should have a entirely different hash. Okay. So let's say if I have written anything, I am writing anything here. You can see that never ever it is producing more than 64 hexadecimal characters whatsoever I'm putting here. Okay, so this is how SHA-256 algorithm works. And in case of blockchain, as I said, we have the different input fields, and we use these input fields as an input to this SHA-256 algorithm. Now, definitely you might be thinking like why I'm using 9 characters here. This is just for demonstration purpose, because if I am going to write the 64 hexadecimal character, it will be a large digit, right? So for demonstration purpose, I'm going to use 9 characters only. But in actuality, remember SHA-256 produces 64 hexadecimal characters. Now let's talk about some characteristics of this hashing algorithm, because I know this is also one of the important question, like not question, doubts, like how, like what are, what make this SHA-256 algorithm a good algorithm? Why we are using SHA-256 algorithm? Why we are not using any other algorithm? So let's talk about some of the good characteristics of a hashing algorithm. So the 5 requirements that every hashing algorithm must fulfill. First is that it should always be one way. Means, let's say you are giving a data to this SHA-256 algorithm, and this data is now converted into a encrypted data, because the hash that you are seeing on your screen are actually working as an encrypted data, right? I'm writing HA or something here, and it is producing some encrypted data of that. Now, the good hashing algorithm will never give back the data. Means you can go from this data point to encrypted data point. Means you can go from this to this, but you cannot go back from encrypted to this. Means you can generate let's say a hash from a given input, but from a given hash you cannot generate the same input back. So this is one of the key requirement of a hashing algorithm. Another thing is it is deterministic. Deterministic means that it always, for every single input, it is going to give you the exact hash. Means, let's say for 1 2 3, it is producing some hash DEF. So it will always and always produce this DEF whatsoever be the case if the inputs are fixed. Means you will never see a situation that for a single input you are having 2 different hashes. Okay, you will always have the same hash when you are going to give the same input. So this is also one of the beauty of this hashing algorithms. So ABC, so let's say, yeah, I have given example also. ABC produces the hash of 845. So always and always ABC will produce the same hash. It will never produce 849 or 948. Okay. Third thing is it should be fast. Definitely it should be fast. Otherwise it will take, if it is taking a lot of time just for producing these hashes, then it will be a time taking process, right? Now, what do I mean by withstand collision? Means it should be very difficult. It should be very difficult. I think I will say exponentially difficult to have the same hash for the 2 input. Means it should never happen. The probability of happening that we have 2 different input, and these 2 inputs are producing the same hash, it should be very, very, very less. It should never happen that 2 inputs are actually producing the same hash. Okay, so it should withstand collisions. And last, that there should be a avalanche effect. Avalanche effect, what do I mean by that? As we have seen in our SHA-256 generator, right, calculator, you might have seen that even I am changing a small alphabet there is a complete new hash. For H we were having a different hash, for HA we were having a complete new hash, right? Now that is what we call avalanche effect. So that each and every time you are, even if you are making a single change in the input, you will get a completely different hash. Okay. Hi. Now in this video we are going to see how actually blockchain is formed using hashing algorithm. So in the previous video we talked about hashing algorithm, right? SHA-256 hashing algorithm, where we discussed that for each block we have a unique hash, right? Now let us understand how a chain is formed between 2 blocks of the blockchain. So let's say we have 2 blocks here, this block in green and this block in blue. So this is block number 1 and this is block number 2, right? And this block has its hash of this, like 000D8C42, and this block is having a hash of 0003453A459, right? So this is the identity of this block and this is the identity of this block. Now how these 2 blocks will be linked together so that they can form a blockchain, right? Because as we discussed in our blockchain video, that blockchain is nothing but it is a chain of blocks. So now we have 2 blocks. Let's see how they are connected with each other. So now let us see how these 2 blocks are linked together. So here you can also see that we have one more field, that is a previous hash in block number 1 as well as in block number 2. For block number 1 previous hash is 00. Okay, why? Because this is called a genesis block. Since this is the first block of our blockchain, so we call this block as a genesis block, and in this previous hash is nothing. Okay, but in this case, in block number 2, this block number 2 also have this previous hash field. Now this previous hash of this block number 2 will consist of the hash of this block number 1. So if you will see, it is 0000 D8C42, and this is also 000 D8C42. So with the help of this hash of block number 1, this block number 2 is able to identify block number 1 by having the hash of block number 1 in its previous hash. Okay, and I think this makes sense because this is a unique identity to this block. So this is like this block number 2 is calling this block, and that's why we have this link. Now let's say if a block number 3 is created, in that case, this block number 3 will have a previous hash equal to the hash of block number 2, and with the help of which block number 3 will be able to identify block number 2, and there will be a link between these two blocks. And this is how a blockchain is formed in a blockchain system, I will say. And this is our genesis block, as I said. Hi, now in this video we are going to talk about why blockchain is immutable. Definitely when we discussed about the definition of blockchain, we discussed that blockchain is a distributed immutable ledger, right? Now let us see why blockchain is immutable with the help of an example. So let's say this is you, okay, who wants to buy a house, okay? Now in order to buy this house, definitely you require money, as well as you need to sign a contract with the party with whom you are buying this house, right? So let's say this house is belonging to party B, and now you want to buy this house from this party B, so you need to sign a contract, right? And now you will take this sales deed contract and present it to the government. So you will go to the government officials saying that, okay, this is a contract that I have signed with party B, and now this house title belongs to me. Title means for now you can think of it as the name of this house. For now, just assume that title is the name of the house, and you are saying that, okay, now this house belongs to me since I have given party B this money, and now I have all the documentations and everything. So now this house belongs to me. So you will present these facts to the these contract, not facts actually, you will present this contract to the government institution. Now after receiving this information, the government institution will record all the important information over a file, over a register, or they can also use a centralized database, means they can also use computer in order to store all the information related to your contract, related to your title of the house. Now the problem with this approach is that anyone can change record of this register, right? Because this register is nothing but government institution has just written some data on a paper. So now anybody can change the record in this register. If we talk about centralized database, definitely in centralized database, since database is centralized in nature, any hacker can also make changes to this centralized database, or the government of or if the government is corrupted, in that case they can also make changes to this centralized database, and once this is done, you will be in trouble, right? Because this file is actually stating that this house belongs to you. But if someone is changing the facts, someone is changing the information in this file, in that case this house will not belong to you. And there are so many cases that has happened before, and still these type of things occur where the person who has bought this house has no authority over the house just because there was some mistakes given or there was some changes in the government documentation. So you do not want to lead up in such type of trouble, right? Because if you will be in such type of situation, then your situation will be like this, right? Because you have invested so much money in your house. So in order to prevent from this situation, what we can do is we can use blockchain, which is an immutable ledger. So let's say this transaction, this data that you are buying this house is stored on blockchain. So this data is stored on, let's say, block C, okay? And now someone hacked this block C, because we are assuming that, okay, blockchain can also be hacked. Someone is trying to manipulate the data, means manipulate the data that this house belongs to you in this block C. So this hacker is trying to manipulate this block C, since this block C is containing the data that the house belongs to you. Now, if the hacker will try to hack this block, trying to change this block data, the blocks that are after C will also get affected. Why? It's very simple. If you have watched my previous video where I discussed that the new block consists of the hash of the previous block, right? So this D will consist of the hash of block C in its previous hash field. Similarly for E and F, right? So once this block will get corrupted, the data in D, E, F will also get corrupted, right? And if you do not remember, let me show you the presentation from our previous slide. So here you can see that this is our block number. Let's assume that this is our block number D. This is our block number C. Someone is trying to change the data in block number C, and if let's say someone is trying to change the data in block number C, then the hash of this block will change. Why? Because these different fields are being used in order to get this hash, right? And this also we have discussed in the SHA-256 algorithm video. So this hash will get changed, and since this hash will get changed, this block number 2, that is our D block, is also having the hash of this block, right? So if this will change, then this will change, and since this will change, the hash of this will change, and since the hash here will change, then definitely again you can see the domino effect here, right? Now the previous hash of this will change and the hash will change. So in this way, all the blocks that are coming after C will get changed. And by this, the network, the distributed network of blockchain will know that there is some issue with the blockchain. As we discussed also this, right? That our blockchain is a distributed immutable ledger. So if we are assuming that this is our blockchain, okay, this is our P2P network of blockchain. We will discuss about P2P network in our upcoming video. But for now, this is our P2P network, right? And here you can see that this block is getting affected. Now, once this block will get affected, the people, this block will also get affected, and the people who has the correct copy of the blockchain will get to know that there are some issue with the blockchain of A, and what they will do is they will correct these changes because they have the correct copy of the blockchain. Okay, and this is why blockchain is immutable in nature, right? So this is why blockchain is immutable in nature, because if you are going to change any block, this change in one block will affect the rest of the blocks. Now, some of you might be thinking that what will happen if someone tries to change the first block, right? And we will talk about this case also in our upcoming videos, so don't worry about it. And yeah, this first and last block also, right? So don't worry about it. We are going to talk about this in our upcoming video because this is a concept which is not the part of this video. But now, for now, you must have understood if someone tries to change the data of middle of the blocks or the blocks that are coming in between some blocks, in that case, how immutability will take place in blockchain. Hi, now in this video, we are going to talk about P2P network. Now, this is a term that I am using a lot. So let us understand P2P network. And in order to understand P2P network, let us first understand what is a centralized network and how it works. Okay. So in a centralized network, we have two parties. One is server and another one are clients. So as the name suggests by the server is the one who serves the client. Okay. And this server is actually holding all the data. So you can understand this with the help of an example that YouTube is a company that has its own server, which on this server, all the videos are stored. Okay. And when someone wants that video, when someone wants that data, they request from YouTube server, and then YouTube server provide them with that data. Now, in the case of this, like if you will see this diagram, this picture that is appearing on your screen. Now, in case of this, as you can see that this server is holding some data, right? And let's say this client wants this data from this server. Okay. So what this client will do, this client will actually request from this server that, okay, I need this data that you are having. And then server will respond to this client with that data. Now, this is how a centralized network works. Okay, let's say if this client wants some data, it will request from this server, and then the server will respond with the data that the client has requested. And in the same way, other clients also can do that. Now, the problem with this approach is that if someone hacks the server, then this data will get manipulated, right? Because someone is hacking the server, and let's say the hacker made some changes to the data. Now, in this case, if a client requests data from the server, in that case, the client will have this manipulated data, right? So the data will not be a right data. So the client will be getting some manipulated data. So this type of situation we do not want, right? Some of the, let's say it is something very important to us. It is a very important file, and now we are getting some corrupted data just because a hacker has hacked this particular server. So what we can do is we can use a P2P network. Now, what is a P2P network? So in a P2P network, we have peers. Okay, P stands for peers. So this is a peer-to-peer network. Now in a peer-to-peer network, there is no server, there is no client. Okay, everyone is at equal position. So anyone in this whole network can share data, and anyone from this whole network can request for a data. Okay, so each and everyone is at same level. There is no server, there is no client. Each of them are, or you can think like this also, that each of them are server and each of them are clients also. Okay, so let's say, and now A wants that data from B. So A can request that data from B, and in, let's say, another case that E wants the data from A. So E can also request the data from A, right? So in this way, P2P network works, right? It's a very simple process. Anyone from this P2P network can request data. Anyone from this network can produce data. So there is no client server. There is nothing like that. Okay, each and everyone are at equal level. Okay, so this is what P2P network looks like, and this is how blockchain network is formed, where each and everyone is having the exact copy of the blockchain, and each of these people can talk to each other via P2P network. Now let us also see that how P2P network, distributed P2P network, works in blockchain also. Okay, so this is our P2P network in a blockchain, and let's say a block is added at A's end. Okay, so A has created a block. How it is created we will talk about in our upcoming videos, but let's say A has created this block. Okay, now once A has created this block, A will send this information to its peers, okay, which are B, E, and F in this case. So A will transfer this information to B, E, and F, saying that, okay, I have created this block. Now once this is done, B, E, and F will add this block after verifying and validating whether the block is correct or not. If the block is correct, then they will add this block to their blockchain. Now after this, B, E, and F will transfer the same information to C, saying that, okay, we have a block that is created by A. Can you check whether it is right or not? So C will take this block. He will also verify and validate this block. And if this block is correct, then C will also add this block to its blockchain. And this is how P2P network works in a blockchain, right? Because each and everyone can talk to each other. Each and everyone are at equal level. So each people can talk to each other in a P2P network. Now you must be thinking, why do we need a distributed P2P network in blockchain? So as we have discussed in our Immutable Ledger video, right? If someone tries to manipulate a data, so all the data will get corrupted, right? All the blocks that are coming after that particular block will get corrupted. So we have discussed about this, right? And to convey this information, what we need is a P2P network. Okay, I have this text here, right? So I have removed that. So now let's say if a block is get corrupted in one of the blockchain. Okay, so let's say a hacker has hacked a system and now he has manipulated this block of the blockchain. Now this information will be transferred via P2P network only. Okay, and you can also see that once this block is get corrupted, all the remaining blocks or the blocks that are coming after this block also get corrupted because of the hashing thing, right? Now this information will be transferred to B, E, and F. B, E, and F will check, okay, now the block that is the block that A is having and the blocks that we are having are different blocks. So what they will do is, instead of adding this block to their blockchain, they will correct the block of A, saying that, A, you are having a wrong block, let me correct this block. Okay, so this is how P2P network is very essential in order to maintain this immutability in our blockchain network. Okay, so I hope now in this video we are going to talk about a very interesting topic, that is blockchain mining. Now this is one of the most interesting topic of mine also. Let us see this. And in this video we are going to just see an overview. In our upcoming videos we are going to see a detailed video about blockchain mining, like how actually it is done. But for now, let us see an overview, and trust me, you will love it. Okay, so let's say someone is doing, or let's say you are doing some Bitcoin transaction. Okay, so you are doing some Bitcoin transaction. Now this Bitcoin transaction will go to a pool of miners. Okay, we have pool of miners here. Pool, when I'm saying pool, means there are so many miners present in our blockchain network. Okay, so once they will see that, okay, our transaction is done, they will take this transaction and they will try to add this transaction on a block of the blockchain. Okay, and a block can have multiple transaction, thousands of transaction, or depends upon blockchain to blockchain. But let's say for simplicity that in this blockchain a block can have only one transaction, but a block of a blockchain can have multiple. In for the simplicity of this video, I'm going to say that a block can consist of only one transaction. So once the miner will see that, okay, a transaction is done, so they will see this transaction and they will start solving a mathematical problem. Why they will solve this mathematical problem? They will start solving this mathematical problem so that they can add this transaction on the blockchain. Okay, so that's why they will start solving the mathematical problem. Now the miner who will solve this mathematical problem first, okay, because there are so many miners, and let's say one of these miners, let's say this miner, has solved this mathematical problem first. Now once he will solve this mathematical problem first, he will be able to create a block having this transaction. Okay, and after this process, means after this block is created, this block will be verified and validated by other set of miners. Other set means that this miner will not be a part of this verification and validation, but all the other miners will start verifying and validating this block, whether the block created by this miner is a correct block or not. Okay, whether this block is not this block is a malicious block or not. Okay, if this block is a malicious block, then they will reject this block and they will not add this block to their blockchain, and hence again the process of mathematical problem will start. Means again the miners will start solving the mathematical problem so that they can add this transaction. But if this block is correct, if this block has no issues, in that case what they will do, they will add this block to the blockchain, to their blockchain. We have seen this also in our distributed video, right, where we talked about blockchain. They will add this block to their blockchain, and the miner who has solved this mathematical problem first will be rewarded with some cryptocurrencies. Okay, and this block will be added to the blockchain, and this is how the whole mining process works. Now you must be having question, right, like who can be the miner? Anybody can be the miner. Okay, you just need to install a software. Let's say if we talk about blockchain Bitcoin client, once you will install this software, you will have an option in order to you will have an option to be a miner there. Okay, and let me tell you one thing more, that verification and validation is not just done by the miners. Verification and validation is also done by all the nodes. Okay, there are other systems also apart from miner who are just doing transactions, who are just part of that blockchain network. They can also verify and validate your transaction. So only miners are not verifying and validating. Other nodes that are connected to this blockchain network also verify and validate this transaction. Okay, this block, what do I mean by that? Okay, so this is how blockchain network is, this is how actually blockchain mining is done, not blockchain network, but this is how blockchain mining is done. Now what is this mathematical problem? This can also be one of your question, and don't worry, we are going to talk about this in our upcoming videos, where I'm going to talk about nonce, which is a very important topic, which is a topic that you will face a lot in your interviews also. So we will discuss about that in our nonce video. But for now, I hope this is very much clear what is blockchain mining and how it is done. Hi, now let us talk about a very important problem in our distributed network, that is Byzantine's general problem. Now in a Byzantine general's problem, let us understand this with the help of a story. Okay, this is very important problem, you must understand this problem. So this is our Byzantine kingdom, okay, a beautiful Byzantine kingdom, and there are 4 army generals of some different kingdom. Okay, and these are these 4 army generals belong to the same kingdom, and they want to attack on this Byzantine. Okay, they want to attack on this Byzantine, they want to take over this kingdom. Now in order to attack on this Byzantine, and in order to win this kingdom, because Byzantine definitely will also have its army, right? So in order to win from Byzantine, they need to be attacking at the same time. Means majority of these generals need to attack at the same time in order to win over Byzantine. Okay. And we are assuming that all these army generals are at different locations. So let's say this army general with its army is at north, this is at south, west and east. Okay, so all these army generals with their army are at different location. Now definitely, since they have to attack at the same time, they need to communicate with each other, right? Then only they can attack at the same time when they have the information that okay, this army general is going to attack. Now we can also planning of let's plan to attack, right? So they need to communicate with each other, but the problem is that they are at different places. So what they will do, so they will send their messenger saying that whether to attack at this point of time or whether not to attack at this point of time. So let's say this army general, okay, send this information to the other rest of the army generals that, okay, this is the best time to attack on Byzantine. I think this is the best time. Let us attack on Byzantine. Now, the same thing will be done by the rest of the army generals. They will also send their messengers. Now, this army general has sent this information. Okay, this is the best time. Let us attack on Byzantine kingdom. Okay, other kingdoms will also other army generals will also send this information, and this army general will also send this information via their messenger that okay, let us attack on Byzantine. And this is an ideal situation, and if this will happen, then definitely they will win Byzantine kingdom, because now they are attacking at the same time. Majority of them are attacking at the same time, so definitely they are going to win Byzantine kingdom, right? But what will happen if one of these army generals is a traitor, right? This can also happen that this is a traitor. Now will be a problematic situation. Why? Because this traitor will give wrong information, right? So let's say that all these army generals are saying that to attack is the best, this is the best time to attack on Byzantine, because they will win over Byzantine if they will attack at the same time, at this particular time. But since this army general is a traitor, he is sending false information to the rest of the generals that okay, no, this is not the best time to attack. Let's not attack at this point of time, because he's a traitor. Even though this is the best time to attack, he will say that let's do not attack at this point of time. So what will happen in this case? Now, in this case, these army generals will go for the majority of the votes. Okay, so this army general will see that okay, what is in majority, to attack or not to attack, and he will see that okay, this army general is saying to attack, this army general is saying to attack. So, and this is the only army general who is saying that this is not the best time to attack. So definitely he will go with these two army generals. In the same way, he will also see that okay, this is saying to attack, this is saying to attack, but this is saying not to attack. So let's go with these two people, since these two people are in majority. In the same way, he will see that these two people are in majority and they will attack and they will win over Byzantine once again. Now, why I am telling you this story? Because this story is, if you will relate it to our distributed network, where distributed network are present at different location and they need to verify a particular set of information. Now, in order to verify a particular set of information, these distributed system depends on the majority. And same goes for our blockchain network. Blockchain network is also a distributed P2P network, right? We have seen in our previous video, right? So in a distributed P2P network, definitely there can be some traitors, there can be some hackers who will send you some wrong information. So in that case, our distributed P2P network totally depends upon the majority. If the majority of the people are saying something, we are going to assume that that is correct. If majority are saying something that majority are saying that okay, this is not a correct information, we are going to assume that this is the correct, means we are going to assume that the majority is correct in this regard also. So this is how distributed P2P network works. But now definitely there is one problem. Now you must be having this question in your mind: what if majority of the people are hackers? What will happen in that case? Like in this case, definitely if you will see, 3/4 of the people, that is 75% of the people are correct, right? 75% of the people are the right people. but only 1/4 means this traitor is the person who was sending some wrong information. So in this case, this is correct. But what will happen if 50% are seeing something and 50% are seeing something? What will happen in that case? In that case, your distributed system will fail. Yes, this is the truth. Your distributed system will fail. But the probability of happening that is very low. The probability of happening that is very low, because just use your common sense right here, that how there can be 50% hackers, right? How, let's say if there are lakhs of people connected in a blockchain network, how there can be 50,000 hackers? This is not a possibility, right? Only I think 10,000 of the people will be hackers, or let's say 1,000 people will be hackers, right? We cannot say that 50,000 people can be hackers, because the probability of having is low. Definitely it can happen in future, but the probability of happening is very low, right? So now I hope you understand what is Byzantine general's problem, right? In correspondence to our distributed computing, where distributed computers are all over the network. So in order to verify and validate a particular information, they need to depend upon the majority. Okay, and this is the only solution to our Byzantine general's problem. So now in this video, we are going to talk about consensus protocol. So let's start. Before talking about consensus protocol, let us understand the concepts that we have learned so far. So we have talked about hashing algorithm and its importance in order to create a blockchain, immutable ledger, which protects our blockchain from hackers, miners who actually verify, validate, create our blocks in the blockchain, and then distributed P2P network, with the help of which we distribute our block all over the network, right? Now, what is the importance of consensus protocol? Let us understand this. Consensus protocol helps us in two ways. First, in order to prevent attacks, like if some hacker is trying to attack our blockchain, in that case it helps us. And then in competing chain problem, which we will see in the next video. In this video, we are going to talk about how it prevents attacks. So there are various types of consensus protocol. You might have heard these names: proof of work, proof of stake, and there are others also like proof of concept, proof of history. There are so many other consensus protocol. But in this video, we are going to mainly talk about our proof of work consensus protocol. Okay, so let us understand this. So as we have discussed in our immutable ledger video, if a hacker tries to manipulate any central block or any middle block of a blockchain, then all the blocks after that block will get affected, right? And by this, these other nodes that are part of this blockchain network will be able to identify that there is some mistake with this A's blockchain, and they will correct it. But what will happen if A is a hacker who is trying to add a malicious block at the end of our blockchain? Now, in this case, what will happen? Because now there are no other blocks, right? After this, there are no other blocks with the help of which we can say that, okay, this block is not a right one, or this block is not a correct one. Because B, C, E, and F, you can clearly see that they have only 4 blocks, while A has added this corrupted block. But B, C, E, F do not know whether this block is a correct block or not. Now, how we can prevent from this type of situation? Now, in order to prevent from this type of situation, what we have is a consensus protocol. So before adding this block, this malicious block to their blockchain, like BCEF in their blockchain, a consensus protocol is run. This consensus protocol makes sure that the block that is being created by A is correct or not. So there is an algorithm. So you can see that this is some part of that algorithm. There are definitely, it is a 3 to 4 documents long algorithm, but I'm just showing you some part of it. So this is a consensus protocol that runs whenever a new block is added to the blockchain. In this consensus protocol, the person who is adding a block, he has to present a proof. He has to present a proof that the block that I am adding is a correct block. And that's why this algorithm is also known as proof of work algorithm in case of Bitcoin, because the person who is adding this block, he has to present a proof by stating that, okay, I have worked on this block, I have worked on this block in order to add it. And to what is that proof? Like, let me tell you, that proof is like the amount of energy this A is consuming in order to create this block. Because in a proof of work algorithm, a lot of energy is required, a lot of power is required. And why this is so, we will see in our upcoming videos, but a lot of energy is required in order to create this block. So A will present a proof that, okay, I have consumed this amount of energy, I have consumed this amount of, power in order to create this block. And definitely there are other checks also, which will also run in order to verify that the block that is being created by A is a correct block or not. Now, once this is done, then and then only this block will be added to other nodes of the blockchain. And then only A will be rewarded with a cryptocurrency. If this consensus protocol, this proof of work protocol finds out that this block added by A is not a correct block, in that case, A will not be rewarded with any cryptocurrency and A will be at loss because A has to consume huge amount of energy. Let's say he has consumed huge amount of energy in order to create this malicious block. Then he has to pay a huge amount of electricity bill. So A will be at loss. So this is how our consensus protocol works in order to have correct non-malicious block. Okay, so if a block is added at the end of the blockchain also, then also we have mechanism to prevent from a block which is malicious in nature. Now there can be a question that verification and validation, like since this adding of blockchain, this adding of a block in a blockchain takes a lot of time. Okay, it takes around an average of 10 minutes, but does verification and validation also take that amount of time? Because E, B, C, E, F will also verify and validate this block, right? Definitely consensus protocol will run, but also B, C, F will also take measures in order to verify and validate this block. So is this verification and validation, is this a time-taking process? So no, this is not a time-taking process. Creation of a block is a time-taking process, but verification and validation is a very easy process. It's like you are giving a Rubik's cube, like I have given you a problem, you have to solve this Rubik's cube, and anyone, right? Anyone from the network can identify that whether this Rubik's cube has been solved in a correct way or not, right? You can just look at this Rubik's cube, you can turn around and you can see that, okay, this Rubik's cube has been solved in a correct way. But to solve this Rubik's cube is actually time-taking process, and solving this Rubik's cube is like creating a block. And to identify whether this Rubik's cube is a correct one or not, whether the Rubik's cube has been solved or not, is verification and validation, which is a very easy process as solving a Rubik's cube. Hi. Welcome to the second video of consensus protocol. In this consensus protocol video, we are going to talk about the other use of consensus protocol. So in the previous video, we talked about prevent attacks, how consensus protocol help us in preventing attacks from the hackers. Now we are going to talk about competing chain problem. Let us understand this with the help of an example. So this is our blockchain network, right? And let us say A as well as C created a block at the same time. This type of thing can happen. A can pick a transaction. Okay. So to pick up a transaction, there is a place called Mempool, which we are going to talk about in our upcoming videos. But for now, Mempool is an area from where A has picked a transaction. C has also picked the transactions from this Mempool, and they started solving a mathematical problem. And now they have solved this mathematical problem at the same time. This type of thing can happen because all these people are at different part of the world and they are competing with each other, right? So it may happen that A has solved a mathematical problem at the same time when C has solved the mathematical problem. So now A is having a different block and C is also having a different block, right? Now, what will happen after this? After this, A will and C will transfer this information to its nearest nodes, right? We say these system as nodes. In blockchain terminology, we call these systems as nodes, or you can say system also, but we call them as nodes in a blockchain network. So C will transfer this information to B that, okay, I have created a block. A will transfer this information to F and E that, okay, I have created this orange block. Okay, now like why I am assuming that C is transferring this information to B and not to E and F, we are assuming here that for C, B is the closest node, and for A, F and E are the closest node. Okay, so that's why A is able to transfer this information first to F and E, and C is able to transfer this information first to B since C is close to B. Okay, so this is a assumption we are taking here. Now, once this transfer of information will be done, then what will happen? F and E will create a block at their own end, means they will verify and validate this block, and they will see that, okay, this block is good, so they will add this block to their blockchain. In the same way, B will also verify and validate the block of C, and it will say, okay, it is good, so he will also add this block to its blockchain. Okay, so this is how our blockchain network will look like. Now the problem will arise is when B and C will transfer this information that they have a block, purple color block, and A, E, and F should add this block to their blockchain, and AEF will also do the same. They will also transfer this information that they have created a block, they have added this block, orange block, and they will want that B and C should add this block to their blockchain. So information will look something like this, where B is transferring this information to A and C is transferring this information to E and F, where E and F are transferring this same information to C, B, and all. This is how the transfer of information will take place, and this is not good because now there is a conflict, right? So now which blockchain block should be added? Whether B will add the block of A, E, and F, that is orange block, or whether A, E, and F will add this purple block. Now the question arises, right? Now according to our consensus protocol, whichsoever network will have the longest blockchain, remember, whichsoever network will have the longest blockchain, that blockchain will be adopted, and the blockchain that is having the short blockchain, that blockchain block will be discarded. And you will understand this with the help of an example, so just don't worry. In this case, if you will see, A, E, and F are part of a network, right? Since they are close to each other and they have the same block. So let's say that A, E, and F are the part of a network, and B and C are part of a different network. And we are assuming that each of these systems that are present in our blockchain network have the same power to solve the mathematical problem, right? As we discussed in our mining video, right? That all these people solve a mathematical problem since they are miners. So we are assuming that each of these systems that are present here are having the same power to solve the mathematical problem. Okay. Now, since A, E, and F are a network and they are in majority, so they will have a computational power of solving a mathematical problem of 3, right? Because we are assuming that this having a problem, this has the capability of solving the mathematical problem of 1. This is also having the solving the mathematical problem capability of 1. This is also having 1. This is also having 1. This is also having 1. So the whole network have the capability, like A, E, and F have the capability to solve the mathematical problem of 3, right? In the same way, B and C will have the computational problem to solve that mathematical problem of 2. Okay, so definitely A, E, and F are more powerful in this case, right? So what A, E, and F will do, they will add another block to their blockchain. So in this case, we are assuming that E has created a block, and E has added this block to its blockchain. Now E will transfer this information to A and F, and they will also add this block to their blockchain. Now, in this case, if you will see, which of these network have the longest chain. So you can clearly see that A, E, and F have the longest chain, right? They have 1, 2, 3, 4, 5, 6 blockchains, means 6 blocks in the blockchain, while B and C have only 5 blocks in the blockchain, right? So as we discussed, according to our consensus protocol, we will only consider the longest blockchain, and we will discard the blocks of our small blockchain. Now in this case, since AEF have the longest blockchain, so B and C blocks will be discarded. So the purple block that B and C has created will be discarded. So the transaction that were present in B and C blocks, right, in the purple blocks, they will be again transferred back to the mempool. Okay, mempool is an area where all the transactions are kept. So these transactions that are like these blocks, the transactions that are discarded for now, all the transactions of these discarded block will be again added back to the mempool, so that again mining can be done on them, so that again those transactions can be processed in a block. Okay. So these blocks that you are seeing on your screen, these blocks are actually called orphan block. These are called orphan block, or you can say them as discarded block. Now, once these blocks will be discarded, BC will add the blocks, these orange blocks that are being that are a part of this AENF network. So B and C will add these blocks to their blockchain, so that a consistency among all the people of this blockchain network can be maintained. And these blocks, again, as I said, these blocks will be called as orphan block, and these blocks will be discarded. All the transactions that were present in these discarded blocks will be again added to the mempool, so that again those transactions can be processed by the miners in the next mining process. Okay, and this is how our blockchain network will look like. So just remember, always and always, the longest chain will win. Always the longest chain will win, and the shortest chain, the blockchain that is having the short chain, right, in that case the blocks will be discarded, like as we have seen in this case. Okay, if you're finding it a little bit complicated, just rewind back this video, you will understand it, I guarantee you. Okay, so this is how our network will look like, a beautiful blockchain network. Now let us see some of the important points related to our consensus protocol. So the consensus protocol of blockchain is much better alternative to our Byzantine fault tolerance. What is a Byzantine fault tolerance? As we discussed in our Byzantine generalist problem, right? In our Byzantine general problem, for that general problem, a solution was proposed, and that solution was this Byzantine fault tolerance. And for our Byzantine fault tolerance, the majority of votes that we require is of 66%. Okay, while in case of our consensus protocol, we only need majority of 51%. So our consensus protocol is a much better alternative to our Byzantine fault tolerance, because fault tolerance requires a majority of 66% vote, while our consensus protocol only requires 51% vote. Second, all the transaction in the orphan block will be dropped. As we have seen also, these transactions will again go back to the mempool so that the miners can again solve for it. And the miner that had mined the block, right? If you will remember that C has created that purple block, right? So that purple block was discarded from the blockchain network. So for that, C will not be getting any type of reward, because that block got discarded from the blockchain network by the consensus protocol. So remember this point also. And third point is, for this type of situation, if you might have heard this thing, that for whenever you do a Bitcoin transaction, you must wait for 6 block confirmation. And the reason for this is this only, that there can be conflicts in the blockchain network. So you do not want to be the part of that conflict, right? Let's say A has transferred you some Bitcoin. Okay, now you are thinking that A has done this transaction and now you will be receiving the Bitcoin. But after some time, the block that was having that transaction got discarded from the blockchain network, because that block was the orphan block, right? That block was not a part of the longest chain. So it was discarded from the network. In that case, you will not be getting any like Bitcoin from A, right? So you must wait for 6 block confirmation, and then only you should be happy that okay, now you have received the transaction. But we will talk about like this 6 block confirmation more in our upcoming videos. This is just to give you an overview of this, that why you should wait for 6 block confirmation whenever you are doing any Bitcoin transaction. Hi. Not only in this video we are going to start with what is Bitcoin and why do we need it, but let me remind you that this is the starting of our second module, and that is cryptocurrency. So in the starting only, I told you, right, that we are going to divide our course into 3 modules, and this is the starting of our second module, which we are going to start with what is Bitcoin and why do we need it. So let's start. So we are going to understand the history of Bitcoin. We are going to understand why do we need Bitcoin? What is the problem with our current financial system? Okay, so let's start with this. So all these things started in year 2008, when US economy was very bad. Nearly 9 million people lost their job, and nearly 1.8 million small businesses got closed. And not only this, Wall Street of USA, stock market of USA, you can think of it like that, was on its knees. And the greatest bank, the biggest bank of USA, Lehman Brothers Bank, a $1 billion valuation bank, got closed during this period of time in USA. And you can understand the impact of that situation by this picture, where people were revolting against the government, people were revolting against the banks, because they have lost all their savings, because the people who are just going to retire, they have lost all their retirement money. People who were saving for their child education has lost all their money, child education money. People who are going to buy home, they do not have any money left in order to buy home. So situation was very, very painful at that point of time. Now you must be thinking, why all these things were happening. And the reason for this is banks, the banks of USA. Because of the foolishness of banks, US economy was in such a bad situation. And not only this, the US government was supporting this foolishness of banks, right? US government was supporting these foolishness of banks. And now let us understand what these banks were actually doing. As we all know, banks make profit by lending you money, right? So when they lend you money, they charge interest on it, and that's how they make profit. Now, year 2008 or a year before that, banks started lending money to people who were not capable enough to return back the money. Now you must think why they will do that. Like, what was the reason for doing that? And the reason was simple: greed. According to banks, at that point of time, they thought that if we are lending money to someone, they will repay back. Who is not going to repay back the money? So they were lending money to people or anyone who was just coming to the bank and asking for loans. And these type of loans are called subprime loans. Means when you are lending money to someone who is not capable enough to return you back the money. So since they lended money to people who are not capable enough to return back the money, so after some point of time, bank started going into loss. And that's simple, right? Because they have lended money to people who are not capable enough to return back the money. So they start having losses. Now, to prevent situation like these, the US government start sending money to these banks. Just imagine, because of the foolishness of bank, all these things started, and US government was not punishing them but rewarding them with money. They were lending them money, they were giving them money so that the banks can operate in a proper way. Now you must be thinking, what kind of justice is that? Because of the banks, the USA was in that situation, and US government is supporting that. And yes, that's true. This is the true story. And after this incident, a question was raised. Question that, can we trust our banks? Can we trust our government when it comes to money matters? And the answer was clearly no. And do not think that this was the first mistake, or do not think that this was just a mistake which just happened for the first time. No, this is not something which has happened for the first time. If you will look back to the history, you will see that a lot of time these type of things has happened in the history also, where banks and government were doing something, both of them got greedy or something, and they started manipulating the money situation of that particular country, of that particular area. And at that time only, when situation was so worse, when everything was getting destroyed, at that time only Bitcoin was born. And who is the inventor of Bitcoin? Satoshi Nakamoto. Now nobody knows who Satoshi Nakamoto is, whether he's a person, whether it is a team of person, whether he's a male or a female. Nobody knows anything about Satoshi Nakamoto, but he is the inventor of Bitcoin. Now, what is Bitcoin, right? We have understood what is the problem with our current financial system? It is under the control of our centralized authorities like banks or governments. Now, let us understand what is Bitcoin, how it is different from these banks, these governments, because these are the people who are actually controlling the money. They control the supply of money. They control everything related to money. Let us understand how Bitcoin is different from these money, right? These currencies, actually, fiat currencies, actually. Bitcoin is a decentralized digital currency without a central bank or single administrator that can be sent from user to user on the peer-to-peer Bitcoin network without the need for intermediaries. So if you will look at this Bitcoin, it is a decentralized cryptocurrency. Decentralized, what do I mean by decentralization? It means that nobody is controlling the Bitcoin. There is no single person who has a control over Bitcoin. It is a digital currency. Okay, so currently the currency that we have is a fiat currency, which is controlled by the government. It is a digital currency. It does not require any central bank or any single administrator, and it can be sent over a P2P network. We have talked about a P2P network, right? So it can be sent from one user to another using a P2P network, and it does not require any intermediaries. And it uses a technology called blockchain. And we will see the difference between Bitcoin and blockchain in our upcoming video. So don't worry about it. But for now, blockchain is a technology that is being used by this Bitcoin cryptocurrency. Okay. So this is how for a Bitcoin, like this is how a Bitcoin network looks like, where people are connected with each other. It is a P2P network, right? Where you can see that people are connected with each other and people can transact cryptocurrency with each other. It is a decentralized distributed network. So no anybody who wants to send money and anybody who wants to actually send Bitcoin, receive Bitcoin can happen over this network. Now the next question that you might have in your mind, that if we talk about our fiat currency trust is based on our government. If the government of a country is well, then the fiat currency is also good, right? If the government is in an unstable position, then this fiat currency will be worthless. Okay, and we will see the example of this also in our upcoming videos. But for now, just remember that the trust of our fiat currency is actually based on our government. But when we talk about our Bitcoin, the trust is on these algorithms, these mathematical problems with the help of which this Bitcoin is actually built. And don't worry, you do not need to learn all those mathematical things. There is no mathematical problem to solve. I know many of you must be thinking, oh no, it does it contain math? No, it does not contain math. Just don't worry about it. I'm just trying to tell you here is that Bitcoin uses mathematics. Okay. And yes, if you want to learn more about this financial situation of USA in 2008, how this type of situation arises in USA because of the foolishness of banks, I will recommend you this movie. This is a great movie. All these actors are great actors. So you must watch this movie if you want to learn more about it. And there might be this question also, can this mathematical equation can be wrong or algorithm can be wrong? So let me tell you, like 2 plus 2 is equal to 4, right? It does not matter whether you are doing 2 plus 2 equal 2 plus 2 at in USA, in India, or in Brazil, whatever place you choose. It is always be going to 4, right? In the same way, this mathematical equation, these algorithms that are used in order to build this Bitcoin works 100% all time. Okay. So you are not trusting this, any single person or something. You are actually trusting this equation, this algorithm. And this equation, the beauty of this equation is that it is totally available, open source. You can read about it. So it is not something which is hidden from you. You can go and just type Bitcoin GitHub repository and you can see all the source code available there. Okay, and it is not that it has just started. It is since 2008. A lot of people have already seen this open source code. But if you are thinking, look, I cannot trust this, so just go and type Bitcoin GitHub repository and you can find all the documentations, all the mathematical codes that are being used in order to build this Bitcoin. Okay, and this is how Bitcoin ecosystem looks like. We have a miner who solves the mathematical problem in order to create a block. We have nodes. Nodes means these are the people who are actually transacting, means these are the people who are sending Bitcoin from one person to another. So these are called nodes. Okay, so the system that you see are actually nodes. Okay, I'm just representing it with these person, but definitely these are actually computers only. Your computers or your laptops are actually working as nodes. Those laptops can also work as miners also. Okay, it all depends upon the, like, what do you want to be. So you have to install a software, Bitcoin client software, and then you can choose either to be a miner or you can choose either to be a node. If you have become a node, you will be doing regular transaction, verifying and validation of the blocks. If you will become a miner, then you have to solve the mathematical problem. Then we have large mines, right? And we will talk about these large mines, which are actually using the whole, like a group of miners are there who is solving these mathematical problem in order to create the block. And this is the mining pool, means where group of miners are, these group of miners are working together in order to solve. So these large miners are actually these mining pools only. So they form a mining pool in order to do this, in order to solve this mathematical problem, in order to create the block. So when we talk about blockchain, right? Blockchain is actually a technology. As we have discussed in the definition of blockchain network, right? Not blockchain network, in the definition of blockchain, where we talked about that blockchain is a distributed immutable ledger, right? So this is the definition of blockchain. It is a technology. Well, when we talk about Bitcoin, right? Bitcoin is actually a protocol slash coin. Not only Bitcoin, we have other protocols also like Waves, we have Ethereum, and definitely other protocols are also there. And all these protocols are actually using blockchain as a technology. Okay. Now, what are these protocols? Protocols are basically rules. Like if we talk about in our Web 2 world, in our internet world, we have different set of protocols. We have HTTP protocol, we have TCP/IP protocol, we have UDP protocol. So there are different protocols which defines like how we are going to communicate over the internet, how the file transfer over the internet will take place. So each and everything is actually being done on the internet using these protocols. In the same way, for our Web3 world, for our blockchain world, we have these different set of protocols which defines how people who are connected to the blockchain network are going to communicate with each other, how many cryptocurrencies they will be like, how the how miner will be rewarded with the cryptocurrencies, how miner are going to solve a mathematical problem. All these things are actually rules which are implemented in these protocols. Okay, so for example, you can understand in this way also that technology, when we say blockchain is just like YouTube. Okay, YouTube is a platform, right? YouTube is a technology on which we can have different set of videos. So these protocols that you are seeing, right, these are like your videos. So you can have different varieties of videos, different set of protocols, like different varieties of videos over the YouTube. In the same way, you can have different protocols on this blockchain technology. Now let us see this more with the help of an example. So we are on the site of blockchain.com Explorer. So here you can see that we have different blocks of our Bitcoin blockchain. So this is using our blockchain technology. So let me click on one of the blockchain. So let me show you this. Okay, let me open this in new tab. Let us see this. Okay, so this is how our block of a blockchain looks like. We are going to talk about in great detail about this in our upcoming videos, but for now, just have a look at it. So this is block number 7522253. Okay, and this is the hash. As we discussed, our block consists of a hash. This is the height, this is the miner, which is unknown currently. This is the fee reward, the amount the miners has received after mining this block. So you can see that there are different set of fields, right? And these are all the transactions that are present in our block. So as I said, right, a block can have multiple transactions. So all these things are done via blockchain technology, by using blockchain technology. Now let us have a look at Bitcoin protocol. So this is our Bitcoin protocol. Okay, so this is the GitHub repository, and in this, just search for Bitcoin GitHub. Just type Bitcoin GitHub and you will have this repository, and inside this you will see the rules and regulations are written about the Bitcoin protocol. For Ethereum, it is Ethereum protocol, and for that there can be different set of rules. For Bitcoin, there are different set of rules. Okay, so you can see this. A lot of files are there, right? Like chain.cpp, where each and everything about how transaction will be done on Bitcoin, how people are going to communicate over Bitcoin, each and everything is present in this Bitcoin protocol. Okay, so this is what protocols are all about. I hope you understand about these protocols. Hi, let's talk about Bitcoin's monetary policy. Now, before understanding what is Bitcoin's monetary policy, let us understand what is a monetary policy. So monetary policy is actually something which is controlled by the government of our country. Okay, so let's say if we talk about a government, it is in government control that how much supply of money they want in the country. So government has a machine with the help of which they can print money, right? We all know that. And how much supply of money is needed in a country is actually decided by the government of our country. So the total supply of money is in the hand of our government, right? So they can increase the supply of money, they can decrease the supply of money. It is all under the control of our government, and this is something not very good, and we will see that why it is. But for now, I hope you understand what is a monetary policy. Let us understand Bitcoin's monetary policy. So Bitcoin monetary policy has two things. First, the halving, and another thing is block frequency. Let us understand these one by one. So what is halving? So according to Bitcoin monetary policy, the Bitcoin reward that is given to the miners will get half after every 4 years. So if you will see in 2009, the reward was 50 new Bitcoin. In 2012, it is 25 new Bitcoin. In 2016, it is 12.5 Bitcoin. So for every 4 years, the reward is getting half of the previous year, right? So 50 divided by 2, 25, 25 divided by 2, 12.5, and 12.2, 5 divided by 2 is 6.25. And not only this, the block number are also responsible. So for every 200 and I think 2 lakh now, 2 lakh 10,000 block, 2 lakh 10,000 block, you will see that the Bitcoin reward system, the rewarding system that is given to the miners will get half, right? So it is 2 lakh 10,000, then it is 4 lakh 10,000. So this is like this, okay? And after a particular time, that is after Bitcoin has hit 21 million in total supply, at that point of time, Bitcoin will get exhausted. Means the total supply of our Bitcoin is only 21 million. And it is estimated that by 2140, we will reach at this number when we will have 21 million Bitcoin in our supply, in our market, okay? And after this point of time, there will be no printing of Bitcoin you can think of, or no rewarding of Bitcoin to the miners. Now you must be thinking, if there will be no reward for the miners, right? Because after 21 million, there will be no reward for the miners because no new Bitcoin will be rewarded. So how miner will earn money? Then miner will earn money from our transaction fee. So whenever you do a Bitcoin transaction, apart from these rewards, miners also get a transaction fee commission. Okay, so you provide them a transaction fee. So by that, it is estimated that by that point of time, there will be various people, like there will be many people who will be doing these Bitcoin transaction, and from that transaction fee only the miners will make profit. Okay, now there must be this question also, that why there is a supply cap of 21 million, like why not infinite number of Bitcoins? And the reason for it, like the reason that I can think of, is that by limiting the supply of Bitcoin, we are actually making the value of Bitcoin more. Like gold, silver, these are our precious metals, and these are very rare, right? These are very rare. You cannot print gold in your home. You cannot create a silver in your home. In the same way, the supply cap of Bitcoin is maintaining this rarity thing, so that if the supply of something, just remember this simple economic principle, that if the supply of something is less than the demand, if the supply of something is less than the demand, then the value of that thing increases, right? And in the case of Bitcoin, I think Satoshi was thinking that why not make Bitcoin just like gold, just like our silver, means let Bitcoin be rare on earth, means do not have infinite Bitcoin, just have rare amount of Bitcoin on our earth, okay? And if we do not have a supply, then situation like this can also happen. So this is a $100 trillion note, which is actually being used in Zimbabwe just to buy some loaf of bread. Yes, this is true. So what actually happened in Zimbabwe, you can read about this in much more detail on Wikipedia, that Zimbabwe started printing money at a much faster rate. Means the president of Zimbabwe thought, why not to equally distribute money to all the people so that there is no gap between rich and poor. So he started printing money. So as he started printing money, the supply of money got increased, but the demand was not increasing at that rate as supply. So due to which, since supply was more and demand was not that much, the value of our currency, the value of Zimbabwe currency got decreased, and due to which Zimbabwe needed this $100 trillion note in order to just buy some loaf of bread. And I think this is also one of the reason that Bitcoin has a limit of 21 million cap, so that this type of situation does not happen in the future. And second monetary policy of our Bitcoin is that on an average, it will take 10 minutes to create a new block. Okay, so if you are thinking that you can create a block, in just 1 second or 2 seconds, it is not going to happen. It will take around an average of 10 minutes in order to create a new block. So this is also one of the monetary policy of Bitcoin given in the Bitcoin algorithm. And now who is deciding all these things, right? Who is deciding the block frequency? Who is deciding this halving period? Each and everything is actually being controlled by the Bitcoin algorithm. There is no central authority who is controlling these like this thing. This is all done. This is all done by the Bitcoin algorithm, and this is the beauty of Bitcoin, right? There is no central authority who is controlling all these. This is totally dependent upon how the miners are mining Bitcoin, or how the people are actually using Bitcoin. Hi. Now, in this video, we are going to talk about mining in much more detail. So, in our previous videos, we have talked about mining, right? We have seen a very quick overview of mining. Let me give you a summary of that, so people who haven't watched that, so they can get a overview of that. So in mining, when we do a simple transaction, that transaction go to these pool of miners, and these miners start solving a mathematical problem. The miner who solves this mathematical problem first gets the ability to create a block, okay? And after this block is created, this block goes to these set of miners once again, so that they can verify and validate this block, whether this block is a malicious block or not. And once they find that, okay, this block is not a malicious block, they add this block to their blockchain, and this miner who has solved this mathematical problem first get rewarded, and the block is added to the blockchain. So this was just quick overview of blockchain mining. I hope you have watched the previous video of blockchain mining, where I have discussed about this in much more detail. Now let us understand this mathematical problem. What is this mathematical problem? What miners are actually solving for? Like whether this mathematical problem is a algebraic mathematical problem, calculus mathematical problem, or integration mathematical problem. Just joking. All these things are not there. But yes, let us understand what type of mathematical problem are these miners are actually solving for. Now to understand this, we have to understand a new field that is called nonce. So till now we have talked about block number, data, previous hash, and hash, right? But there is also a new field that is called nonce. Now, if you will see these different fields, right? This block number, we will talk about this hidden field, this data, previous hash. So these were the fields that we give to our SHA-256 algorithm, and this SHA-256 algorithm then produces a hash. Now, if you will look at these fields, block number, data, and previous hash, all these fields are actually fixed fields. What do I mean by fixed? Means the miner, if you are a miner, you cannot change anything inside this block number, right? Because block number is something which is given by the algorithm, right? So if block number 5 is created, after that block number 6 will be created. So you cannot say that, okay, after block number 5 I want to create a block number 7. So this cannot be possible. You cannot change the data, right? You cannot change the transaction. If A is doing some transaction to B, you cannot say that no, C is doing some transaction to B. So you cannot change the data of a block. You cannot change the previous hash as well, because previous hash actually depends upon the previous block, right? So because previous hash contains the hash of the previous block. So this can also not be changed, right? So all these fields are fixed. We cannot change them, but miners require a field which they can change, so that they can solve this mathematical problem, which we will discuss in our upcoming video. But to solve this mathematical problem, they need a field, and that field is nonce. Now, nonce is something which gives power to the miners so that they can solve that mathematical problem, which we are going to talk about. Okay. Now, as I said, block number, data cannot be changed, previous hash cannot be changed, but nonce is a number which we can change. And if we can change the nonce, we can also change the output of our SHA-256 algorithm, right? Because as we have discussed about SHA-256 algorithm, as we change the input, the output of SHA-256 algorithm also gets changed, right? So let's say these are some fields that are given in our block, some fixed field given in our block number 6, some data, some transaction, some previous hash. Okay. Now, if I have to generate this hash, definitely I have to give all these fields to the SHA-256 algorithm, right? So let's say if the nonce is 23, and then we have a hash of this 00001BA1. Now, since these fields are fixed, and let's say if I want to change the hash, what I will do? I will change the nonce. So as soon as I will change the nonce, you can see that we have a different hash. If I will change the nonce to 3, so I have a different hash. I cannot change the remaining fields, but I can change the nonce. So I'm changing it so that I can have a different hash. And why do I doing this? You will understand. Let us do it practically also. So this is a website, demoblockchain.org/blog. If you will come to this website, and let's say I have some data. Let's say A is sending 5 Bitcoin to B. Definitely, this is not how transaction actually are there in the blockchain, but just for simplicity I'm doing this. Okay, so now as you can see that as soon as I have changed the data, we have a different type of hash, right? If I will remove this, let me remove this, so you will see that this is a different kind of hash. If I'm having some data, we have a different kind of hash, and as soon as I'm changing the data, we have this color of the block gets pink, right? Now why it is pink? Because this is not the correct nonce for this block. Okay, so the miner, what miner will do, he will solve a nonce which is going to be perfect, which is going to be correct, so that this block gets green again. So let me click on this mine so that you can see that. I am clicking on mine, and you will see that our nonce will get changed. And as soon as our nonce will get changed, you can see that our block got green and hash also got changed, right? So as I said, nonce is a number which is under the control of miner. Nonce can be changed by the miners whenever they want, so that they can change the hash. If I will, let's say, again change some data, so you can again see that this got pink in color. Now I have to solve this mathematical problem, and to solve this mathematical problem, I have to generate a nonce. So I will click on this mine button, and this will help me in generating a nonce which will be correct in order to get this block color again green. Means this block then will become a valid block. So if it was a pink block, it was not a valid block, it was a malicious block because there was some change in the data. But now it is again a correct block, right? Not a malicious block. If I will change the block number for now, so you can see again it's pink, right? If I have to again click on mine, again nonce will get changed, nothing else will get changed, and now we have a green block. So this is what nonce is, but definitely we are going to talk about much more in our upcoming videos. But I hope you have understood how nonce actually works. Hi. So in the previous video, we talked about nonce, right? And now in this video, we are going to talk about how nonce are useful in mining. And not only that, we are going to also see how actually mining takes place. So let's start. Now, what is nonce? Let us understand nonce first. Definitely we have seen nonce in great detail in the previous video, but let's see in the point of view of mining. Okay, so nonce is a number that blockchain miners are solving for. And what do I mean by this statement? You will understand once we are once we will go throughout the whole presentation. So just wait for some time. Now what is target? So target is a number used in mining, which we will see how and why. It is a number that block hash must be below for the block to be added onto the blockchain. Now, what do I mean by this? So in the previous video, we have seen that nonce is a number that can be controlled by the miners. And when the nonce is changed, right? When the nonce of a particular block is changed, the hash of that block is also getting changed, right? Because nonce is also being added as an input to our SHA-256 algorithm. And when we are changing the nonce, we are changing the input to our SHA-256 algorithm. So the output that we are getting, that is the block hash, is also getting changed, right? Now, this target is a number that block hash must be below. Now, what do I mean by that? You will understand once we will start with our presentation. So just don't worry about it. But for now, just understand like this, that you have generated a block hash. Okay, you have generated a block hash by changing the nonce. Now, your block hash must be below the target, that is a number that is being adjusted by the Bitcoin algorithm. Let's say that we are talking about Bitcoin blockchain only. So this Bitcoin blockchain will give you a block hash, means this Bitcoin blockchain will give you a target, okay, and you have to produce a hash, block hash, which is below this target. And this will make sense once we will start with our presentation. Now the target adjusts every 2016 blocks. So this is something which is being adjusted after every 2016 blocks, and it also ensures that the blocks are mined once every 10 minutes. Now, this is something which is actually being done by the Bitcoin algorithm, means by the Bitcoin blockchain only. So we are not doing anything. There is no central authority who is doing these things. All these things are being controlled by the Bitcoin software only. Okay. So this is how our hashing algorithm looks like, right? Which we have discussed in one of the videos of hashing algorithm, where we are giving an input to this SHA-256 algorithm, and this SHA-256 algorithm is then just producing this hash, right? This hash, 64 hexadecimal character, that is a hash, right? Now what are these numbers, right? What is this 5819 EF? So this is an alphanumeric character, right? We have numbers, we have also some characters. So like, what are these? These are nothing but these are actually hexadecimal numbers. So if you are from computer science background, or if you have taken computer in any way, then you might know this, that these are hexadecimal number. So like We have a decimal number system like 0, 1, 2, 3, 4, 5, 6 till 15, right? So these are decimal numbers. And if we have to write the same number in hexadecimal number system, we write like this. So if you will see that 0 to 9, everything is the same, 0 to 9. But after 10 means after 9, when you have 10, so 10 is represented A in hexadecimal, 11 is represented as B in hexadecimal, and 12 as C, and so on. Okay, so this is what hexadecimal number are. So again, if you want to know a bit more about it, just watch any YouTube video, or just go for any Google page, and you will see that it's simple. It's simply a number system. Like we have decimal number system, we have hexadecimal number system, nothing else. Okay, so these are the hexadecimal numbers that you are seeing. Okay, so these are nothing but these are hexadecimal numbers or hexadecimal characters. So let's say that this is one of the hexadecimal number, right? Because as we said that decimal number system can be represented in hexadecimal number system. So this is nothing but this is also a number. Like we have 100, 1000, 999, or let's say 1 lakh, 2 crore, or like 2 crores, 10 lakhs, 99,000. This is also a number, right? In the same way, we have this hexadecimal number. We can have a hexadecimal number looking like this. We can have a hexadecimal number looking like this. Now let me ask you a question that, let's say if you have 64 characters, okay, let's say you have 64 characters, means you have 64 blanks, and you have to find the smallest hexadecimal number. What will be the smallest hexadecimal number? What you are going to fill in those 64 characters, in those 64 blanks actually, so that you have the smallest hexadecimal number. Take a while, pause me for a minute, and then answer it. I hope you have answered it. So let's see. What will be that number? That number will be 000, right? So we are filling each and every 64 blanks that are given to us with 0, and if we will fill it with 0, so the number that we will get will be the smallest number, right? In the same way, if I will ask you that what will be the greatest number, you have 64, again 64 blanks, and I want to know which is the greatest number. What are you going to fill in those blanks? What will be your answer? Take a minute and pause me for a second. I hope you have answered the question, and the answer to this is simple. That will be F, Y. So 64 F are there. Why? The reason is simple, because in hexadecimal number system, as we have seen, 15, if you will see, F is the largest number currently in hexadecimal number. Like in decimal number system, we have 10, right? Like what I'm trying to say here is that in case of decimal number, after this there is a repetition, right? 11, 12, 13, 14, 15, 16, and hexadecimal number is also the same case. The important thing to notice here is just remember this, that F is the largest number, right, in this table, right? F is 15 actually. So we can have F in all those 64 blanks, right? So this is the largest number. Now why I'm telling you all these things, you will understand. So this is our block. Okay, we have some data. We do not have any nonce. Since we do not have any nonce, so we are not we do not have any hash here, right? And this is the set of all possible hashes. So when I'm saying all possible hashes, so what I'm saying is that we have hashes here, means all the hexadecimal numbers here from smallest to largest. Okay, so we will start from 00000, because since we are talking about 64 blanks, 64, because SHA-256 produces 64 hexadecimal characters, so there will be 64 zeros here, and then there will be 64 F here, right? Means between these you will have all the numbers. So you will have something, let me start my pen. So you will have 0000 like this, 0, then 00001, then 00002. I hope you understand, right? And the same way you will have FFF till here. So we have all the possible hashes in this all possible hashes square, okay, arranged from smallest to largest. This is a target that is being set by the Bitcoin algorithm. Now how does why Bitcoin algorithm set these type of targets? As I said, so that it can ensure that each and every block is mined on an average of 10 minutes only. So no miner can mine the block before 10 minutes. And when I'm saying mine, what do I mean by mine? Means no miner can solve a mathematical problem before 10 minutes, on an average of 10 minutes. Okay, so this is to ensure that, and for that we have this target, and this is set by the Bitcoin algorithm, since we are talking about Bitcoin blockchain. Okay, now we are going to see what is that mathematical problem that miners actually solve for. we have seen an overview that miners solve a mathematical problem, and after solving that mathematical problem, we have block created, and then we add that block after verification and validation, right? In the blockchain mining overview, if you haven't seen that video, please check that video in the playlist. You will find that, or I will share it in the I button. Okay, let us see what is the problem that miners are actually solving for. So let's say we have a nonce 100. Okay, so we have a nonce 100, and for a nonce 100 you can see that we have a hash, that is CD1AEFBF. Okay, and this hash is actually belongs to this part of the, all these possible hash, means this is belonging somewhere at this position. Okay, at this position. Okay, now when we will change this nonce, you can see that when I'm changing it to 76, this hash changed, and now we are at this position. An important thing to here notice is that none of the nonce till now that we have generated is below the target. And we have seen, right, in the definition of target, that the block hash that we are generating must be below target so that we can add a block to the blockchain, or we can create a block. And this is the problem that miners are actually solving for. What they are trying to do is they are trying to change the nonce, because this is something which is in their control. They are changing these nonce. Now once they are changing these nonce, they have different hashes, right? Before that, if you will see, we have 100, like before at nonce 100 we have this hash, at 76 we have this hash. So what they are trying to do is they are changing the nonce so that they can generate hash. And what they are trying to do here is they are trying to generate a hash which is below this target. Currently none of the hashes that the miner has generated is below the target, so he will keep on generating these nonce. He will keep on changing these nonce. So let's say he started again, and now he has a nonce of 201, but still you can clearly see that this hash is not below this target, right? As you can see from the picture. Okay, now let's say he again changed the nonce, and now he has a hash of 000B6A, and this is something which is below this target. Now this is the time where the miner has actually solved the mathematical problem, because he has generated a nonce, not actually I will say nonce, because when I'm saying nonce, so actually nonce is something which is actually generating our hash, right? So when I'm saying nonce or block hash, just think like I'm going to use them interchangeably, so just don't be confused. So when he is changing the nonce, now he has produced a nonce, or he has produced a block hash which is below this target. So now this miner has actually solved the mathematical problem, and he will be rewarded with a cryptocurrency. And if we're talking about Bitcoin, so he will be awarded with Bitcoin. Now some of you might be thinking, like, why this hash is below this target? Now why not these hashes, right? Some of you might be thinking, and I will explain to you these in much more detail in our upcoming slides. But for now, let me give you a hint. Actually, what is actually happening, if you will see, this is the target, right? 000. This is a number. So we are saying that the first 4 digits, since we have 64 characters, right? We have 64 characters, and in this we are saying that for the target to achieve, the first 4 numbers should be 0, right? The first 4 numbers should be 0. So any number which is below this number, it can be anything. Any number that is below this number will be the desired hash, and the miner who will generate that desired hash will be awarded. Otherwise, if a number, if you will see this number, this B474, this number can never be below this target, right? Why? Because in the starting only it has B474E, right? Since we have taken only 8 characters here, right? 9 characters actually for the demo purpose, actually 8 characters, 8 characters only. So you can clearly see that all the 8 characters are having these numbers, so none of these numbers are 0, so the target can never below this, the hash can never be below this target. And that's why this hash is the one which was the desired one. Definitely there can be various other hashes, because this is an area, right? It can have many target, so it can also have a target of, means the target can be, right, like this also, 1 2 3 4. Okay, because again we have 4 zeros and the number which will be below this. And don't worry, if you still are not able to understand, you will understand it. Let's move on, and then you will understand it in a much more detail. Okay. Okay, before moving further, let me tell you one more thing. Because some of you might have this question that so this nonce like the nonce that we are generating, is this producing, like, it is so simple, like it looks so simple that we can generate a nonce and we can be here, right? We can generate some nonce and that will lead to here, because all these hashes are from smallest to largest. So just generate a nonce which will lead us to this, right? But this is totally a random process. Why? Because if you will see, if we will start with 100, this 100 is producing a hash which is here, right? Which is some point here. Now when we have 76, now you can see that this 76 is producing a hash which is somewhere there, means it is much above the previous one, right? So it is producing a hash which is some point here. And let's say if we have 201, so in that case you can clearly see that it is somewhere below. So this is a totally random process. So this is not something like you can just produce non-sequentially that 0 1 2 3 and you will start from this. No, this is not how it works. This is a totally random process. So like you cannot just produce a nonce like by thinking, okay, I will produce this nonce and that will lead me to this, right? This is a totally random process. There is no pattern to it. So just remember this and do not be confused with this. Okay, now let's move on to the detailed topic of this target. Now let us understand that criteria, that target and all those things if you are still not able to understand. So let's say we have a 5-digit number, because as I said, hexadecimal number are nothing but these are also numbers. So we are considering that we have a 5-digit number, and with the help of this 5-digit number we can cover this entire area, right? So we can have numbers starting from 00 till, and let's say we are only assuming decimal number system, so we can have a number of 99, right? So we are assuming that we have a decimal number system for now, not hexadecimal number, so that I can explain you this. So we have a number starting from 000 to 999. So we are covering this entire area, right? We are covering this entire area. But what will happen if I will make the first number 0? If I will make the first number 0, now you can clearly see earlier we were covering from 00 to 9999, right? But now what we are covering? We are only covering these 4-digit, because we have made this first character as 0. So now we are covering from number from 00 to 999, since the first character is 0, the first number is 0. So now you can clearly see we have much smaller number, right? We have much smaller number between this range, because earlier we were having 99999 and now we have only 9999. So definitely this range will be between this small, like a small range will be there between these two numbers, right? So that's why we are saying that this is actually representing this small area. So this area is actually having numbers from 00 to 99. And that makes sense also, because 999 is a much bigger number. So it will be from here to 000, right? It makes sense. And what will happen if I will make the first two characters 0? Again, this area will get reduced. Why? Because now we have only numbers from 00 to 999, right? Because the first two are already 0. The first two are already 0. Right? So by this you can clearly see that the area is getting reduced, and the miners are actually solving for this area only. So they are actually producing a nonce which is lying between these two ranges, between this area. So they are finding, let's say they have a target of, for example, let's say 00 let's say 453, just an example. So any number which is below this range, like that can be 00452, that can be 004 or 300, anything which is below this range will be the solution for their mathematical problem. Or any number which is above this, let's say for example 12453 or 10453, all these numbers you can clearly see that will lie above this area, right? Because it is only a 3-digit number, but all these numbers are 4-digit number. So definitely we cannot have a number 4-digit number in this area, because this is the area of 3-digit number, right? So that's why we have this type of thing, this type of target thing. And I have just given you one more example where I'm saying that first 3 characters are 0. So now you can clearly see one more important thing, that you can see that as we are increasing the number of 0, right? As we are increasing the number of 0, the target area is getting reduced. And when the target area is getting reduced, it will become more difficult for the miner to solve the mathematical problem, because now they have to solve for this small area only. Earlier, they were solving for this big area. earlier is before that they were solving for this big area, but now as the number of zeros are increasing, right, before these two numbers, the target area is also getting decreased, means the solution is the probability of solving finding their solution to their problem is also getting reduced. And that's what make mining very much difficult. And just don't believe me, just don't trust me, I will show you a mathematical proof for this also. Okay, so just if you are comfortable with mathematics, then that's good. If you're not, just have a look at it. You will have a good sense why this is so much difficult for the miners, because many of you might be thinking it looks so easy, we do not have to do anything, we have to just generate, we have to just generate some nonce, and with the help of which we can easily find the block hash, and that's an easy process. But that's not an easy process, and you will understand this with the help of this example. So let's say this is the current target. Definitely this is not the current target. I have made this PPT a long back. So just say that this is one of the target that was given to the miners to solve for. So now the miner's responsibility is to generate a hash which is below this huge number, right? And the first 19 characters, as you can see, are leading 0. Okay. So now let us understand this, why mining is so difficult. Okay. So let's say we have a possible hash, means we have 64 hexadecimal characters. So we have 64 hexadecimal characters, right? And so in total, we can have a possibility of 10 to the power 77 hashes. Now, what do I mean by that? So since we have 64 characters, right? So in these 64 characters, I have 64 possibilities, right? 16 possibilities here, 16 possibilities here. Why 16 possibilities? Because as we have seen in hexadecimal number, we have number from 0 to 15, and if you will count, it is 16. There are 16 numbers, right? 0 to 15 means, or 0 to f, actually 0 to f. So we have 16 numbers here from 0 to f. 16 numbers are there between 0 to f, and that's why we have 16 possibilities. So we can have 0, we can have 1, we can have a or b or f, like this. This is something related to permutation. If you are not comfortable with it, that's fine. For now, just think like this, that we have 16 to the power 64 possibilities, because 16 into 16 into 16 till 64 times we will have 16 to the power 64, and we have calculated in 10 to the power 70 into 10 to the power, so it is 10 to the power 77. Now total valid hashes, because as you can see that the target that is set has 19 leading zeros. So the total possible hashes with these 19 leading 0 is 10 to the power 54. Why? Because the first 19 characters are 0, right? First 19 characters are 0, so we cannot touch them. So this is 0, this is 0, like this. We can only touch the remaining, that is 64 minus 19, right? 64 minus 19 characters we can touch. So we can say that they are 10 to the power 54, that is 16 to the power, if you will calculate it will be around, I think 45, right? It is 16 to the power 45, and if you will find it in the form of 10 to the power, it is 10 to the power 54. Now if you will see the probability of picking a random hash from this large area, that is 10 to the power 77, this is the large area, right, having all the possible hashes, and this is the small area having a small set of hash, right? So if you will see the probability of finding a particular hash that is a solution to your problem, that is 10 to the power minus 23, that is 0.000000 till 22 times, right? Something like that. So this is a very small number. And that's why miner has to put so much effort in order to find a solution to their problem, in order to generate that right hash which is below the target. Now this is the problematic thing, right? So mining is not an easy task. That's why it took days. If you're a miner of proof of work, it took days, even weeks sometimes, to find the target, to find the desired target, so that you can create the block of a blockchain. Now again, I hope you have understand that. So this is something which I thought you should know, that who is actually adjusting these difficulties. So this is done by the Bitcoin algorithm only. So we are not doing this, no central authority is doing this, everything is done by the Bitcoin algorithm only. Okay, this lecture we are going to talk about Bitcoin target history, and you will love this lesson. You will learn a lot in this lesson. So in the previous video we talked about nonce mining in detail, about the target, and how the miners actually solve for that target in order to get the reward in order to solve that mathematical problem so that they can create a block, right? Now let us see what are the different Bitcoin target that already has occurred in the history, right? So this is a beautiful website. If you want to learn about Bitcoin in detail, trust me, this is the best website, and you can learn a lot about Bitcoin on this website. The website name is learnmeabitcoin.com. It's a great website. And let's go to the target page of this website. So where's the target? Let me search for it. So target, oh, here it is. So this is our target page, and in this, if you will see, we have all the target. Currently the target is this. Okay, you can see a lot of number of zeros are there, right? And as we discussed, the more number of zeros that we have, the lesser will be the area of finding the solution, right? In the previous video we have talked about this. And if you will see, okay, this is the Bitcoin target history. So you will find the Bitcoin target history under this tab, and you can see the Bitcoin target history here. So you can see that how the Bitcoin target history is being changing, right? It's been changing from time to time on every 2016 block, or on every 2 weeks, right? It's changed, and it is done by the Bitcoin algorithm. So this is not what we are doing, but this is done by the Bitcoin algorithm only. So you can see that it is being changed, right? And currently it is changed on 13th of September 2022, and today is 14th of September when I am recording this video. So you can see that the target just changed yesterday only, right? And let us see some of the important things that you should notice here, that is important, right? So first thing, if you will notice, from 3rd Jan 2009 to 18th of December 2009, the target never changed. You can see that the target is still 0.00000FFF 0.000FFF. And why this is so? Because as we discussed, right, the target should change after every 2016 block or after every 2 weeks, right? But the target was never changing. And the answer to this question is very simple, because at that point of time there were not much miners, right, who were actually mining for the Bitcoin. So there were less number of people who were solving the mathematical problem. So since there were less number of people, so the Bitcoin algorithm never thought that why should I change the Bitcoin target, because there are less number of people, and already this target is very much, heavy for the miners at that point of time, because at that point of time there were not so much good technologies also, I will say. Okay, so miners were using their computer or some a little bit high performance computer or something. So at that point of time, Bitcoin mining algorithm thought that why should I change the target? It is good, why should I change it, right? But after some time, means after 18th, means after this 18th December 2009, you can see that the target is continuously changing. So if you will see, so it is D86A, it is C428. So the target is continuously changing, right? The number of zeros are not changing. One important thing to notice here is the number of zeros are not changing, but it does not matter, because as we discussed, right, these are all the numbers. So if it is D8 and this is C42, so D8, if you can clearly see, at this point of time, FFFF, right, this number is greater than this number. So means what actually happened, I think, on 30th December 2009, the target decreased in the sense this number got much less, means the target become much harder to achieve, because now we are what we are trying to do here is we are actually reducing the area, right, because we are decreasing this number. And all these things we have discussed in the previous video, so I'm not going into much depth. So we are decreasing the number, so hence we are decreasing the area where the solution for the problem is, right, for the mining problem is for the miners. So miners are solving for much lesser area, right? But after some time you will see that I think the number of zero also started increasing, means this was making the Bitcoin solving problem much more harder to solve, means Bitcoin mining problem much more harder to solve. So let us see where the number of zeros are changing. It is actually very much difficult to find out, right? A lot of numbers are here at this point of time. Okay, so I think from around this point of time the number of zeros are changing or something. Yeah, this point of time I think the number of zeros are also changing, means now the target is much more harder, right? So earlier it was decreasing, like it was harder, a little bit harder, but now since the number of zeros are increasing, right, so the target is much more harder at this point of time. So this is something that you can see, and you can clearly see that the target is changing on every 2 weeks, 5th August, 15th August, and the number of blocks, the difference between the number of blocks is 2016. So all these things you can see on this page. It is a beautiful website, as I said. So you can see a lot of interesting thing here. So it is also not the fact that, let me tell you one thing more, that it is not that every time the difficulty will increase. There will be times where the difficulty will decrease, because at this point of time, when the cryptocurrency market is going down and miners are not much interested in mining Bitcoin, so you will notice that the Bitcoin difficulty level is decreasing day by day. Not day by day means on every 2 weeks or such type of things are going on. Why? Because the number of miners are today, because the cryptocurrency market is down at that point at the time of making this video. So miners are leaving the Bitcoin mining industry, and hence the difficulty is also decreasing. Okay, so this is the best time if you want to be a miner, because the difficulty is decreasing. And there are other things also. So if you want to learn much more about this target, so you can see that a lot of things again. I think there is a calculator also, like how much time it will take to solve the target and all those things. So this is a good website. You can definitely refer to this website, a highly recommended website. So you must check out this website. And in the next video, we will talk about the different machines that we have for mining, like GPUs and ASIC, normal computers, that is CPUs. We will talk about that in detail in the next video. And if you have any doubts, please comment below. Now in this video, we are going to talk about the difference between the various technologies that miners use for mining. Now, before talking about the different technologies, let us go back to our nonce example, where we have learned that by producing these nonces, which are actually being produced by the miners, these miners produce different nonces, and with the help of which they are able to reach the target, right? Now, one important thing to notice here is that by changing these nonces, miners are able to change the hashes. So let's say we have two miners, one miner who is actually able to generate 5 hashes in 1 second. And we have another miner who is able to generate 10 hashes per second. When I'm saying hashes, I'm talking about these hashes. Now, if I will ask you which miner has high probability of winning this target, of generating a hash which is below this target, the answer to this question is very simple. That is miner B. Why? Because miner B is able to generate hashes at 10 hashes per second, while miner A is able to generate only 5 hashes per second. So like now miner B has more chances, right? Because he will be able to change the different nonces at much faster rate as compared to your miner A, which is able to generate hashes at a much slower rate, right? It is like miner A is having a car which is running at 25 km per hour, while miner B is having a car which is running at 50 km per hour. So now miner B is much faster as compared to miner A. Now, why I'm telling you all this? I'm telling you all this because these different technologies have different mining rate. So if we talk about CPUs, normal CPUs that we have in our, we use in our day-to-day life, right? We have CPUs in our laptop, we have CPUs like when we use a system. So if you will see, CPU is a technology which is actually able to generate 10 mega hashes per second. So it is around, I think 10 mega hashes is definitely, it might sound very much high, but it is not that much high. In today's world, nobody actually use CPU for mining, and especially if it is Bitcoin, nobody is actually using CPU for mining Bitcoin, because it is a very less number. Okay, it is only 10 million hashes per second. Okay, now after CPUs, what miners started using is GPUs. Now these GPUs has a mining rate of 1 gigahertz hash, not hertz. Actually, I actually literally always get confused between hashes. So it is actually 1 giga hashes per second, which is around 1 billion hashes per second. And if you will see, it is much higher than CPU, right? But still, GPUs are something which are actually used for multi-purpose things. So they are not specially designed for mining purposes. So still the mining hash rate is still very low if we talk about GPUs, and there are very few miners at this point of time in 2022 which might be using these GPUs. Okay, but now what miners are actually using is ASIC. Now what is this ASIC? ASIC is also a technology with the help of which miners are able to generate 110 trillion hashes per second. So you can see that among all these technologies, ASICs are the most fastest. So this is what make ASIC so powerful. Now let me show you some of these GPUs which are actually available on eBay. So you can go on eBay and you can search for these GPUs. The thing with GPU is that they are actually more cheaper as compared to your ASIC, which are actually very costly. If you will see, they are in thousands of dollars. So this is how your GPU looks like. Okay, so actually I haven't used any GPUs yet, so definitely it is on eBay, so I'm guessing this is what how GPUs actually looks like. Okay, that's wonderful. And I think this is for mining only. NVIDIA on that GPU accelerator, CDU, PCI, e-mining learning, something like that. I'm not that much sure, but I think this is one of those GPU. Okay, so let me search this GPU for mining so that we can have better results. Okay, have different. This is a GPU mining rig, so where you can have various GPUs at one time, many GPUs at the same time. These are the GPUs that you are seeing, and these are the, I think the slots are given here. Okay, and now you can see the ASIC. So you will see ASICs are, as I said, the most powerful, but they are very costly also. It is around $1,000. Actually, a very costly thing. That's the thing. So I hope you have got why do we use CPUs, why do we use these GPUs, and why do we use ASIC. Actually, it's not ASCII, but it is ASIC. Sorry for the wrong spelling here. So I hope now you got why miners currently use ASICs. Most of the mining pools actually use ASIC because ASICs are very much faster. Miners are able to generate hashes at a much faster rate. Hi. Now in this video, we are going to discuss about mining pool. So let's start. So this is our blockchain network, and the people that you are seeing in this blockchain network, we are assuming that these all people are actually miners. Now, who are miners? We have talked about it, that miners are the people who are solving a mathematical problem. And what is that mathematical problem? That mathematical problem is to solve for a nonce or to solve for a hash which is below the target, right? And we have discussed everything in detail in our previous video. So if you have not watched the previous videos, please watch the previous videos as well. In the previous video, we also talked about that these miners who are actually participating in the blockchain network in the mining process, they require some form of technologies, right? So let's say these are different miners, they all have different type of technology. Some of them are using CPUs, some of them are using GPUs, some of them are using ASIC. Now the problem arises when there is unequal distribution of hashing power. Now what do I mean by that? So let's say all these miners were actually mining by using some GPU technology, because GPU is cheaper technology. So these miners can afford GPUs only. So what they did, they started using GPUs. Okay, so they are enjoying their Bitcoin mining by using GPU only. But after some time, what happened? Some big companies comes into picture, and these big company started using ASIC technologies or big mining technologies in order to mine Bitcoin. So these companies that you are seeing on your screen, these are actually people or big corporation who have millions, or not I will say millions, but thousands of miners working under them, and they are using powerful technologies like ASIC, or let's say GPUs or some form of powerful technologies in order to mine. Now, if you will see in this case, these miners that are not part of these big mining corporation, they do not have enough power, they do not have enough technologies or means in order to compete with these big corporation, right? Why? Because these big corporations, since they are using powerful technologies, so they might be mining, let's say in 1 second they are mining, let's say 1 trillion hashes per second. But these miners who are working alone at their home, they are able to mine only, let's say, thousands of hashes per second. So the probability of winning definitely is higher for these big corporations and not with these individual miners, right, who are mining alone at their home. So what these miners can do is they can form a mining pool. Okay, so you can see that these miners, they have formed a mining pool. In the same way, this big corporation also thought, okay, why not to increase my power, and they also become a part of this mining pool. Now, what is this mining pool all about? So it is a pool of miners where all the miners, like these miners, let's say these four miners, has actually formed a group, and now they are solving the mathematical problem as a group. So these miners are not solving the mathematical problem alone, but these miners are actually combining all their power, and they are using all their power in order to solve this mathematical problem. And that's how they are now, I will say, they are now as much as powerful as these big corporations, because definitely I am showing you only four miners here, but in the mining pool you can have thousands of miners or even lakhs of miners. Okay, so they can now compete with these big corporations who are actually using hi-fi technologies, like powerful technologies for mining. Okay, now let us also discuss some more benefits of mining pools. First benefit is that you don't have to buy costly equipments. Now, since you are working as a group, so earlier you might need to buy an ASIC so that you can mine, right? You can compete with these big powerful corporations. But now you can form a group, and by forming a group, you are now equally powerful as those corporations, because you are combining all the technologies and you are like working as a group now. Okay. Second is that you don't have to worry about mining setup. Now, let's say you are you are at your home and you want to mine, but you do not want to have a heavy setup of big technologies at your home or something like that. So what you can do is you can join these mining pool. Okay, and then you have to pay some amount of fees to these mining pool, because definitely you are using all their software and everything. They will provide you with each and everything. You have to just start your computer now and you have to just start mining. Okay, so they will provide you with everything, so you don't have to worry about these mining setup, about the software, about the hardware and everything. You have to simply have a computer or a simple technologies, and now you can be a part of this mining pool. Now, the third thing is that distribution of rewards is according to the mining power. Now, what do I mean by that? So let's say these four miners are, mining for a Bitcoin. And let's say this miner is using some powerful technologies like ASIC. Okay. So now definitely he has, he's using much more. He's using much more hashing rate in order to solve for this mathematical problem, right? Definitely these three people are also using, let's say these three people are using GPUs only, and but he is using ASIC. So definitely he is actually making, he is actually utilizing the most power, and he is actually giving uh, most to the group, right? For mining, right? He's working most as compared to these, because GPUs, as we have discussed, has a hashing rate of gigahertz, not hertz, actually giga hashes per second, but an ASIC has a hashing rate of 1 trillion hashes per second, right? So definitely he is actually using a lot of power. So in this case, if they will want, if they will solve this mathematical problem, and if they will get a reward in terms of Bitcoin, so definitely in that case, this miner will be definitely given much more amount of Bitcoin as compared to these three miners combined, right? Because he has used much more technologies, much more power actually, in order to mine this Bitcoin. So it is like the effort you are going to put, the reward you are going to get accordingly only. Okay. And the fourth point is that there is no wastage of power, since all these miners can, as you can see, that all these four miners are solving the same mathematical problem, right? But this mathematical problem will be divided among all these four people, and which we will discuss in our upcoming videos. But for now, let's say this mathematical problem is, let's say, this mathematical problem is of, let's say, 100 meter, just an example to give you. So 25-meter will be given to him, 25-meter will be given to him, 25-meter will be given to him, and 25-meter will be given to him, so that they can equally work on these problems. So they are not, they are not solving the same mathematical problem, means there is no repetition of work here, right? So this work will be divided equally among all these four people, and they will start solving the mathematical problem in this way. And let me show you the different hash rate that we have currently. Okay, so this is for Bitcoin. So I'm on this website, blockchain.com/pools, and here you can see that these are different mining pools. So here you can see that these different mining pools, they have a different hash rate, and this unknown is actually occupying the major portion here, right? So he is the most powerful, I will say, in this hash distribution. And then we have this ant pool via BTC. So there are different mining pools at this point of time. Now you must be thinking that if this unknown is the most powerful one, why not to join this unknown mining pool, right? So that you will have higher chances of winning. But in that way, you have to also think that since this unknown is, this is a big mining pool, so definitely the distribution of reward will be done accordingly, right? So if let's say you also won a reward, but that reward will be divided among all the participants all around, among all the miners who are the part of this big mining pool, right? So the distribution will be done accordingly, and in that way you will be getting less amount of reward because there are more number of people, right? Or let's say more big technology they are using. In that case, they will be given much more reward than you if you are a small part of this mining pool. So here you can see much more information about it. Definitely there is much more to explore on this blockchainexplore.com. Do visit to this website. You will learn a lot about Bitcoin, Ethereum and different cryptocurrencies, about their hash rate and everything else. Now in this video, we are going to talk about Nonce Range. And this is a very important video because this video actually will help you to understand our next topic, that is timestamp. So please be a little bit more alert, more careful in this video, okay? This is a very important video. And this video will be a little bit tricky, I will say, because in this we are going to use a little bit of mathematical calculations. So you might find it a little bit tricky, but I will suggest you to just be patient, and at the end of this video, you will be understanding each and everything. Okay, so just be a little bit patient here. So as we have discussed in our previous video, that this nonce is a number that miners use in order to solve the mathematical problem. So with the help of this nonce, miners are able to generate different hashes, and once they are able to generate a hash which is below the target, they are able to create the block, and once they will create the block, they will get rewarded, right? I have explained all these things in the previous video. Now since this nonce, as we can see, is a number, right? And since this is a number, it has a particular range. This nonce is a 32-bit number. Now, if you are not from a computer science background, you might not be getting this bit. So I will suggest you to just go and search for it, and you can easily see an explanation for this bit. Okay, this is something related to your computer science fundamentals. So just go and search for it, and you will find a good video like about this bit. For now, what you can think, or not, I will say think. For now, what you can say that this nonce, the range of nonce we have is 4 to 4 into 10 to the power 9. Means with this 32-bit number, we can generate 0 to 4 into 10 to the power 9 nonce, that is around 4 billions of nonce. Means we can have a nonce at 0, 1, 2, and till we can have this nonce 4 into 10 to the power 9. Okay, it is a pretty big number, right? This is a pretty big number. Now, and how I have got this calculation, this is something, again, I will say this is something related to your computer science background only. So I have just taken this 0 to 2 to the power 32 and then minus 1. That's how I got this number 4 into 10 to the power 9. Okay. Now, if you are not getting it, just don't worry. Just go on with the video. You will understand each and everything at the end. The concept actually at the end of this video. This 4 into 10 to the power 9 nonce might looks like a very big number to you, right? But trust me, this is not a very big number. If we talk about our SHA-256 algorithm, which produces 64 hexadecimal characters, and if we talk about the number of possibilities, means the number of hashes that we can generate from this 64 hexadecimal characters is around 10 to the power 77. Okay, it is around 10 to the power 77. Now, how I got this number? Since we have 64 characters here, and at each character we have 64 possibilities, right? Because as we have discussed about hexadecimal number is from 0 to F, and if you will see the range, it is 16. So we have 16 possibilities here, 16 possibilities here, 16 possibilities here, and we have till 64 characters, right? So I have just multiplied all this 16 into 16 into 16 64 times, and that's how I got this number. Okay, so this is the total number of hashes that we can produce by using this SHA-256 algorithm, and this is something related to your permutation and combination of mathematics. But don't worry, if you just remember this number and you are good to go. Since the total number of valid hashes is around 10 to the power 77, right, which we calculated using this SHA-256 algorithm, And the total number of nonce that we can generate is 4 into 10 to the power 9. Now, if you will see something is problematic here. The number of nonce that we are generating is very, very, very much lower than this 10 to the power 77. Means this 10 to the power 77 is a very, very, very big number, right? If you will compare it with this 4 into 10 to the power 9, right? Because we have 10 to the power 7, here we have 10 to the power 9, so it's a very big number. Now, this generates a problem. Now, what is that problem? That there are not enough nonce to generate the valid hash. Why? Because with the help of nonce, what we do? With the help of nonce, we generate hash, right? And with the help of nonce, you can clearly see that we can generate only 4 into 10 to the power 9 hashes. Because we have 4 into 10 to the power 9 nonce, so we can generate 4 into 10 to the power 9 hashes, right? But the total number of valid hashes is 10 to the power 77, right? So we cannot generate all the hashes that are possible. Now, if you are not getting it, you will understand. Just see this diagram. So let's say this is our nonce, right? This is our number of nonce, and this is our total number of valid hashes. Okay. And let's assume that this is 4 into 10 to the power 9 nonces, and just assume that these are 10 to the power 77 hashes. Okay. Now let's say as a miner, I used one of my nonce and I was able to generate this hash. Okay. So I was able to generate this hash that is present in our SHA-256 algorithm. Now by using this, I was able to generate this. Now after some point of time, you will see that I do not have any nonce remaining in my bucket. So I cannot generate these hashes that are left. And it might be the possibility that my target is somewhere here, right? Because it might be a possibility, right, that I might have exhausted all my nonce, but still I was not able to produce these hashes, so I was not able to go to these hashes, and might be my answer is there in these hashes that are left. It can be a possibility, right? So this is a problem. And just do not think that I was just using this nonce and it was generating this nonce. I mean, it can be here and here also. Like this can produce this nonce also, this hash also. This nonce can also produce this hash also. I'm trying to explain you another concept here. The concept is that with the help of this nonce, you cannot generate all the possible hashes that are there. And if you are not able to generate all the possible hashes, so you might not be able to generate the hash which is below the target. Okay. And this is a problem, right? This is a problem. Now let's look at another important thing, that let's say that a modest miner who is mining is able to generate 10 to the power 8 hashes per second. So this is just an assumption. So he is using some technology and he is able to generate 10 to the power 8 hashes per second. Now, since we have only 4 into 10 to the power nonce, how much time it will take to consume all these nonces? So it will take around 4 into 10 to the power 9 oblique 10 to the power 8 equal to 40 seconds, right? Now, how I got this calculation, let me tell you. So in 1 second, I was able to generate 10 to the power 8 hashes, right? So let me do it 1 seconds and hashes. Okay, so I'm using a unitary method of mathematics. So in 1 second, I was able to generate 10 to the power 8 hashes, right? Now, I have 4 into 10 to the power 9 nonce, right? So means I have 4 into 10 to the power 9 hashes, right? Because these nonce are actually used to generate hashes. So we can say that with the help of this 4 into 10 to the power 9 nonce, I am able to generate 4 into 10 to the power 9 hashes. So the question is, how much time will it take to generate this number of hashes? So I'm taking this as x, a variable. Then I'm going to do cross multiplication, a simple unitary method trick. You can go and see this. This is a simple thing. So I will be getting x 4 into 10 to the power 9 into 1 divided by 10 to the power 8. And by this, you can clearly see that in 40 seconds, I will be exhausted with all my nonces. Now, the question is what I will do if all my nonces are exhausted. After 40 seconds, what I will do, right? This is the question. Let me erase all these things. So this is my question, that so what the miners will do when nonce get exhausted and miners have not hit the target. Okay, this is a big question. And we will address this question in our next video where we are going to talk about timestamps field in our blockchain. Okay. Hi. In this video, we are going to talk about timestamp. So in the previous video, we have talked about a problem that we have with the nonces, right? We have limited set of nonce and the modest miner actually mines around 10 to the power 8 hashes per second, due to which a miner will get exhausted with all its nonce in just 40 seconds, right? Now the question arises that what the miners will do when all the nonce get exhausted and miners have not hit the target. This is a big question, right? And the solution to this problem is timestamp. Timestamp is also a field given in our Bitcoin blockchain or any other blockchain, but for now we are talking about Bitcoin. And this timestamp is the time at which a particular block is created. So let's say the timestamp for this block can be this number. Now this number when in seconds, this is actually Unix timestamp, means Unix time. Let me show you that. So if I will go to this Unix timestamp, so this is our Unix time. So this is the time, like at the time when the Unix started in January 1, 1970. So you can clearly see that this clock is uh, going on, right? So now we have one more field that is given to our SHA-256 algorithm, and with the help of which we are able to produce our hash, right? Earlier, we were only talking about block number, nonce, data, previous hash, but now we have one additional field, and that additional field is timestamp, which is also given as an input to our SHA-256 algorithm. So whenever our timestamp will change, and since the timestamp will change in every second, right? Because this is given in seconds. So in the next time, it will be 5-6, right? This number and then 5-6. So when the timestamp will change, then definitely the output of our SHA-256 algorithm will also change. Hence, we will have a different hash of this block, right? Now let us see how this timestamp can help miners, like the problem that we are facing, right? That the nonce are being exhausted. So how this timestamp can help us in this situation? So let's say this is the timestamp of this block, and let's say this is nonce, right? And timestamp is not of this block actually. This is the timestamp when, like, the miners are actually solving for this block. Okay, so they are solving this mathematical problem, and every time the timestamp is changing. So that's the thing. Okay, currently I'm just showing it inside the block so that you can understand this in a better way. So now let us see, this is our nonce. Okay, this is our nonce and it is currently at 0. Okay, so this is like a scale, so it is currently at 0. Okay, now let's say that miners are solving this mathematical problem. They are using their technologies, their mining equipments in order to solve this mathematical problem. So let's say after 0.5 seconds, okay, yes, one more thing to tell you. Yeah, I just forgot to this, that a miner exhausts 4 billion nonce in 40 seconds. This is what we have seen, right? So a miner will be exhausting around 0.1 billion nonce in 1 second, right? Simple calculation, 4 billion in 40 seconds. So 0.1 billion in 1 second. Now, let us say that this is a nonce scale, as I said. Let's say after 0.5 seconds, so our timestamp is not changed, right? Because timestamp will change in every 1 second. So let's say this is, we have only passed around 0.5 seconds, and after 0.5 seconds, you can clearly see that some of the nonces get exhausted by the miners because he is solving this mathematical problem. Now, in the next 0.5 second, what will happen? In the next 0.5 second, this timestamp will change, and since this timestamp will change, so we will have an entirely different kind of a hash for this block, right? We will have an entirely different kind of a hash for this block. Since we will have a different kind of a hash for this block, the miner can now again start this nonce from 0 and again reuse the nonces. I hope you are getting this. This is a little bit difficult to understand, so just try to understand what I'm trying to say here. That since the hash is changed of this block is changed, a miner can again start using nonce from 0 so that he can find its target. Because the hash is changed, so by using nonce from 0, he will have entirely different kind of hash when starting from 0, right? This is what I'm trying to say. So let's say after 1 second again, okay, so again after 1 second, so what I'm trying to say here is that after 1 second, he will be exhausting again some amount of nonce. If let's say it is 58, again some amount of nonce is being getting exhausted. So after every second, some amount of nonce will get exhausted. And once that 1 second will hit, again the miner will start from zero, and again he will start using the nonces again and again. So he is actually reusing the nonces again and again. So this is what is actually happening. So 56, so now the miner has used this amount of nonce, and after 57 he will again go back to zero and he will exhaust some more amount of nonce. Now let me tell you one more important thing here. Just don't be confused that this is not starting from this to this, okay? Like this at 56 it is was at this, so you might be thinking that at 57 it is starting from this to this. No, at 57 it is again starting from 0 to 57 only, okay? At 58 again starting from 0 to this point only. Now why this is changing, like why some at some point we have this green ending here, at 57 it is ending here, and at 58 ending here. Why it is happening like this? Because only 1 second is passing every time, right? And this is due to what we are taking into consideration is that miner is using a technology, right? ASIC or GPU, whatever technology. So this ASIC or GPU technology might get heated up, and since these technology might get heated up, so the efficiency of these technology will get decreased, right? And since the efficiency of these technology will get decreased, definitely it will also affect the hashing rate of those technologies, right? If the That's why if you have some of the pictures that mining, those big mining pools, or I will not say mining pool, those big mining companies have coolers or AC so that they can cool off their their big, technologies they are using for mining, right? So this is the simple case. That's why I'm showing you different, different number of nonces are getting exhausted in each and every second. Okay. So one thing is for sure, with the help of this timestamp, we are able to reuse our nonces, right? So the problem that we were facing earlier, that the nonces were getting exhaust again and again. Now they will not get exhausted. The miner will be able to reuse the nonces. So we have found a solution to our problem. But here is a catch. There is one more problem. Let me tell you what is that problem. If we talk about our current hashing rate of the whole network, okay, I'm talking about the hashing rate of the whole network, okay, when all the miners are and all the mining pools are there, you will see that this is around 234 million trillion hashes per second. 234 million trillion hashes per second. This is a pretty big number. And if we talk about the number of nonces, the number of nonces that we have is only around 4 into 10 to the power 9, as we have discussed in our previous video. And if you will divide this number from this million trillion hashes, 10 to the power 6, 10 to the power 12, I'm not considering this 234, I'm leaving it out. Then also, this time, if you will see, is 4 into 10 to the power 9 seconds, which is way less than 1 second. Means the miner will be exhausting all its nonce in just the power 9 seconds, which this number, as I said, is very, very, very less than 1 second. Now some of you might be thinking like, you do not get this, right? Why I'm dividing it this like this number from this? Let me show you this. So this is our blockchain explorer website. If you will go to this link, blockchain.com/chart/hashrate, you will see that this is our, and I will go here. So you can clearly see, might be available, might be visible on your screen. It is 234.365 million, and you can clearly see that this is given in trillion hashes per second. So the estimated number of tetra hashes per second the Bitcoin network is performing in the last 24 hours. So actually it is for 24-hour data, but this is the total hashing rate of the whole miners that are actually mining for the Bitcoin. Now if you will go to our hashing distribution of the different mining agencies or the different mining companies, right? You will see that a small mining company is actually around, let me see whether they are providing any percentage or not. it is not providing any kind of a percentage. I think no, they are not providing any kind of a percentage. But what important thing I want to share here is that if you will see, this unknown is actually around, I think, 49% or around 40%, right? It is around, I think, 47% or something. It is actually using 47% of this big number, 234 million trillion hashes per second. Means this person, not actually this person, this mining pool is actually generating, or I will say is able to generate around 47% of this 234.365 million trillion hashes per second. So if you will combine this mining pool power, they are generating this nonce in this amount of rate. And if you will see the smallest mining also, it will be around, I think, 1%. Let's say this is around 1%. Then also, if you will see, this number is a pretty big number. And that's why if you will see, I haven't included this 234 in the calculation. I was only assuming that the hashing rate, the current hashing rate, is only around million trillion hashes per second. That's why I have just taken 10 to the power 6 into 10 to the power 12. I have divided this number by this 4 into 10 to the power 9 by this number, right? So you can clearly see that if we will combine the mining pools, the power of the mining pools when they are working together, the hash, the nonce are actually getting exhausted in less than 1 second. So now again the question arises, what the miners will do in their idle time, right? Again, this question arises, what the miners will do in their idle time, because in less than 1 second, they're exhausting all their nonces. And we will see the answer to this question. Now in this video, we are going to talk about Mempool. So let's start. So if we talk about our previous video where we saw that the current hashing rate is around 234 million trillion hashes, right? For the overall Bitcoin network, okay? Since we are talking about Bitcoin, so it is around 234 million trillion hashes per second. And we also saw that if we talk about the number of nonce, we have only 4 billion nonce, that is 4 into 10 to the power 9 nonce. And if we will divide this by this total number of hashes per second, we can clearly see that 4 billion nonce will get exhausted in just 4 into 10 to the power 9 seconds. That is very, very, very less than 1 second, right? And we ended our previous video by this question: what should the miners do in the idle time? Because in less than 1 second, all their nonces will be getting exhausted. Now they do not have nonces, and if they do not have nonces, they cannot generate hashes. So they will reach the target, right? So what they will do in this 1 second period of time? So should they wait for timestamp to change that after 1 second and then they will start again the nonce process? Or there is some solution to this problem? And there is a solution to this problem. And the solution is the transactions. As we know that our Bitcoin block consists of number of transactions, which we have seen in our previous video as well, right? So by changing the transactions, you will see, by changing the transactions, we can change the hash, right? Because transaction is also one of the fields that we give to our SHA-256 algorithm. And when we will pass our transaction to our SHA-256 algorithm, then the output will also be generated. And if we will change the transaction, so because transaction is one of the input of our SHA-256 algorithm, in that case, output of our SHA-256 algorithm will change. Hence, we will have a different kind of a hash, right? So now the question arises, from where these transactions come from? These transactions actually come from an area that is called Mempool. And we will talk about Mempool in detail in our next video. But for now, just imagine that Mempool is an area, okay, from which miners pick your transaction. So whenever you do a transaction, let's say you are sending some Bitcoin to your friend, this transaction will be transferred to this mempool, okay, which is an area where all the transaction will be there. And from this only, miners will pick your transaction. So you can clearly see that I have, not actually, I have this mempool have a number of transactions, right? And this thing that you are seeing, FF3ABC, D23ABC. So this is the transaction hashes and this is the fees, okay? Because as we know that miners also take a little bit amount of fees whenever they are processing your transaction, because they are, they are doing a lot of work there, right? They are solving this mathematical problem, and solving this mathematical problem requires a huge amount of energy, and for that they charge this a little bit amount of fees for your transaction. Okay, so this is a very simple process. So here you can see that there are a lot of there are so many transactions. So there will be so many people who are doing some transaction. These transactions are actually being the part of this mempool, and now miners will pick their transaction from this mempool only. Now let me ask you a question. If you are a miner, okay, let's say if you are a miner, then which of these following transaction you will pick and put it inside your block? Okay, so let's say there is a transaction, there are a lot of transactions here, right, in this mempool, and now you are a miner and you have to create this block, and in order to create this block, definitely you need some of these transactions, and you need to pick some of these transactions into this block, and let's say you can pick around 4 transactions from this mempool. So my question to you is, which of the following transaction you will pick from these eight number of, I think there are eight number of transactions given in the mempool. What you will choose? Pause me for some time and answer me in the comment section of this video. Okay, and see whether you are right or not. So I hope you have answered to the question in the comment section. Now let me tell you which of the following transaction the miner will pick. So you can clearly see that from among these transactions, this transaction, if you will see, has the most amount of transaction fee. And since you are a miner, you want to make some profit, then definitely you will pick this transaction as your first transaction, and you will put this transaction in your Bitcoin block, right? Second transaction that you will pick, since I said, right, you can pick 4 transactions. So definitely you will choose this transaction, because in this you are getting a transaction fee of 0.06, and in the same way you will choose this 0.05 and then 0.04, right? Because these transaction have the most amount of fees, and you will take these transaction, you will put this transaction to this Bitcoin block, right? Simple as it. Now you can clearly see that these transactions are also part of your Bitcoin blockchain, and when there will be a change in transaction, your hash will also change. Now let us go back to our question, that what happen if all the nonsense will get exhausted in less than 1 second? Let's start with that question, or let us start with the solution of that question. So let's say this is our clock, this is our beautiful clock, okay, and this is our current timestamp at 58, okay, which has not changed yet, okay. Let's say this is our nonce, okay, that we are using, and let's say in less than 1 second, in less than 1 second, you can just see the clock, just see this clock carefully, okay, just see this clock carefully, and you will see that in less than 1 second we have exhausted all our nonces, right? And still the timestamp is the same. Now what miner will do in this case, because nonces are exhausted, he cannot depend upon the timestamp, he can only do one thing in this case, and that thing is transactions. He can change the transactions given in this transaction block. And how he will do that? He will pick up a transaction which is having the least amount of value, okay, which is this 0.04, and he will replace this transaction with a transaction which is just below this 0.04, means below in the sense which is having a transaction fee of just less than this 0.04. And if you will see in this mempool, the 0.02 is a transaction which is having a transaction fee of just less than 0.04, right? And he will replace these 2 transactions. Now, as soon as he will replace these 2 transactions, right, you can clearly see that now miner can again use back all the nonsense, right? Because once he will change the transaction, the hash will change, right? Now he will have a different kind of a hash, and now he can again change these nonsense in order to generate the target hash, right? I hope this makes sense, because earlier, if you will go back to this situation, we were having some kind of a hash, right? And by changing the nonce, we were not able to reach to our. Now once we will change the transaction, like in this case we have replaced the 0.02 with 0.04. Now this hash will change, so now we can again reuse our nonce, right? Now let's say again he will start the same process, he will generate some nonce, and only less than 1 second he again, if you will see, he has again exhausted with all his nonce. Now what he will do? Again, he will check which transaction is having the least amount of value. In this case, you can clearly see it is 0.02, and he will replace this with this 0.01, right? He will not replace it with this 0.04, because again he will land up to the starting, right? So he will replace this 0.02 with this 0.01 transaction, And now again he is having an authority, or I will say not an authority, again is having a power to reuse the nonce, right? And again you can clearly see that a timestamp is still not changed. So again he will start the nonce process, and boom, in less than 1 second he has again exhausted with all his nonce. Now what he will do, he will again do the same process again and again. He will replace this 0.01 with this 0.008, right? Now he will again start the same process. This is a repeated process, right? And again you can clearly see that he has exhausted with all his nonce, and let's say miner was not able to find the solution with the help of this nonce also. Now what will happen, because now you can clearly see we are taking an example here, or assumption here, that we have exhausted with all our transaction in our mempool. Okay, we can take this assumption. Definitely there can be thousands of transaction in our mempool, but I am taking this assumption that we have exhausted with all our transaction in our mempool. Now what miner will do in this particular case? And the answer is, if you will clearly see here, the timestamp will change after this 1 second has passed, right? Till now, the cases that we were dealing with were less than 1 second, right? So we started with this less than 1 second, less than 1 second, less than 1 second, and now we have reached our 1 second. Now, once we will reach our 1 second, boom, our timestamp will change. And since our timestamp has changed in this case, now you can clearly see that the miner can again restart the process of nonce. He will again take the transaction which is having the, he will again take the 0.04 which he has replaced earlier, so that he can find the solution. He will again take this 0.04 because this transaction is having the most amount of transaction fee as compared to the remaining transaction, and he will again start the process of this generation of nonce. And if he will be lucky, he will get the answer in this case. Otherwise, again the same process that we have discussed, right? This process will get repeated again and again till the time he will find his solution. So I hope this makes sense. Let me just give you a quick summary to you. If you are still not able to catch up with, just let me give you a quick summary to you once again. Okay. So we started with this position. Okay. And we exhausted with all our nonces in less than 1 second. So we replace our 0.04 transaction with 0.02. And now again, we will start with our nonces. Again, we exhausted with all our nonces. Still, we haven't reached to our solution. So what we will do again, we will change the transaction, means we will replace the transaction. So 0.02 was replaced with the 0.01. Now again, the mining process will start, and boom, again, you can clearly see that we are assuming that, okay, the miner was not able to find the solution and he has exhausted with all his nonce. Now what he will do again, he will again replace, replace this transaction, the 0.01 transaction with 0.08, and again he will start the same process. Okay, 0.08, and again he will start the same process. And once he will reach to this 1 second, and let's say he was not still not able to find a solution, he will do nothing. Just he will wait for the timestamp to change, and once the timestamp will change, again he will be in power to use the nonsense again, and he will also take back his piece, right? This transaction fee of 0.04. Why he's taking back his 0.04 transaction? First, this is the transaction fee, this transaction is having the most amount of transaction fee as compared to the remaining transaction. Second reason is because the timestamp is changed. So with the timestamp is changed, he will be having a different kind of timestamp, right? Not timestamp, actually different kind of a hash for this block, right? And due to which he can again use the nonces, and again the same process will start until or unless he will find the solution to his problem. So I hope you understood this by now. If you have still any doubts, please let me know your doubts in the comment section below. I will be happy to answer your doubts. Okay. And yes, let me tell you one more important point in this video, that never try to have a transaction fees which is too less. Okay. So always see that what is the current market transaction fee rate. If you will have your transaction fee too less, in that case, what will happen? Miner will never pick your transaction. In this case, because miner, let's say our miner was not having any option, right? That's why he picked this 0.008. But still, you can clearly see that 0.008 is way less than these transactions. So chances that this transaction will never be picked by the miner. Okay, so just be careful if you are doing any type of transaction, cryptocurrency transaction on a Bitcoin or any other type of a blockchain. Just remember that your transaction fee should not be so less that the miner will never pick your transaction from the mempool. Okay, and in the next video definitely we will talk about this mempool in much great detail. In this video we are going to see how mempool works behind the scene. So let's start. So this is our blockchain network. Okay, so this is our blockchain network and the systems that you're seeing here, right? So we are assuming that these systems, these computers that you're seeing on your screen are basically miners. And these people that you're seeing in black color, these people are basically representing nodes. Okay, so these are the people who are not doing any kind of mining. These are people who are just here connected to this blockchain network in order to do some transaction. Let's say this person wants to send some Bitcoin to this person, so that's why he need to connect it to this blockchain network. Okay, and in the same way, let's say these nodes also help in verification and validation of a block. So let's say if a block will be created, so these nodes basically can validate and verify a particular block. Now let me tell you one thing more, that there is no like any specific speciality or difference between a node and a miner. Basically a miner is actually a node only. Okay, so this is a node only who has actually opted for mining. So these people can also opt for mining. So do not just think that these two people are basically two different kind of a people. They are same, just the thing is that this node has opted for mining, and these nodes that you're seeing in black color, they have not opted for mining. Okay. Now, as we have discussed in our last video, right, that mempool is an area where we store all our unconfirmed transaction. So let's say if this person is doing some transaction, that transaction will go to mempool and miners will pick transaction from that mempool. And I have discussed this in great detail. If you haven't watched the previous video, please watch that video and then only continue with this video. Okay. Now, many of you might think that when I'm saying that mempool is an area where all unconfirmed transactions go, you might think that mempool is a centralized database. But that's not the case. Mempool is not a centralized database. Mempool is something which is associated with each and every node. So this mempool is also with the miners. This mempool is also associated with these nodes. Means these nodes, these miners has this area. So whenever you convert into node, so your system will be working as a database. You can think like your system is a database. Not your system is a storage, and in that storage, this mempool will be stored. So each and every person who is connected to this blockchain network will consist of this mempool. Okay. So if you want to have a mempool of your own, means not of your own actually, a mempool like this. So you just need to install a software called a Bitcoin client. And once you will install this software, you can also become a node, and then you will also have a mempool in your system. Okay, in your node. Okay, that's good. Now let's say this person that you are seeing here, this node, wants to do some kind of a transaction. So let's say this is our transaction ID and he did some kind of a transaction DF123. Now this information will be conveyed to the connected participants or the connected nodes. Now one thing important to note here is that you can clearly see that this transaction is at this point of time is an unconfirmed transaction. So until or unless this transaction will not be verified and validated by the miner and will go to a block, this transaction will come under the category of unconfirmed transaction. And this is a mempool. This green area that you are seeing on your screen is a mempool. Now this information will be conveyed to the, as I said, to the nearby nodes. Now once this information will be conveyed to the nearby nodes, this transaction will also be added to their mempool. And the same way, this information will be transferred to the remaining other nodes that are connected to this blockchain network. And by this, you clearly see that these transactions will be a part of each and every mempool. Okay. So any miner can pick these transactions from his mempool and he will be able to then start mining. Okay. Now let's say this is also one of the person who wants to do some kind of transaction. So let's say she did a transaction of ABC56 and this transaction will again be added to the nearby nodes. So this information will travel to the nearby nodes, and from the those, this information will travel to the other nearby nodes, and in this way you can clearly see that all these transactions be added to the mempool, and by this only this mempool uh, will be filled with all the transactions. Now, currently, what I'm showing to you on the screen is only 4 transactions here, right? But that's not the case. Your mempool can consist of thousands of transactions, but definitely I cannot illustrate that here. That's why I'm just showing you 4 transactions. Okay, so this makes sense, I hope. Now let us understand. So this is a process where we have seen that how an unconfirmed transaction goes to the mempool. Now let us understand how this unconfirmed transaction is taken from the miners, means how miners take these transactions from the mempool and create a block with this. So let's say, uh, definitely since this is a blockchain network, so each of the nodes will have a blockchain, right? Exact copy of the blockchain. I have discussed in the starting lecture, right? That blockchain is a distributed immutable ledger. And as we know that people are miners, so they will start mining for the Bitcoin. Now let's say this miner was the first miner who was able to solve this mining problem. Okay, he was able to solve this mining problem, and that's how he was able to create a block. And since he has now the capability to create this block, he can add these transactions to this block. Okay, now once he will add these transactions to this block, he will convey this information to the nodes, to the nearby miners, that okay, I have created this block and I have I have used this, like I have put these transaction into my block. Please confirm, please verify and validate my block whether it is correct or not. Now these nodes will start verifying and validating these blocks, and once they will verify and validate and say that okay, this block created by this miner is a correct block, they will add this block to their blockchain. So you can clearly see that. So this information has traveled to this and this person, and that's why they have added this block to their blockchain. And once they will add this block to their blockchain, these transactions will also move from this unconfirmed category to the confirmed category, because now a block is created and any transaction within the block is a confirmed transaction. Now this information again will be conveyed to the remaining nodes. They will also create a block, will also take the remaining the transaction from this mempool, and they will add it to their block. And in the same way, others will also do. And this is how you can clearly see that transactions are taken from this mempool area to the blockchain area. Okay, so transactions are getting like these unconfirmed transaction which belongs to mempool are now becoming confirmed transaction once they are a part of this block of the blockchain. And this is how mempool works. But let me show you mempool in real life also. So how does mempool looks like? So this is our blockchain.com unconfirmed website, and I have chosen this unconfirmed transaction, and now you can clearly see that this is how mempool looks like. So what they are doing is they also this company blockchain.com is running a node, and now they're displaying the data on our screen. So you can clearly see that each and every time one of the transaction is being added to this mempool, and all these transactions are basically unconfirmed transaction, and this place is nothing but this place is a mempool. Now from this unconfirmed transactions only, miners will pick some of these transactions and will add to the block of the blockchain. And once they will verify and validate those block, means from the other participants of that blockchain node, once they will verify and validate this block, then these transactions will become a confirmed transaction. So I hope this makes sense. Do check out this website. This is a great website if you are looking for some practical insight about Bitcoin or Ethereum or any of the like blockchain. So mainly I think they deal with Bitcoin and Ethereum, and then Bitcoin Cash and all those things. But still, I will definitely suggest you to do come and visit this website. Hi. In this video, we are going to talk about transactions and UTXOs in Bitcoin blockchain. So let's start. So how transaction actually occurs in a Bitcoin blockchain, okay? So let us understand that. If you will understand this, you can easily understand how transactions actually occur in any other kind of a blockchain, okay? So this is very important lecture. So just be a little bit more, I will say cautious, a little bit more aware during this lecture. So let's say some of my friend, okay, let's say Arjun, one of my friend, transferred me some 0.4 Bitcoin to me, okay? In the same way, there is some friend of mine, Raj, who also sent me some 0.3 Bitcoin, Alice, and Bob. So here you can see that all these people, Arjun, Raj, Alice, Bob, all these people have sent me some amount of Bitcoin, right? And these transactions that you are seeing on your screen are basically called as UTXOs. Now, what is the full form of UTXOs? These are unspent transaction output. Unspent transaction output, or you can call them as UTXOs. Now, let's say I want to buy this coffee, which is of zero point 0.5 Bitcoin. Definitely a very costly coffee, but let's say I want to buy this coffee of zero point 0.5. Now, how this transaction will take place? Okay, so let us understand this. Now, if we talk about a normal bank transfer, right, or a normal bank, I will say transaction, how it will work. In a bank transaction, what will happen? Let's say if I have to buy this, let's say 0.5 rupees or for 0.5, then in the bank statement, what you will see is that you will have some total amount that is 0.4 plus 0.3 plus 0.7 plus 0.1. So you might have seen this also, right, in your bank statement that you have some this total bank account balance. And from that total account balance, from that total bank account balance, some amount get deducted, right? And this is how a normal transaction, bank transaction looks like. But in case of Bitcoin, this is now how it works. Okay. In case of Bitcoin, what will happen? So understand how this transaction will take place in the Bitcoin blockchain. So first thing that we will have is the input. Okay. So we will have an input. And from this UTXOs, from this unspent transaction output, our wallet, because we are not going to do that, our Bitcoin wallet will select a UTXOs, which will help us in buying this 0.5 Bitcoin coffee. So either we can go for this 0.4 Bitcoin plus 0.1 Bitcoin UTXO, or we can select any other UTXO given here. Like the 0.3 Bitcoin UTXO we cannot select because this is not this will not be helpful, right, to buy the 0.5 Bitcoin. But we can select this UTXO. So this is a total random process that is done by your wallet. Just selecting this Alice UTXO. Definitely you can also go for the 0.1, 0.4, but we will talk about this case in our upcoming videos. But in this case, let's say that this UTXO was selected from our by our wallet. Okay. Now this UTXO will be divided into two. First UTXO, the first output actually will be 0.5 Bitcoin to the coffee shop. Okay. So 0.5 Bitcoin will be given to the coffee shop so that we can buy the coffee. The remaining UTXO, that is 0.5, 0.7 minus 0.5, that is 0.2 Bitcoin, will be written back to us, right? Because this will work as a change. We are giving 0.7 and 0.2 Bitcoin is written back as a change, right? Now, this transaction that you're seeing, right? This output that you're seeing, this will be a UTXO for the coffee shop. And this thing that you are seeing, this transaction that you are seeing, this output that you are seeing, this will be the UTXO for our wallet, okay, for our cryptocurrency wallet where we have all these UTXOs. Now, this is something very different from a bank transaction, right? As I said, in a bank transaction, what will actually happen? From your total savings, some amount will get deducted, and this is how the transaction will take place in a bank transaction, in a banking world, right? But in case of blockchain, this is now how it is done. And don't worry if you are still not able to get this particular example. We are going to have many examples in our upcoming videos. Then you will be able to understand this in a much better way. Okay. If you are still not able to understand it, if you are able to understand it, that's good. But in our upcoming videos, I'm going to take some more examples so that I can explain you this concept of UTXOs, because this is very important to understand. Okay. So we will see that. So this is how our UTXO field will look like. So we will have Arjun UTXO, Raj, Bob, and this will be a UTXO from me to me, right? Because I'm transferring 0.2 Bitcoin from my wallet to me only, right? So that's how this will looks like in our cryptocurrency, in our Bitcoin wallet. And yes, definitely we have also brought this coffee. Now let me take one more example so that you can better understand this. So let's say we have again these UTXOs and we want to buy this noodles, which is a very costly noodles of 1.4 Bitcoin. But let's say we want to buy this noodle. So how this input will work in this case? Let us see some different kind of example. Now in this case, let's say our wallet can select this 0.4 Bitcoin UTXO, then this 0.3 Bitcoin UTXO, and then this 0.7 Bitcoin UTXO. So our wallet is selecting all these three because 0.4 plus 0.3 plus 0.7 will be equal to 1.4 Bitcoin. And then this will be, now this is while this was our input and there will be an output. Now this will be transferred to our noodles shop only, right? Because we do not will be having any remaining amount of UTXO in this case, right? Because there is no change. So this output will become the UTXO for our noodle shop. Okay. So this is how it will work when we are adding all those. But still, we will see some more example in our upcoming videos. And yes, this will be the only UTXO that will be left in our wallet, because all these UTXOs, this Rajan Raj Alice, we have spent all these UTXOs. So in our wallet, we will be seeing only this UTXO. Okay. And why this is done, like why this is so complicated? Actually, this is done so that in Bitcoin blockchain, we can have a track of each and every transaction and we are not missing any kind of a transaction. That's why we are doing all these complicated stuffs so that we can have a track of each and every transaction that is happening on Bitcoin blockchain. Now, in this video, we are going to talk about transaction fee. So, in the previous video of UTXOs, we talked about how UTXOs work. And if you haven't watched the previous video, please watch that video. Now, in this example that we have discussed in our previous video, so these were our available UTXOs. Like someone has done some payment, and these were the available UTXOs in our wallet. Now, once we will do this payment for the coffee, one of the UTXO will be selected from this given set of UTXOs. And let's say in this case, we have selected this 0.7 Bitcoin from Alice UTXO. And once we are doing this payment, you can clearly see that this UTXO is being divided into two parts. First is 0.5 Bitcoin to the coffee shop because we want to buy this coffee. And the second UTXO is this 0.2 Bitcoin, which is given back to us. Just like we are actually given back the change, right? So we are providing some additional money and the shopkeeper is giving us back the change. Now there is one problem. The problem is that we haven't considered the transaction fee. So whenever we are doing some kind of transaction, in this case, we are doing a transaction, right? We are spending some Bitcoin to buy this shop, to buy this coffee. So we are doing some kind of a transaction. And in order to process this transaction, we need to pay some amount of transaction fee to the miner, because miner will be solving a mathematical problem. He will be taking our transaction to create a Bitcoin block, and then only our transaction will get processed. Now, in order to make our transaction get selected from the miner, we have to pay a certain amount of transaction fee. So that transaction fee can be anything. But in this case, let us assume that we need to pay a transaction fee of 0.1 Bitcoin. So now what will happen? The 0.7 Bitcoin that you are seeing on your screen, it will not be divided into 0.5 and 0.2 Bitcoin, but it will be divided into 0.5 Bitcoin and 0.1 Bitcoin, because 0.1 Bitcoin will be the fees that we are paying to the miner. Okay. And now the UTXO will look something like this. So this UTXO will be given back to us, right? It will be the part of our UTXOs field. This UTXO will be the part of our coffee shop owner. And this UTXO, the fees that we are giving, right? This fees 0.1 Bitcoin, this will be given back to the miner. And this is how actually UTXOs work in real life. Okay. So remember this, whenever you are doing any kind of a transaction, so in that transaction, you need to pay some amount of fees to the miner, and that fees will also be considered as a UTXO for the miner, because it is like you are paying something to the miner. So it will be a UTXO for miner's wallet. So this is how our UTXO field will look like after we will do payment for this coffee. Hi, welcome back. Now in this video, we are going to talk about cryptocurrency wallets. So if we talk about cryptocurrency wallets, and if you have seen any cryptocurrency wallet, if you have, let me show you cryptocurrency wallet. I have this MetaMask wallet. So in this MetaMask wallet, what you will be seeing is that MetaMask wallet is actually showing me the total amount of cryptocurrency that I have in my wallet, means in my account actually. Now this is actually Rinkibi. This is actually test network. Actually, it is a. These are just generally these are actually fake. Okay? So just do not confuse it with real ethers and try to hack my account or something. These are fake ethers actually. So these are on test network, and we will talk about these technical details, what are test networks, what are fake ethers in great detail in our upcoming courses, but this is not the part of this particular course. Okay. So in this, if you will see that I have this amount of balance in my wallet, so this arises a question, right? That whether cryptocurrency wallets are actually storing our balance, right? Because it is showing our balance. So it might be that whenever we are getting some amount of cryptocurrency, it is getting stored on this wallet. But this is the case or not, we are going to answer this in this video. Okay. And this will be a very useful video for you to just watch this video full. Okay. So currently you can see that I have 4 blocks here. Okay. And in all these 4 blocks, we have certain transactions. So if you remember from our coffee shop UTXO video, if you do not just see this screenshot I am attaching here. So here you can see that I have all these transactions done to me, and all these transactions I'm showing on this block number 1. So I'm assuming that all these transactions that are done to me are actually the part of this block number 1. This is just an assumption, okay, so that I can explain you this concept about cryptocurrency wallets. So this is just an assumption. This another set of transaction, the transaction that I am doing to the coffee shop, I am assuming that these are the part of this block number 2. Okay. In the same way, and yes, one more thing, that this transaction that you're seeing, right, ls to me, this transaction is actually getting used up. Why? Because I'm using this 0.7 Bitcoin from ls and I'm giving it to the coffee shop and 0.2 back to me. And these are the part of this block number 2. So I'm completely using up this ls to me transaction, right? Now, in the same way, if you will remember from our noodle shop UTXO example, in that case, if you will see, I have some more amount of transaction done to be. And let us assume that, okay, my friends are a little bit generous and they are doing some more kind of transaction. They are sending me some more Bitcoin to my wallet. Okay, just an example. And all these transactions are part of block number 3. And the transaction that I am doing to the noodle shop is a part of this block number 4. Okay. Now in this also, if you will see, this Arjun to me, Raj to me, Alice to me, all these 3 transactions are getting used up so that I can pay to this noodle shop, right? And I have shown this here also. Now let us discuss about those transactions that we are not spending. So if you will see this transaction which is done to me by Bob, we are not using this transaction. We are not using this transaction which is done to me from me only when I was giving the change. And if you will see this Arjun to me transaction, Raj to me transaction, Bob to me transaction, all these transactions are those transactions which are done to me, means I was the receiver and I haven't used up these transactions. While if you will see these green transactions that you can see here, green circles, all these transactions are those transactions which are actually used up transactions, means they do not definitely they belong to the blockchain, but we do not care about it, right? Because now we have used all these transactions. And the remaining transaction that I'm showing with the help of an arrow, not actually arrow, because like this transaction, actually what I'm trying to say, like this transaction where I'm doing a transaction to this noodle shop. So this transaction is a transaction where I am the sender, I'm not the receiver, right? So I am the sender here. In the case of this also, me to coffee shop, I am the sender. So this transaction is also I'm not highlighting with yellow because I am the sender. I am detecting some balance from my account to pay this coffee shop, to pay this noodle shop, right? Now, let us see how actually cryptocurrency wallets work. Whether, like, since we have this question, right, cryptocurrency wallets are storing our cryptocurrency or not. Now, with the help of this example, it will be very clear that cryptocurrency wallets are not actually storing our cryptocurrencies. So, what cryptocurrency wallets are actually doing is they are keeping track of all these yellow UTXOs, means those UTXOs which we haven't spent, like this green one, and those UTXOs in which we are the receiver. Because once we are receiving something, that will be the part of our balance, right? So cryptocurrency wallets are just keeping the track of all these UTXOs by talking to the blockchain that you can see here, right? They talk to these blockchain, the different blocks of the blockchain. And from that only, they are able to keep the track of all the unspent transactions that are done to me. And then what they do, they up the value of all these transactions. And by that, they are able to determine the total amount of balance that I am having on my account, in my account. So they are not actually storing our cryptocurrency. They are just keeping the track means they are just keeping the track on these blockchain, the different blocks of the blockchains, and by that they are able to calculate the total amount of balance. So they are just displaying the total amount of balance. They do not have our cryptocurrencies in any way. They are not in a position to do anything with our cryptocurrencies in any way until or unless it is a centralized wallet. So we have different kind of wallets, we have different kind of exchange, like we have centralized exchanges as well, we have decentralized exchanges. So the wallet that I have shown you, right, the metamask wallet is actually a decentralized wallet. So metamask wallet is not storing our cryptocurrencies, or metamask wallet is not in a position to manage our cryptocurrencies because the total control of our cryptocurrencies is in our hand only. Metamask cannot do anything in that case. Okay, so by this, remember that wallets, if a wallet is a decentralized wallet, they do not keep track of our cryptocurrencies. But definitely, if you are using a centralized exchange or a centralized wallet, chances are high that they are actually storing all your cryptocurrencies and they are displaying the result to you on your wallets. Okay, so be aware about this also. Whenever you are trying to use any cryptocurrency, try to go for a decentralized exchange, try to go for a decentralized wallet, but definitely see whether it is safe or not. Okay, just do not blindly go to any decentralized exchange or wallet. The point is that, remember this thing, that I do not want to go into the detail of the trading and all those things. The point I want to make clear is that decentralized exchanges, decentralized wallets are able to keep track of your cryptocurrencies by this method, by keeping the track of the different transactions that are happening on the blocks, and then they are fetching those results and showing you to you in the wallet so that you can see easily on the UI part of the wallet. Okay, now in this video we are going to talk about private and public key, and this will be an important video, so please be with me. So in the previous video, what we have seen is that whatever transaction that we do get actually stored on our blockchain, right? And we also discussed about the cryptocurrency wallets, how they work. If you haven't watched the previous video, please watch it. Then you will be having a better clarity during this video. Now, the problem with this model is that there is no central authority who is actually verifying who is actually doing a transaction. Let's say, for example, like you can clearly see that there is a transaction, right? Bob is sending some Bitcoin to me, zero point 0.1 Bitcoin to me, right? But how and who will actually verify whether this Bob is actually doing a transaction? And this zero point 0.1 Bitcoin is actually being sent by Bob. We do not know, right? If we talk about banking system, they have their own identification function. So with of which they are able to verify, okay, this person is sending some amount of money to this person. So they are able to verify all of those things. But in case of a decentralized financial system, if like it is a decentralized financial system because we can send transactions, right? We can receive Bitcoin actually. So it is a kind of a decentralized financial system, right? So in this case, you can see that there is no central authority who can verify whether the transaction is being done by a particular person or not. Just imagine a situation where a miner is keeping some fake transaction in these blocks because miner have the authority of mining transactions, right? Of creating. So what they can do is they can generate some fake transactions. Let's say they can generate some transaction of A is sending some Bitcoin to them, and they can have this transaction in these blockchains, right? Now, if this will happen, in that case, the whole financial system of blockchain, of Bitcoin blockchain or any other blockchain will collapse. So, how this verification and validation of a transaction takes place, we are going to see that in this video. So, this verification and validation of a transaction takes place with the help of two keys. First key is our private key, and second key is our public key. So, let me show you this private key and public key in my MetaMask wallet. So, this is a wallet that I have talked about right in the previous video. So, let me enter my password here. Okay, so this is my MetaMask wallet, and in this, if you will see this is an account, right? So this is an account. So let me do one thing. Let me go for account details. Now if you will see that this is my account, this account is nothing but this is account is actually our public key. But definitely we will talk about this account in more detail in our upcoming video. But for now, you can think of this account address as our public key, because this will be the address that we will be sending to other person whenever they want to transfer some Bitcoin or some Ether to our address. Okay, and I will show you that, so don't worry about it. So another thing, if you will see, let me show you the private key of this account. Account details, I think export private key, yes. So let me type my MetaMask password. Now remember one thing guys, that this private key is something that you should never disclose to anyone, because I'm using fake ether here. Definitely if I will be having some real ether, I will not be showing you this private key, because this is something very confidential that you should never share with anyone. And that's what MetaMask wallet is also saying, that never disclose this key. Anyone with your private keys can steal any asset held in your account, because this private key will actually act as a signature. Okay, I will talk about this in great detail, just don't worry, just see this, that this is your private key. Okay, so this is your private key, so this is your public key. And let's say I want to send some ether to some different account. Let's say I have another account. Okay, no issues. What I will do, I will send some ether to my account only. So let me do that. So I will copy this, I will send, I will send to. So you can clearly see that I am this is actually the sending address, this is actually the public address where I want to send some ether. I'm taking the example of ether because this is Rinky test network actually provides us with Ethereum transactions. So don't worry, whether it is Ethereum or whether it is Bitcoin, because concept remains the same. Okay, so let's say I want to transfer some 0.0001 Rinky ETH, and when I will click on, you can clearly see that. So this transfer of ether is actually taking place from my account to the account that I am sending ether to. So when I'm sending this ether, I will be signing this transaction with my private key, stating that this transaction is actually done by me. Okay, and to whom I am sending this transaction is the person. I'm having the public key, or you can think of it as address or public address of that person where I'm sending this ether to. So when I will click on confirm, so this transaction will take place and some amount of ether will be transferred from my account to some other person account. Okay. Now the question arises, as I said, who will verify this? Whether the transaction that I have done right now in front of you, whether that transaction is actually done by me or by some other person. So let us see that. So for that, we have something which is called as verification function. Let me show you that. So this is our message. Message means this is our data, or you can think of it as transaction also. This is our private key. I have shown you this, right? Now with the help of this private key only, our public key is actually generated. Okay. So this private key is something that you keep with you only. You never share this private key with anyone in the world, and this public key is something that you share with anyone from whom you want to receive some amount of cryptocurrency. So you can think of private key as your email address password and public key as your email address. So you can share this public key with anyone, but you cannot share this private key with anyone. Okay, now since this is our message and we want to make sure that this message is actually signed by us, so what we will do is, with the help of this private key, we will sign this transaction. Now when we will sign this transaction, what we will have is a signature. Now in order to verify whether this message or this transaction is being signed by me or not, what we will be having is a verification function. Now we will pass as an input to this verification function this message, the transaction that we have done, this signature, okay, the signed message that we have done, and the third thing is our public key. When we will pass these three things to this verification function, this verification function will either give in the output in either in yes or no. If the output is yes, then we will say, okay, this message is actually being done by this public key only, means this message, this transaction is actually done by me or the person who is actually doing this transaction only. And if this verification function says no, then we will say that, okay, the person who is doing this transaction is not the right person, and then we will this verification function will give an output no, with the help of which we will be able to verify whether this message is a correct message or a corrupted message. Okay, so this is a very simple process. We will talk about this in much more detail in our upcoming videos. This is just to show you an overview of how private key and public key is actually used in cryptocurrency transactions. Hi, now in this video, we are going to talk about public key and private key demonstration. In the previous video, we have seen how we can use private key and how we actually use public key and everything in detail, right? Now in this video, we are going to see a demonstration for it. So let's go to this website and just search for this super data science public key, and you will find this link. Okay, this first link, public/private key pairs. Just click on this. Now, once you will click on this, you will see that you will have two things, that is your private key and as well as your public key. Now, by clicking on this random function, you can have different private keys and different public key. Let's say if I want to click on this, so if you can see, right, I'm just clicking on this random function. And as I'm clicking on this random function, my public key is also getting changed, because as we have discussed in our previous video, with the help of private key, we generate our public key, right? So let's say if I'm having something like this, so you can clearly see that as I am changing the private key, I'm removing some elements from the private key, my public key is actually getting changed, right? Now, remember one important point, that never have your private key too short, because if you are going to have your private key too short, in that case, what will happen? Anyone can guess your private key, and on behalf of you, they can do transactions. So, which I don't think so you want it. So, do not create your, I will suggest you that do not create your private key, because when you are going to create your own private key, chances are very high that it can be easily guessed, because humans are very poor in creating random numbers, okay, in generating random numbers. That's why we have computers. So let the computer do this work. Do not do that. Just for demonstration purpose, I'm showing you that by changing the elements here, you can have your different set of private key. I think that does not support the alphabets, that's why it is not changing, but no issue. So let's have number only. Okay, right. Now let's go to the signatures part. So in the signatures part, as we have discussed, that with the help of our private key, what we do, we generally verify that the message that we are doing, the transaction that we are doing, is actually done by us, right? So let's say this is me, Chitij. I know it is a complicated name. So Chitij sends some Bitcoin to, let's say, Raju. Okay. So we have Chitij, we have Raju. This is our message. So I want to sign this transaction. I want to sign this transaction. So what I will do, I will just click on this sign. Now, as soon as I will click on this sign, you can see that I have this message signature. And you cannot change this message signature, because this is something which is actually being done by using your private key and by using your message. Okay. So for different messages, you will see different kind of message signatures. So let's say if I'm changing it, okay, some random text. Now if I will click on sign, okay, I think it is not supporting alphabets. That's why. No, I don't think. I think, oh no, it is supporting alphabet. I just do not I do not see that it is changing the signature. It is too long, right? So you can clearly see, right? As I'm changing the message and I'm signing it. Okay, I'm not changing. So now I'm changing the message and I'm signing it. So you can see that I have a different message signature, right? Private key is the same. Definitely you can change this private key also. Let's say you want to have some different private key like this. And if you will click on sign, you will have a different kind of message. Okay, message signature actually. So this is how this works in practical, right? Now let me show you this verification function also. So as we have discussed in the previous video, that for verification, we need message, we need public key, as well as we need signature, right? And you can see that we have all three elements here. When I will click on this verify, you will see that this will turn into green color. So let's me click on this. So now you can see that it turns into green color. And if I'm going to change anything and then I'm going to verify it, then you will see that it will turn into red color. So let's say I am manipulating this message. Okay, I am a hacker and I'm trying to manipulate this message. I'm trying to change some data from this message. So what I am doing is I am just, instead of sending transaction money to Raju, I'm sending this money to me. Let's say, okay, so let's say this is me, just like this only. And now if I will click on verify, you will see that it will turn red in color. Why it get turned red in color? Because the message, because the signing that we have done was for actually Chitij to uh, Raju, right? But now we have changed the message. We have manipulated the message, and since we have manipulated the message, that's why when we are doing this verification, it is turning into red. Okay, so if anyone is changing the message or public key or signature in any way, then this verification function will always give red color, or I will say no as an answer, and this verification will not be done. Okay, and if it is turning green in color, means if the verification function is sending an output yes, then it is working perfectly fine. Means your message, public key and signature, everything is fine and you can work with this. Okay, So I hope you enjoyed this video, this demonstration video. I will meet you in the next video, and definitely if you have liked this video, please click on that like button. If you are new to this channel, please subscribe to this channel because I'm regularly going to upload new blockchain courses on this channel. And yes, meet you soon. Take care. Bye bye. If you have any doubts, comment below this video. Okay. Now in this video, we are going to talk about public key versus Bitcoin address. So if you remember from our previous video where we talked about private and public key, where we talked that with the help of this private key, we generate this public key. And let's say if we want to do any kind of transaction, or let's say we want to do any kind of, we want to send any kind of message, then we sign this message using this private key, means we take this private key, this message, and with the help of which we generate a signature, right? And then we take this signature, this message, and the public key to this verification function, and with the help of which we can verify whether the transaction, whether this message is actually being sent by us or not, right? And if you haven't saw the previous videos, please saw this video. I have talked about this in detail. Now in this example, we have more entity, and that entity is Bitcoin address. Now what is this Bitcoin address? People think that Bitcoin address and public key are the same thing, but that's not the case. Bitcoin address is an address at which you receive Bitcoin. So let's say you have a friend and you want to receive some Bitcoin from your friend. So what you will send is your Bitcoin address to your friend, and then your friend will transfer some Bitcoin to that Bitcoin address. People think that public key is actually being sent, but actually Bitcoin address is being sent in order to receive Bitcoin here. Okay. Now, what is the use of public key? So public key, as we can clearly see, it is actually used for the authentication, right? So whenever we are doing some kind of transaction, let's say I'm sending some Bitcoin to my friend, in that case, I will be using my public key. So public key is a different thing and Bitcoin address is a different thing. Now, there might be some questions here that why do we have public key different, even though public key is something that can be, that can be public in nature. So why do we not send our public key for receiving Bitcoin? Why do we have this special Bitcoin address? And the reason for this is that we want to make our system more secure. By sending our public key, we are actually making ourselves more, I will say, vulnerable, because now we are sending our public key to each and every one person, and might be in future there might be I will say 0.00001 possibility that with the help of our public key we might trace back to our private key. But that's not the possible case, because we can only go from private key to public key. We can never go back from public to private key. But there might be any case in future, must like any invention or something like that, there can be a situation where we are able to go back from our public to private key, from this public key to private key. Now that will be a very dangerous situation. Now to have some additional layer here, to have some additional security layer here, what we have done is we are generating a Bitcoin address from this public key. So let's say if someone is trying to decode this Bitcoin address, might be, again this is a might be case, a very less probability case. If something happens in the future also, then also they will be able to go back to the public key, but not directly to the private key. So we are actually adding one more security layer here, so that nobody can go to this private key, because private key is something that needs to be private. If someone is having access to our private key, they can take all our funds, they can manipulate all our funds, means they can do anything with our cryptocurrencies that we have in our wallet. So that's why we have this public key as well as this Bitcoin address. Bitcoin address to receive Bitcoin, public key for the verification of this, for the verification of this, for a verification of our transaction. Okay. So if we talk about a Bitcoin blockchain, a typical block of a Bitcoin blockchain is of size 1 MB. Okay, so in this 1 MB, we have the block number, some different fields like, as we have discussed, timestamp, nonce, and other fields as well. As well as we have a lot of transactions. Definitely, I'm showing only 3 transactions here, but definitely there are more transactions here. These are the transactions ID, by the way. And this is our previous hash, this is our hash. So you can see that this 1 MB of block is containing so many things, right? And not only this thing, this 1 MB block also contains some more information about the transactions, because we cannot only depend upon the transaction ID, right? We need some more information about the transaction, like who is doing this transaction, to whom this transaction has been done, the amount of Bitcoin that has been sent, as well as the signature and public key. Why do we require signature and public key? As we have discussed in our previous video of private and public key, where we talked about that signature and public key is required so that the other person can verify whether this transaction is actually being done by me or not. By me as in, like in this case, X is doing some transaction. So to verify whether X has actually done this transaction or not, signature and public key is required, and we have discussed this in the previous video, right? So you can see that transaction is involving so many different fields also. And this script sig, means this signature as well as this public key, acquires around 60 to 65% of space. Now just imagine we have an MB block where 60 to 65% of space is actually being acquired by this signature and by this public key, which is not a good thing. Why? Because if this thing is acquiring around 60 to 65% of space, then we have few space left in order to have our transactions. Means if we will cover this amount of space just by its nature and public key, then we will have only few transactions, right? Because if this is acquiring 60 to 65%, then we are left with only, I think, 30 to 35% of space for our transactions, which we do not want, right? We want to accommodate more number of transactions to our block. Why? So that more number of processing can take place, more number of transaction can be solved, means can be processed in per second. Like in the case of Visa, which is actually processing around thousands of transactions per second. And we also want the same with blockchain, right? With Bitcoin blockchain, because if we will process less number of transactions per second, then people will not be good, right? People will not be happy that, let's say, they have done some transaction and now they have to wait for, let's say, 3 to 4 days. And nobody wants this type of thing, right? Nobody wants to wait for 3 to 4 days for a simple transaction, which can be done using, via bank transfer, via Visa in just few milliseconds. So blockchain community decided something. What they thought, that instead of having this 60 to 65% of a space, this SegWit, this thing is actually called as SegWit, okay? SegWit as in segregated witness, okay? So SegWit is segregated witness because this is the witness that are doing this transaction. And what the blockchain community thought, that why not to remove this thing and said, like, let's send this thing separately. Let's do not send this thing, this 65% script sig within this block. Instead of this, why not to send this separately? So first you will have a block in which you will have all the transaction. Okay, so you can fully use the block for filling up the transactions. And once you have filled up the transaction, once you are done with the filling of transaction, now you can send this script sig afterwards. So by this, we are able to accommodate more number of transactions, by which the miners will be able to process more number of transactions per second, and by which people will be more happy in the Bitcoin community. So this was the suggestion that was adopted, and due to which we have this thing, this signature and public key, which is also known as segregated. Why segregated? Because now they have been segregated, means they have been detached from this, and now they are being sent separately in the Bitcoin network. Okay, so this is something very important to know, that now you have these things in nature and public key as a separate entity, and this transaction field and all these fields as a separate entity. Once your transaction is filled up, like once your block is created, then you send these segregated witnesses or script sig after that. Okay, so this is done so that we can have more space for our transaction, so that we can process more number of transactions per second. Okay, so this is all about segregated witness. Hi. In this video, we are going to talk about hierarchically deterministic wallet, or HD wallets. So let's see what it is and what is the use of HD wallets. So if we talk about our previous video, in that video, we have discussed that this Bitcoin address is actually used in order to receive Bitcoin, right? And this Bitcoin address is there so that we can have secure kind of transaction, because so that we do not have to reveal a public key every time we are doing any kind of transaction, right? So this was the whole purpose of Bitcoin address. But if I will tell you here that there is still one problem, one issue with this particular approach, where we are using only single Bitcoin address. And the issue is that there are privacy concerns. Now, what is this privacy concern? Since we are using the same Bitcoin address again and again to receive Bitcoin from our friends, from our relative, or from our customer, let's say if you are a business owner, So anybody can track my Bitcoin address transaction because I'm using the same address again and again, and everyone is doing all kind of transaction, all kind of Bitcoin to my this same Bitcoin address. So anybody can go to Bitcoin Explorer or any website like this, and they can search for my Bitcoin address. And once they will search for my Bitcoin address, they can see all kind of transactions that I have received, or all kind of Bitcoin that I have received from my friend or from my relative or any other person. Now, this is a dangerous kind of a situation, right? Because now any person who we do not know, any hacker or any scammer, can track down the pattern that we are doing. Means he can track down the pattern in transaction, that okay, this kind of like this particular Bitcoin address is receiving this kind of Bitcoin. So might be this person is a business owner, or let's say might be this person is a very rich person because he receiving constantly receiving some amount of Bitcoin to his Bitcoin address. So anybody can easily find out the pattern. Anybody can easily find out all the transaction that we are doing, and this is not we want to show, right, to all the person. We do not want to show this to the public. You do not want to show that okay, today you have brought some coffee or you have brought some clothes. You do not want to show this to the public that you are doing this kind of transaction. So what is the solution to this problem? What we can do in order to prevent from this problem? What we can do is we can use HD wallets. So what are HD wallets? HD wallets are those wallets which actually provide you functionality to have more than one Bitcoin address. If you talk about early cryptocurrency wallets, those cryptocurrency wallets only give us the functionality of having one Bitcoin address. And the problem, as I said, was that anybody can easily find out the type of transaction you are doing. Okay. So with the help of HD wallet, what we have is now is a master private key. So this HD wallet provides us with a master private key, and this master private key is actually used to generate a private key, and this private key is used to generate a public key, and with the help of which we can generate a Bitcoin address. And not only this, now what we can do is we can add one, let's say we added +1 to this private key. So now we have an entirely different kind of private key, and then we can use this second private key in order to generate second public key and in order to generate second address. And in the same way, if you will see, we can continue on. So we can have numbers of private key, we can have hundreds of private key, and we can have hundreds of Bitcoin addresses, and with the help of which nobody can track out who we are or what we are doing actually. Now remember, I'm not saying that by tracking your addresses anybody can find out your home or your name. No, I'm not saying that. I'm just saying that your transactions, since each and every transaction is in public, anybody can find a pattern in that, and from that pattern he might reach to you. Okay, this is one of the possibilities. It is not that completely true that it will always happen, but there can be a possibility of happening that, right? So for that, HD wallets provide us with this safeguard that now you can clearly see that we have multiple addresses. We can use these multiple addresses. We have our crypto wallet, and you can select any of the addresses that are provided, and you can use those addresses in order to do any kind of transaction. And by this, your identity, your privacy is totally protected. And why they are called hierarchically deterministic wallet? And the reason for this is very simple, because as you can clearly see, right, that it is like an hierarchy, right? So someone is generating this, then this. So a hierarchy is there. Not only this, if you talk about real world application, let's say you are a CEO of a company, okay, and you want to give certain authority to your employees. Let's say you have some top managers. So what you can do is you can hold your master private key, and you can provide these private key 1, private key 2, private key 3, private key 4 to your managers. So let's say they want to do any kind of transactions, any kind of payment for your company, because since you are providing them the private key, so every transaction that you will be doing with the help of this private key will be for business purposes, right? So they will be able to do all kind of transaction with these private key, because private key is actually used for the transactions, right? And with the help of this master private key, you can easily find out what kind of transactions your managers are doing. Now, your managers cannot find out what kind of transaction you are doing with the help of this master private key, but with the help of this master private key, you can find out what kind of transactions your managers are doing. So you can easily find out like if this is manager one, kind of transaction he is doing, or manager two, what kind of transaction she is doing. So you can find out each and every detail about these private keys. So you can go from here to here again, but you cannot go from here to here, right? So this is something we have talked about in the previous videos also, right? So this is the use of HD wallets, and that's why we use HD wallets, because they provide us privacy as well as safety. And let me show you one example also. So this is an address, and you can clearly see all the associated transactions of this address. What amount of Bitcoin he is sending, what amount of Bitcoin he is receiving, each and everything is given in this blockchain explorer. Just you have to come to this particular website, just paste down the address, any random address or any address that you have, just search for it and you can find out each and every transaction that this particular address is doing. Okay. Hello. Now in this video, we are going to start with Ethereum. So in the starting of our course, as I said, right, that I have divided this course into three parts. Module A, where we talked about blockchain. Module B, where we talked about cryptocurrency, that is Bitcoin. And now we are going to cover module C. So I'm very excited to start this new module. And in this module, we are going to learn each and everything about Ethereum. Like what is Ethereum? What is a smart contract, decentralized application, EVM, DAO, hard and soft fork, DAO Attack, ICO, and all coins, and definitely much more. This is just an overview, so do not be confused that only they are going to be only 9 videos. There are going to be so many new things in our upcoming videos. But let's start with this new module, and let's start with what is Ethereum. Now, before talking about Ethereum, let us talk about the founder of Ethereum, who is Vitalik Buterin. Vitalik Buterin is the founder of Ethereum. He proposed the idea of Ethereum in 2013 when he was only 19 years old. And his story is also very inspiring, guys. He proposed the same idea to the Bitcoin community that we should have a blockchain in which at which actually we can run programs. But nobody in the Bitcoin community believed in him, and then only he launched the Ethereum blockchain. Now, what is wonderful about Ethereum blockchain? Ethereum blockchain, like if we talk about Bitcoin blockchain, which came before Bitcoin blockchain only supports transactions of Bitcoin. Means you can do transactions on Bitcoin, like you can send some Bitcoin to your friend, or your friend can send some Bitcoin to you, but you cannot run programs on Bitcoin blockchain. And Ethereum is a blockchain that gives you a facility to run programs on the blockchain, on this Ethereum blockchain. And these programs are called smart contracts. And we will talk about this in much more detail in our upcoming videos. But for now, this is the most interesting thing about Ethereum, that you can run programs on Ethereum blockchain, and with the help of which you can create decentralized application. And again, this is a topic which we will discuss about in our upcoming videos in great detail. And if we talk about the cryptocurrency related to Ethereum, that is Ether. So if we talk about Bitcoin, Bitcoin provides us with Bitcoin. And if we talk about Ethereum, it provides us with Ether as a cryptocurrency. Okay, but we will talk about Ethereum in much more detail in our upcoming videos. This is just an introductory video to tell you what is Ethereum and who is the founder of Ethereum. But we will talk about Ethereum in much more detail in our upcoming videos. Now in this video, we are going to talk about Ethereum nodes. Let us see what are they. So let's say this is our Ethereum blockchain network, okay, where A, B, C, E, F, these are different systems and they are part of this Ethereum blockchain network. Now let's say you also want to become a part of this Ethereum network. Let's say you also think that, okay, I also want to be the part of this Ethereum network, and I also want that I should have the access to the blockchain. You may want, right, in the future. So what you have to do in order to become a part of this Ethereum blockchain network? Now, in order to become a part of this Ethereum blockchain network, you need to install a software called Geth, or we also call these kind of software as client. So you need to install this client, that is Geth, in order to become a part of this Ethereum blockchain network. Now, once you will become a part of this Ethereum blockchain network, you can also have access to the Ethereum blockchain like these nodes have. Okay, so let me show you that software. So this is Geth. So this is our Geth. Okay, so once you will install this software into your system, then you can also have access to the Ethereum blockchain. You can do transaction on Ethereum blockchain. Let's say you want to become a miner in the Ethereum blockchain, then you can also become a miner in the Ethereum blockchain once you will install this Geth software. Okay, now in order to become this, and yes, one more important thing that I should tell you, that once you will become a part of this Ethereum blockchain network, then you will not be a normal system. Then you will be called as node. So let's say before installing of Geth, you are having a normal laptop, normal system. Okay, let us call that. Now, once you will install Geth and once you will start running Geth on your system, then your system will not be a normal system. Now it is a special kind of system because now it can be a part of our Ethereum blockchain, and we called that kind of a system as node. Okay, so you need to install Geth in order to become a part of this Ethereum network. And if you will become a part of this Ethereem network, you will be called as node. Now we have different kind of nodes because if we talk about Ethereum blockchain, we have different kind of people. There are few people who want to be miners. There are few people who just want to be validators. There are few people who just want to do normal transaction on Ethereum blockchain. So that's why we have three kinds of varieties, three types of nodes in the Ethereum blockchain. First, we have full node. Second, we have light node. And third, we have archive node. Let us see what are these three different nodes. So if we talk about full node, as the name suggests, it consists of the whole copy of the blockchain. So whatever is happening on the blockchain ecosystem, Ethereum blockchain ecosystem, each and every data, each and every block information is consists of with this full node. So if you become a full node, you will have access to the whole Ethereum blockchain. But definitely not the whole, I will say. There will be some amount of data you have to request from a different kind of a node that we called as archive node. You can see that it stores full blockchain data, although this is periodically pruned, so a full node does not store all state data back to Genesis. So definitely you will be having some amount of data. Let's say if there are 100 blocks, so you will be having information about, let's say, 80 blocks, but rest 20 blocks will be pruned. Okay, so you cannot have access to that 20 blocks. Definitely you can ask that, like you can ask about that data, about that 20 blocks data from archive node, and we will talk about archive node, so don't worry. But one thing is for sure, you can have access to around 80% of the blockchain data that is happening, that is there in the Ethereum blockchain ecosystem. Now, if you will become a full node, then you can participate in the validation, verification, as well as mining of the blocks. Okay, validate the blocks, that block are malicious, whether the transaction are right or not. So you can do all kind of thing if you will become a full node. Third thing is that it serves the network and provide data on request. Means we will, in the next slide, we will talk about light node, and light node actually depends upon full node. Full node depends upon archive node and light node depends upon full node. So if you request some data, full node will be the one that can also provide you with that data, especially light node access. Light node request for that data from full node, and we actually request data from light node. So this is how this whole process actually works. And all states can be derived from full node, although very old state are reconstructed from request made to archive node. As I said, that you can definitely have access. Let's say if you have 100 blocks and you, as a full node, you have only access to 80 blocks. But let's say you want to have access to those 20 left blocks. Then in order to do that, you have to just request from the archive nodes that, hey, I just want that data. Can you please send me that data? So archive node will send you that data. So this is how full node works. But definitely, in order to become a full node, you need to have a good system. You need to have a system which has higher storage, because if you will have less amount of storage, or let's say your internet is not that kind of a stable, in that case full node will not work for you. So you need to have a dedicated system in order to run a full node. Now let us talk about light node. And light node is the most favorite one for most of the users, and the reason is very simple, because light node does not store the entire blockchain. It only store the summary of blockchain. Okay, so it is like blockchain is a whole story, and it is having some like light node is storing only the summary point of that story. So this is how light node works. Okay, and it depends upon full node. So whatever transaction are happening, if it wants to have the, if it wants to know about that transaction, it has to request from the full node. and it is very good for those systems which have low capacity devices. So let's say you are having a system which is not of good storage, and your internet is not that good. In that case, you can become a light node, and by becoming a light node, you can do transaction on the Ethereum blockchain. Definitely you cannot become a validator or a miner by using light node. So the light node do not participate in the consensus, means it does not participate in the you know in the proof of work, because definitely now Ethereum does not work on proof of work. Now it has shifted from proof of work to proof of stake. So you cannot participate in the consensus part, means you cannot participate in the decision making part, whether a block is a malicious block or not, whether a block is a correct block or not. You cannot do that. You cannot mine a block, you cannot create a block. You can only access the Ethereum block, like you can see what is happening on the Ethereum blockchain. This is the only role you will be having if you will become a light node. Let's talk about Archive node. So Archive node, as I talked earlier also, these are the nodes that have the entire history of the blockchain. So if there are 100 blocks in the Ethereum blockchain, Archive node will store the entire 100 blocks in its data storage. So this is how Archive node works, and that's why it is written that built an archive of historical data, means from the beginning, like Ethereum, when Ethereum started, from that point of time till now, they are storing each and every data. And yes, it requires terabytes of disk space if you want to become an Archive node. So if you are having some GB of space, then it will not be beneficial to become an Archive node. It will not be fruitful. So you need to have terabytes of data space, disk space actually, in order to become Archive node. So these are the three different nodes that we have in Ethereum blockchain. And trust me, this light node is the most easy one. If you want to become a part of this Ethereum blockchain, this is the most easy one, because it does not require much from you. It only requires some amount of storage, and if you have those like certain amount of storage, you can become a light. Now in this video we are going to talk about Ethereum accounts. Let's start. So what is an Ethereum account? An Ethereum account is an entity with an Ether balance or ETH balance that can send or receive transactions on Ethereum blockchain. The definition is very simple, if you will see. The Ethereum account works just like our bank account. With the help of our bank account, we can send some money, we can receive some money. In the same way, with the help of Ethereum account, we can send some Ether, we can receive some Ether. So if you have an Ethereum account, now you can send Ether to someone and receive Ether from someone. There are basically two types of Ethereum accounts. First one is externally owned account, that is EOA, and second one is contract account. Let us understand each of them with the help of an example. So what is an externally owned account? So externally owned account are those accounts that are actually opened by a human. So if you are a human, definitely if you're listening to me, you are a human. So if you will open an account on Ethereum, then that account will be an externally owned account. Now the key feature of this externally owned account is that for opening this externally owned account, you will need a wallet. So that can be any cryptocurrency wallet. And in order to access this wallet, what you will have is a private key. And we have seen this also, right? I was talking about private key and public key. I have shown you this also. That with the help of this private key, you can access this wallet. And this wallet will provide you the complete control over your externally owned account. Okay. And we will see an example also. So don't worry. So with the help of this private key, you can access this wallet, and this wallet will then show you your current balance, whatever balance you have in your cryptocurrency wallet. And also with the help of this, you can send transaction, you can receive transaction, and not only this, with the help of externally owned account, you can access your smart contract. And we will see an example for this also. Definitely I will talk about smart contract in much more detail in our upcoming videos, but for now you can think a smart contract as a simple program, and with the help of our externally owned account, we can access our smart contract. Okay, so let me show you an example also. So this is our MetaMask wallet. I'm using this for a long time, right, throughout this video. So in this account that you're seeing right on your screen, this account is your externally owned account or EOA. And with the help of this account, you can send some Ether to some other account also. But for now, I don't think so I have any other account to test this. So what I will do is I will just copy the same address. I will send some ether to my own address only. So I'm copying this address. So it is like you are no, this is the account address of the person to whom you want to send some ether. So let's say I want to send some 0.00001 ETH, and then I will click on next, and then I will click on confirm. Now, once I will click on confirm, 0.0001 ETH will be transferred to this particular account. Okay, because I have this account only at this point of time. So I'm sending the same to my address only. But definitely, if you will have some other address, you can send ether to that address as well. Okay. So let's wait for our transaction to be get confirmed. So you can now see that our transaction is confirmed, and we can see that on this Gorilla etherscan.io. So this is, as you can see that this is our Ethereum blockchain, means Ethereum blockchain block. And this is the from address, means this is the person who has actually sent some ether. And this is the address of a person to whom this address was, this ether was actually sent. And also you can see other details on the Ethereum blockchain, that the transaction fee they charged and the amount of ether that I have sent from this address to this address. So this is the whole use of externally owned account, so that you can send, receive ether with the help of externally owned account. Now let's talk about the second account, and that account is contract account. So this contract account is an account which is actually controlled by your contract. So definitely in future, I will create a course on Solidity. In that course, I will definitely show you how you can create your own contract account. But in this video, because this is out of the scope of this course, in this video, I will just demonstrate you how a contract account looks like and what is the use of contract account. So with the help of contract account, just like with the help of your external account, you can send and receive ether. You can also do the same with the help of your contract account. The only difference is that this contract account is totally controlled by the contract code. So whatever code you have written in your contract, in your smart contract, that will control how the sending and receiving of ether will be done. Okay, let me show you that also. So let me show you one contract. Okay, so this is one of random contract address. Okay, this is not I have created or something. This is a random contract address that is available on Ethereum blockchain. Okay, and let's say I want to send some ether to this contract. So can I do that? Yes, you can do that. This is your contract account address. Okay, so you have to just copy this and you have to open your wallet, because as I said that with the help of your externally owned account, you can interact with the smart contract, right? So I want to send some ether to this contract. So I will click on send. I will paste the address of this contract account. Okay, so this is the contract account address. And let's say I want to send some 0.0001 ether, and then I will click on next. I'm not sure whether it will get confirmed or not, because this is not my contract. Okay, it is a random contract. If this contract does not have any functionality of receiving ether, definitely it will fail. Okay, so I'm just telling you this beforehand because I haven't created this contract. I'm just randomly sending some ether to this contract address. So let's see what will happen. Let's wait for our transaction to get confirmed. Okay, let's go to Block Explorer. So now in this, you can clearly see that this is the contract account that I have used in order to send some ether. And this is the contract address at which I have sent this ether. Okay. And whether it will fail or pass, I do not know. Let's wait and let's see. So now you can see that it got failed because this contract might not have any functionality to receive the ether, because as I said, everything in contract account, means in this contract account, is totally dependent on the smart contract. So if in your smart contract you do not have any functionality of receiving ether, then definitely you cannot receive any ether, right? But you can see that I tried to send some ether. This was the transaction fee, this was the value that I have sent and everything, but it got cancelled. That's a different story. Okay, so this is how contract account looks like. This address that you're seeing, this is how your contract account looks like. And why do we have this contract account? So that we can provide a unique identity to our contracts, right? Because let's say in future I want to talk to my contract, I want to receive some data from my contract, then definitely I need to have some address, right, where I can locate my contract. And this contract account actually help us in that. So that's why we have this contract address and everything. Let me show you a quick picture, like what is the difference between externally owned account and what is the difference between contract account. So in externally owned account, you require a private key so that you can access your wallet. In contract account, you do not require any kind of private key or public key. This is controlled by human because we are creating this wallet, but this is controlled by the contract code. This is having a unique account address, and this is also having a unique account address so that we can locate it, right? We can talk to them. And this also hold Ethereum balance, and this can also hold Ethereum balance. Okay, so because they work just like your normal external account contract, the only difference is that they are in control of contract code and not by humans. This is the only difference. Otherwise, they can do all sort of things that this external account can do. They can receive balance, they can send balance, means they can receive ether, they can send ether, they can have their own balance. Like, okay, this account, this contract is having, let's say, 2 ETH of balance. So this is also possible in the case of contract account. Okay, so I hope now it is clear what is the difference between external account and what is the difference between contract account. Now we are coming to hi. Now let us talk about the most important topic in Ethereum blockchain, that is smart contract. Let's see what it is. So if we talk about smart contract, what is a smart contract? A smart contract is simply a program written on Ethereum blockchain. So just like you write program in C, C++, Java, Python, right? You write programs. In the same way, you write programs for the Ethereum blockchain, and those programs are actually called as a smart contract. What? Yes, it is true. Smart contracts are nothing but simply programs. Now you must be wondering that why do we call them a smart contract if they are simply programs? Actually, the thing with a smart contract is that in a smart contract you write logics. Like you have that logics like if this will happen, then this will happen. If this will happen, then this will happen. So it is just like a contract, right? Where you are writing some if and else statement where you are stating certain rules that if this will happen, then this will happen. If this will happen, then this will happen. So because of this, I think the name was given as a smart contract. Otherwise, smart contracts are simply programs that are written on Ethereum blockchain. Nothing else, nothing more. Now let us talk about one important thing about smart contract. That if we talk about Ethereum blockchain, we have the functionality of writing programs, that is a smart contract. But if we talk about Bitcoin, we do not have any functionality of writing smart contracts on Bitcoin blockchain. Why this is so? Let us answer this question. If we talk about Bitcoin blockchain, the programming language that is used in order to create our Bitcoin blockchain is Bitcoin script. And the programming language that we are using in order to create our smart contract is Solidity. It is a very popular programming language for the Ethereum blockchain. You might have heard this name, Solidity, and we use this programming language in order to write programs on the Ethereum blockchain. Now, the thing with Bitcoin script is that Bitcoin script is not Turing complete, while our Solidity programming language is Turing complete. Now, what do I mean by not Turing complete and Turing complete? So, when I say Turing complete means that you can code any form of logic that you can think. So whatever you can think, you can code in Solidity programming language. While in case of Bitcoin script, that's not the case. You cannot write all the programs that you can think. And the reason for this is that Bitcoin script does not support loops, while Solidity programming language support loops. And that's the reason Ethereum blockchain supports programs. Means you can write programs on Ethereum blockchain, but you cannot write programs on Bitcoin blockchain because Bitcoin blockchain is using Bitcoin script, which is not Turing complete. Means you cannot write loops on Bitcoin script. And since you cannot write loops on Bitcoin script, you cannot code any form of program that you can think, right? And now you must be wondering, like, why Satoshi Nakamoto will do that? Why Satoshi Nakamoto used a programming language that is not Turing complete? Why not any other programming language that is Turing complete? And the reason is very simple, guys. At the time when Satoshi Nakamoto was developing this Bitcoin blockchain, he thought of a problem. And the problem was actually real. The problem was that, let's say, Bitcoin is providing you facility to write programs on the Bitcoin blockchain. Okay, so let's say this is a program that I have created using Bitcoin blockchain, and now I'm trying to run this program on the Bitcoin blockchain. So these are the participants that are connected with each other, and they are forming the Bitcoin blockchain. So definitely they will be having their blockchains, and everything will be there. Now the problem is that when we will run a program on this Bitcoin blockchain, the same program will run on each of the computers, or I will say in each of the nodes that are part of this Bitcoin blockchain. Because if we talk about Bitcoin, right, we have seen, right, that blockchain is a distributed immutable ledger. So this program that we will be writing will be a part of our Bitcoin blockchain. So this will also get distributed all across the network. So if it will get distributed all over the network, so the same program will be running on each and every system. Now, the problem is that if this program consists of an infinite loop, then what will happen? If this program will consist of an infinite loop, then this infinite loop program will run on each and every system. And the thing is, nobody can stop these programs. Why? Because in Bitcoin blockchain, we do not have any central authority. And since we do not have any central authority, nobody can control these programs. Nobody can stop this program. And this will totally destroy the Bitcoin blockchain, right? Because these programs will keep on running, and they will slow down the network, and Bitcoin blockchain will collapse. So this was the problem when Satoshi Nakamoto was designing Bitcoin blockchain. Now you must think, like, then how Ethereum is able to do that, right? Because as we can clearly see on this screen that we cannot have programs running on blockchain, because if we are running a program running on blockchain and if the program consists of a loop, then this program will be running continuously all over the network, and this will totally destroy the network. So what Vitalik Buterin thought, that definitely we will have a smart contract in this transactions field, because we have different transactions, right? We want to send ether, we want to receive ether, all these things will be there, but we will also be having smart contracts, right, in this blockchain, in this Ethereum blockchain. So what he said that, okay, you can write smart contracts, you can write programs on Ethereum blockchain, but you need to pay for every single line of code that you are running on this program. This is the beauty of Ethereum blockchain. Just imagine what he is thinking, what he actually thought, actually, that when you will create programs, you will be able to create you will be able to write code, whatever code you want to write, you can do that. But for every single line of code that is executing on the Ethereum blockchain, you need to pay money. And this is done using gas, which we will talk about in our upcoming video. But this is how Vitalik Buterin stopped this infinite loop concept. Because if a person is running an infinite loop, then he will be exhausting all his money that he is having in his Ethereum account balance, right? So nobody wants that, right? Nobody want to exhaust their money. And this is how Ethereum stopped this infinite loop problem. Definitely other measures were also done, but this is one of the beautiful thing that Vitalik Buterin thought, so that he can stop this infinite loop programs in the Ethereum blockchain. And that's why now we can run programs on so many systems. I mean, when a program is running, it is running on so many different systems without collapsing the Ethereum blockchain. Because if someone tries to collapse that, he has to exhaust with all his money, and nobody can have infinite money in his account, right? You can have some, let's say 1 crore, 2 crore, or let's say 100 crore, but at one point of time your money will get exhausted, right? And that's how Ethereum blockchain is, much more ahead of the hackers and the scammers, I will say. So that's why we are able to run programs on the Ethereum blockchain, and that's why we are not able to run programs on the Bitcoin blockchain. And this is very important interview question also. So remember this concept. This is very important and might be asked in your interviews. Hi. Now in this video, we are going to talk about decentralized application. So let's start. So before talking about decentralized application, let us talk about how our centralized application works. So this is our architecture centralized application, where we have various clients, okay, and we have one server. So this server is actually owned by a central authority. So let's say this is Amazon. Amazon is having all your data. Whenever you request something from Amazon, Amazon respond you with that data. So we are simply clients, and Amazon is actually having this server, means this is the server of Amazon. Okay, so this is how client server model works. We talk about decentralized application. Since this application is decentralized, we do not have a client server model. Each and everything is done on peer-to-peer network only, means on this Ethereum blockchain. So this is how our P2P network looks like. So our application will not be running on a single node, but our application will be running on each and every node. So this is how decentralized application works, and you can clearly see that how this is running on each and every system, right? Now let us see one formal definition of decentralized application, how our decentralized application is created. Then you will understand why it is called decentralized. So for creating our decentralized application, we require smart contract. Definitely, because in this smart contract, we write our business logic, because this smart contract is also decentralized in nature, right? We write our smart contract. This smart contract is running on each and every node. So this decentralized application is actually using this smart contract, okay, as our backend. So if we talk about our centralized application, they use server, right? And that server is owned by a particular company. But in case of a smart contract is not owned by any particular company. It is the part of our whole Ethereum blockchain. Then we take this smart contract and then we connect one front end with this smart contract. Why do we have this front end? So that we can with the functioning of this smart contract, right? Because normal user cannot directly talk to our smart contract. So they require one UI in order to talk to this smart contract. And when we integrate these two things and deploy it over the blockchain or over the decentralized network, the application that we get by integrating these two technologies is a decentralized application. So this is one simple definition of decentralized application. When you integrate your smart contract with your front end and deploy it on the decentralized network, then the application that you get is a decentralized application. And here is the list of some decentralized applications. So Google, which is a centralized application, that alternative is research. Twitter, which is a centralized application for social media. LBRY is different, like it is a decentralized application for your social connections. And like in YouTube, we have video platform via YouTube. Alternative is you can use in order to watch videos. Definitely, all these decentralized applications are not totally, I will say, fully equipped with each and everything, with each and every features. They are in development phase only, but you can have a look at these different decentralized application. They are available. So let me show you DTube. So this is DTube. Okay. So it is taking some time. Let's wait. So now you can see that this is our DTube. And you can see that there are certain videos that are being uploaded at each and every time, right? So yes, this is how our DTube looks like. You have to log in it in order to run it. So now you can clearly see that we have options for username and YouTube private key. Okay, I haven't used this application yet, but you can see that, right? You have a lot of options here. And definitely we will talk about this. What is this $0.089? We will talk about this also. But this is how it looks. And currently, definitely, there are not much, users at this point of time, because as I said, it is totally new. People are still, working on it, still doing it. Yes, this is good. So let us see the difference between our centralized applications and decentralized application. If we talk about our centralized application, they are not trustworthy, right? Because they are owning our data. They can manipulate anything with our data, because server is actually in control of the company that is providing us the services. And you have seen news, right? This you might have seen news also related to this, that your data got compromised or something like that, credit card details got leaked, because each and everything is in the control of this centralized authority and you cannot trust it. But in a decentralized application, since everything is open, it is not in control of a central authority, so you can trust on them. And not only this, these decentralized application code is totally available in the open source, so you can go and read about the code. While in centralized application, you cannot read their code. Whatever they are doing with your data, you do not know nothing about it. They can censor they can censor important things. Let's say I have a video which is against government, just an example. So these centralized applications can censor those videos, right? But in decentralized application, you cannot do that. Once a video is live, nobody can remove until unless we have some kind of feature in it that, okay, after democracy, like after certain vote, you can remove the video or something like that. Otherwise, nobody can remove the video, because once it is on decentralized application, it is on thousands and lakhs of computers. And you might remove some computers, right? But still it will be running on some other different, on some other different node, right? Because in a decentralized network, we have lakhs and thousands of computers. So if we talk about centralized application, we need to pay. Means, let us understand this with the help of YouTube. YouTube is a centralized application, and if you were watching some video need to see some ads, how YouTube. And if you do not want to watch those ads, what you have to do, you have to buy YouTube membership, right? You need to pay in order to use their application. While in case of decentralized application, this is not the case. In the case of decentralized application, definitely decentralized application, let's say DTube, will show you ads, but they will give you an option that whether you want to see those ads or whether you do not want to see those ads. If you want to, if you are willing to see those ads, then you will be paid for every ad that you are watching. Yes, they will be paying you for every ad that you will be watching. While in case of centralized application, this is not the case, right? You need to pay to remove ads. While in decentralized application, you will be having some options that, okay, you want to watch ads, if you want to watch ads or not. If you do not want to watch ads, then you will not be paid. But if you are willing to watch ads, then they will pay you for watching ads. If we talk about centralized application, they can go down, right? Once a server is down, nobody can access that application. While in the case of decentralized application, this can never happen because your application is not running only on single server, but your application is running on each and every node that is part of that Ethereum blockchain, right? So there are thousands and lakhs of computers that are running your applications, so nobody can stop it. So those applications cannot go down because they are running on so many nodes, right? So do let me know in the comment section whether decentralized applications are great or not. Okay, don't forget, do comment it. Now let us talk about Ethereum virtual machine and what are they. So as we discussed in the previous video, that decentralized applications are applications that run on each and every node that is part of our Ethereum blockchain network, right? Now, the problem in this approach is that it may happen some hacker or some malicious user is running an application that is containing some virus, right? And if that application, if that decentralized application is containing some virus, then that virus will be running on each and every system that is part of this Ethereum blockchain network, right? And this is not we want, right? We do not want that virus should run on our system. So what Ethereum community got an idea. They said that why to run decentralized application directly on your system. They said that you need to install a client that we have talked about, right? Geth. You need to install a client called Geth. That Geth will run an Ethereum virtual machine inside your computer, and this decentralized application will not be running on your computer, but this decentralized application will be running on this Ethereum virtual machine. So it is like if you have used VirtualBox, right? If you have used VirtualBox, so you might know this, that let's say if you are having a host operating system Windows and you want to run Linux operating system on your Windows operating system, in order to do that, you need to install VirtualBox and then you can run Linux operating system on your Windows operating system. Yes, if you haven't used it, you might find it complicated. Just search for VirtualBox and you will see a lot of different videos with the help of which you can run Linux operating system on a Windows operating system machine. And in what Ethereum community did, they designed this Ethereum virtual machine. So whatever will be happening, like whatever result this decentralized application or whatever this decentralized application will be doing, it will not be interacting directly with your machine. It will be only interacting with this Ethereum virtual machine, which is like an operating system running on the top of your operating system. So this is the beautiful thing about Ethereum virtual machine. And how do you have this Ethereum virtual machine? So when you install this Geth client software in your system, when you become the part of this Ethereum blockchain, in that way only you also get access to this Ethereum virtual machine. Okay, so whatever blockchain, whatever thing is happening in you, it might look like that it is happening in your system, but it will be happening on this Ethereum virtual machine. Now let us talk about Ethereum Gas, which is a very important concept for the Ethereum blockchain. So let us understand the concept of Ethereum Gas with the help of an example. Let's say you are having a car, okay, at position A, and you want to reach to this position B. Now, in order to reach from position A to position B, you require one thing, right? And that one thing is petrol, or I will say gas. Without gas or without petrol or diesel, you cannot reach from A to B. Definitely you have a car, you have a machine. It might be beautiful, it might be expensive, but without petrol, can it move from A to B? No, right? So you need to refill some petrol to this car so that you can reach from point A to point B, right? Now, in the same way, let us say that you have a smart contract and you want to deploy this smart contract on the Ethereum blockchain. You want to execute some code on on this smart contract that is deployed on this Ethereum blockchain. Now, in order to do that, you will require gas. But this gas will not be like your petrol or like your diesel, but this gas will be called as Ethereum gas. Now, why you will require this Ethereum gas? Let us understand this with the help of an example. So let's say you want to execute this code in your smart contract. Okay, so this let's create a beautiful smart contract, a program. Okay, in which you want to execute this expression 10 into 3 minus 6. Okay, so this is a simple expression and you want to execute it in your smart contract. Now, in order to execute this statement, you will require some amount of gas. For each and every operator, right, there is a particular gas associated with it. So, for example, if we talk about multiplication, if you are doing a multiplication operation, then you require 5 amount of gas. For this subtraction operator that you are seeing, right, so the subtraction operator, this requires 3 amount of gas. And if we talk about this equal to operator, right, this equal to operator requires 3 amount of gas. So in order to run this code, it is like running a car, right? In order to run this code, you will require this amount of gas so that you can run this expression. So if I talk about, like, if I say that what is the total amount of gas you will be required in order to execute this expression, that will be 5 plus 3 plus 3, that is equal to 11, right? I hope this makes sense, that you require 11 gas so that you can get the result of this expression. So let me show you one important document where you can find the list of all the gas associated with all the opcodes. Okay, let me show you that. So this is this. Shows this DTube. Okay, so this is official website, okay, of Ethereum opcodes. Okay, in this, I think we have to go to this, right? Opcode gas list. Now, in this, you can clearly see that for each and every operator, for each and every instruction that you are executing on the Ethereum blockchain within your smart contract or on your Ethereum blockchain, you have to pay certain amount of gas. Okay, so for stop, it is 0 gas. For add, this is 3 gas. For multiplication, 5 gas, right? Which is we have seen also. For subtraction, this is 3 gas. So you need to have certain amount of gas in order to run or in order to code any kind of expression on the smart contract. Okay, and we will see much more about it in our upcoming videos, but I hope this makes sense, right? I will share the link also if you want. Otherwise, you can search it. It is given there also. Yes, and one important point, that why do we not use ether in this case? Like, why do we have this another entity called gas? Simple, right, guys, that ether fluctuates a lot, because ether is something, sometimes ether price will be $1,000, at another point it will be $2,000. So there is no particular a particular value associated with the ether. It keeps on changing, and that's why we have this concept of gas, and which we will talk much more about in our upcoming video, where we will talk about Ethereum gas price. But before that, let us talk a little bit more about this Ethereum gas. So let's see some important points related to Ethereum gas. First, transaction that modifies the blockchain costs some amount of gas. So any transaction that you're doing, right, which is modifying the state of your blockchain, let's say you are changing the value of a variable in your smart contract, okay, and which I will talk about in much more detail in our Solidity course, but for now. So if you are changing a variable, if you are changing something in your smart contract on the Ethereum blockchain, then that will cost you some gas. And who will pay this gas? The user that is generating this kind of transaction. So let's say you want to, let's say you want to print hello world in your smart contract. So you are making some changes, right? You are actually calling some function in your smart contract. So if you are calling those function, you need to pay gas. Okay. And when I'm saying transaction, do not be confused that transaction is something when I send something to someone. No. Transaction is anything in the Ethereum blockchain that changes the state of your. Remember, like this, anything that you're doing and which is actually changing the state of your block is actually your transaction. So in the previous video, we talked about gas, right? That what is gas and why it is used and everything. Let's talk about what is this price. So let's say again we have this beautiful car and we want to reach from point A to point B. And definitely in order to reach from point A to point B, we require some amount of gas. So let's say in order to reach from point A to point B, I require some 10 liters of petrol. Okay, let's say in order to reach from point A to point B, I require some 10 liters of petrol. Now, if I ask you, what is the total price you have spent in order to reach from point A to point B? Definitely, you can tell me the total amount of petrol that you have consumed in order to reach from point A to point B, that is 10 liters. But now I am asking you that what is the total price that you have paid in order to reach from point A to point B? You will say, this is a silly question because you haven't told me the price of petrol, because it will depend upon the price of petrol that how much cost I have paid in order to reach from point A to point B. And I will say, definitely you are right. So let's say the price of petrol is 5 rupees. I know this is silly. It can never be. It can never be so little as 5 rupees, or let's say $1 or $2. So yeah, this is silly, but still, let's say 5 rupees is used in order to reach from point A to point B. Now, if I will ask you the total price, then you can say that, okay, the total price will be 5 into 10, that is 50 rupees, because I'm using 10 liters, and for per liter, I'm paying 5 rupees. So 10 into 5, that is 50 rupees. And I will say, yeah, you are completely right. Now, the same goes for our gas. So in the previous video, we have seen, right, that we can calculate the total amount of gas that we are consuming in order to evaluate this expression. Now, if I will ask you that what is the total amount you have paid in order to evaluate this expression, you will say again the same thing, right? That, okay, I know the total amount of gas. I do not know the total amount of money, means the total amount of price I have to pay for per amount of gas, right? And this is what we called as gas price. So what is gas price? It is the amount the sender wants to pay per unit of gas to get the transaction mined. Gas price is something which is set by the sender. So in case of petrol, the petrol price is actually fixed by the government, right? Government decides that what will be the total amount of price you are going to pay for per liter of petrol. But in case of gas, it is not determined by the government. It is you who is doing the transaction who will decide the amount of price you are willing to pay for each amount of gas that you are spending. Okay. And I know you might be thinking I will pay as low as possible, but this is now how it works. Let me tell you why. And before moving further, let me tell you this also, that gas prices are denoted in GOI, and 1 GOI is equal to 10 to the power minus 9 ether. So this is a unit of ether. Okay, just like we have 1 kg is equal to 1000 gram, 1 meter is equal to 100 centimeter. In the same way, in 1 GOI, we have 10 to the power minus 9 ether. So remember that. So your gas price can be in 10 GOI, 100 GOI, or it can be 1000 GOI, whatever you will decide. So it totally depends on you whether you want to have your gas price as 10 GOI, whether 100 GOI, or 1000 GOI. Now let's go back to again that question that, okay, if the gas price is set by me only, because I'm going to set this gas price, I will have my gas price as low as possible. I will pay some 0.000001 GOI in order to do my transaction. But now let me tell you one catch here. The catch is that definitely you can decide the gas price. But still, if you want your transaction to get mined faster, then you need to pay good amount of gas price. So the higher the gas price, the faster the transaction will be mined. It is just like in Bitcoin. So in Bitcoin, we discussed about the transaction fee, right? That the higher transaction fee you will be having, the more chances of your transaction to get mined, the more chances that your transaction will be successful. In the same way, if you are going to pay more amount of gas price, then your transaction will be elected, means sorry, not elected, actually will selected by the miners. Then only they will take your transaction and put it inside the block, and then only they will mine your transaction, right? So you need to have a gas price which is according to the market level. So your gas price should not be too low, or your gas price should not be too high. Okay, so remember this. If you will pay more amount of gas price, then you will be having your transaction mined in less amount of time. The more gas price, the less time it will take. It doesn't mean that you have to pay, 10 million GUI in order to have your transaction, in order to run, in order to make your transaction successful. No, I'm not saying that. It totally depend upon the market. You have to see what is the market rate of gas price, and you have to choose wisely in order to do that kind of transaction. But generally, most of the wallets that you see, that your MetaMask wallet, they assume like they take the market price and they provide you the gas price accordingly. But still, if you want to increase the speed of your want to have your transaction done in, in as much fast as it can possible, in that case you need to pay a higher gas price than any other person who is doing that kind of transaction. Let me show you this with the help of an example. So I will open my MetaMask wallet. In this, let me copy this same, send. I will select the address where I want to send. So now I am doing some kind of transaction, right? I am sending. So I have selected, let's say, this amount of GUI. I will say next. Now you can see that here, if you will see, this is they are calculating this max fee, right? So how they are calculating this max fee? So what they are doing is they are seeing the total amount of gas you are going to spend. Okay, so for every transaction there is a gas limit. We will talk about this. We will talk about that in our upcoming video. So what they are doing is they are giving you the estimated price it will take in order to do your transaction successfully. And let me show you this market tab. So I will click on this market tab. Now you can see that if you are willing to pay this amount of ETH, in that case your transaction time will be 30 seconds. If you are paying this amount of ETH, so this is the market price, this is on average, I think this will be less than 30 seconds. So it is more than 30 seconds, it is less than 30 seconds. And then you have this aggressive, that if you want your transaction to be confirmed in, like, in less than 30 seconds, in that case you have to go for this amount of gas price. Okay, or I will say this amount of fees. Okay, they are calculating your gas price by taking the gas consumed and the total gas price you are willing to pay. So they are doing it on your behalf. So this MetaMask wallet is doing on your behalf. Definitely you can go to the advanced settings and you can change it, but I will not advise you to do that because your MetaMask wallet is good enough to do that. But still, if you are thinking, no, I want to change it, I want to change the gas price, I want to change the gas amount, or whatever you want, you can do that also. Okay, but still, I would say that let it do by MetaMask only. Okay, so this is how it is. In this video, we are going to learn Ethereum Gas Limit, which is a very important topic in the Ethereum blockchain. So let us see what is Ethereum Gas Limit. Ethereum Gas Limit is the maximum gas the transaction can consume. So let's say you are doing some kind of transaction. The maximum gas that your transaction can consume will be your Ethereum gas limit, means will be the Ethereum gas limit of your transaction. And what is a transaction? As we have discussed before also, anything that changes the state of our blockchain, of our Ethereum blockchain in this case, is a transaction, right? And who set this Ethereum gas limit? So this Ethereum gas limit is actually set by the sender of the transaction. So let's say you are doing some kind of transaction, some ether transfer to your friend. Now in this case, you will be setting this Ethereum gas limit. Now, okay, we understood what is this Ethereum gas limit, and this is set by the sender. But what is the use of Ethereum gas limit? Why do we have this? We have learned about Ethereum gas, then we learned about Ethereum gas price, and now we have another term related to gas, that is Ethereum gas limit. What is the use of it? Let us understand this. So if we talk about our smart contract, our smart contract is a program that is deployed on the Ethereum blockchain, right? And our smart contract is something that also changes the state of the blockchain. So if you are doing any kind of, state change operation with the help of your smart contract, you are at the end doing a transaction. Let's say you are calling some function of your smart contract and your smart contract is deployed to the blockchain, on the blockchain, and let's say this function is changing some data on the Ethereum blockchain, okay, on the block which is at which this smart contract is deployed. Now this function calling that you're doing is actually changing the state of the blockchain, right? So this will be a transaction. Now, since this smart contract is not running only on your system, but this smart contract is running on each and every system that is part of this Ethereum blockchain, right? Now, just suppose, let's say this person is a hacker. Okay, just suppose that this person is a hacker and this person has launched a smart contract, and in this smart contract, he has some transaction which is consuming infinite amount of gas. Just assumption, just just an example, that let's say this smart contract consists of a function which consumes infinite amount of gas. Now what will happen in this case? Now you may say that, okay, since this person is launching some function which is going to definitely consume infinite amount of gas. When I'm saying infinite, you think of it as a huge amount of gas. Okay, you can think like that also. Now definitely he has to pay good amount of money for that. But another drawback of this situation is, definitely, let's say this person is a rich person and he said, okay, I have no problem in giving money to the Ethereum blockchain. So he said, okay, no issues, I will call this function and I will pay the money, whatever money required, and I will pay that to the Ethereum blockchain. I have no issue with that. But there is one drawback. The drawback is that this smart contract is not only running on his system, but this smart contract is running on each and every system of this Ethereum blockchain. Means this will actually slow down the Ethereum blockchain, right? Let's say this smart contract consists of an infinite function. So this smart contract function is keep on running and run the loop, actually not function, infinite loop. Now this loop will be running infinitely. It will be continuously running. And he said, okay, I'm a rich person, I'm ready to pay you anything, whatever you want. But this will actually affect the overall system, because each and every system has this smart contract, as we talked about also, that in blockchain everything is distributed. So this smart contract will be running on each and every system, which will actually slow down the Ethereum blockchain, right? And we do not want that. So that's why we have a concept of gas limit. We, in the starting of a transaction only, ask from the person who is doing any kind of transaction that how much amount of gas you think your transaction is going to consume. Definitely it is totally an estimated guess. You cannot say that, okay, this will be the total amount. It is a totally estimated guess. Okay, this is the amount of gas my transaction is going to consume. You have to tell this to the Ethereum blockchain in advance, actually to the Ethereum wallet, whatever wallet you are using, in advance, so that the Ethereum blockchain can, okay, see that, okay, this transaction is consuming this amount of gas. Okay, this is good, I have no issue with it. And then only that amount of that transaction will be executed on the Ethereum blockchain, so that it does not slow down the whole system. So that's why we have a limit. We are having a limit that has to be decided by the sender, that, okay, this is the gas limit of my transaction. With the transaction that I'm going to do, this will be the gas limit of my transaction. Okay, so you have to give it a finite number so that the Ethereum blockchain can accept it if it is a good amount of limit, and if the limit is too high, it will reject that transaction. Let me show you that also. So this is my MetaMask wallet. Let me copy this address and let me send some amount of ether to me only. Okay, I'm sending some amount of ether to my address only, just to show you what do I mean by that. So I will have 0.0 point some 0001 ether. Okay, I want to send this amount of ether to me. I will click on next. Now when I will click on next, if you will go to this part, this market part, and then if you will go in this advanced settings, you will see that there is an option of Ethereum gas limit that you can set. You can edit this Ethereum gas limit according to the type of transaction that you are doing. Typically, whenever you are doing an ether transfer, in that case, 21,000 is the Ethereum gas limit. Okay, it is the Ethereum gas limit in like whenever you are sending some amount of ether to your friend. But definitely when it is a smart contract transaction, in that case your gas limit may vary. It can be more than 21,000, but 21,000 is the minimum, so it can be more than 21,000 only. Okay, and also this gas limit is also used in order to calculate your Ethereum transaction fees. Okay, so here you can see that there are a lot of things, right? Maximum base fee, priority fee, but you do not have to go in the calculation of it, because this thing keep on changing. Okay, earlier there was another criteria in order to calculate the gas fee, and now we have another criteria of calculating the gas fee. So do not if you want to go into that, definitely you can, but I will not suggest you, because this is something which will keep on changing, and I don't think so there is any use of it. But definitely if you want to, you can go and learn about this on ethereum.org website. And as I said, this gas limit, you can change it according to your convenience. And you might be thinking, I can have, let's say, 42,000. Definitely you can have a 42,000 gas limit. Then you also have to pay the amount, you have to pay for the 42,000 gas limit amount of fees as well. So do not think that you can have 100,000 of gas limit. So if you are going to have 100,000 gas limit, then you have to pay accordingly. Now what will happen, let's say you might be thinking that, okay, if my guess is wrong, if let's say my transaction is consuming only 35,000 in this case, so what will happen, the remaining 7,000 gas limit fees will get reverted to your account. So don't worry about it. If it is, let's say your transaction is consuming 35,000 and you have put it, you have put 42,000, in that case 7,000 will be reverted back to your account. And if you are having less amount of gas limit, let's say your transaction is going to consume 42,000 and you have only used 35,000, let's say. Now in this case, what will happen, your transaction will get failed and your money will also be not refunded, because it's your mistake, because the miner who has picked your transaction has put all his effort in order to solve for your transaction. But now, since you have given only 35,000 amount of gas limit, he will not be able to execute your transaction because your gas limit must be 42,000. So it will be rejected and you will not get any kind of refund. Okay, so that's the case. Now in this video, we are going to see a demo of the Ethereum blockchain. We will see like what are the different fields in the Ethereum blockchain, the transactions that Ethereum blockchain have, and how it is different from the Bitcoin blockchain. Okay, so this is a beautiful website, etherscan.io. You can learn a lot about Ethereum on this particular website, about its transactions, about the mining rate. Each and everything is given at this website in a great detail. Okay, so just come to this website, etherscan.io. Now here, if you will see, we have all the latest transactions field, and here we have all the latest blocks field. Okay, so let me go to this particular block and you can see the block number here. The block number is around, I think, some lakhs, I think, 1, 10, 100, 1,000, 10,000, lakhs and lakhs, crores actually. So it is in crores. And then we have status uninitialized. Okay, so it is not successful yet. This is the timestamp at which this particular block was created. And this is the proposed slot and epoch. Okay, nice. And we have the number of transactions. So you can clearly see that this block is now at this point of time is having 168 transactions and 44 contract internal transactions. That's great. Okay, then we have the recipient. So this is our recipient address. Then we have the block reward and then the difficulty. Wow, that's great. So this is the difficulty and this is the block reward, guys. Okay, and this is the size of our block. Okay, and this is the gas use. So we have discussed about gas, right? So you can clearly see that how gas is actually being involved in the blockchain. And this is the gas limit, and if you will see a very good example, it is that this is the total amount of gas that is used and this is the gas limit set by the sender, right? And you can clearly see that only 84.59% of this Ethereum gas limit is used. So the rest amount, that is the rest, I will say around 16% of the gas, will be refunded back to the sender. Okay, now this is base fee per gas. Now I am not going to into the technicals of this. For this, as I suggested you before also, you have to go to ethereum.org. There you can find much more details about this fee per gas and everything. So this is the burn fees, extra data. This is the hash of this particular block. So as we have discussed in the blockchain video as well, right, that each and every block has a hash. So our Ethereum blockchain also has a hash. This is the parent hash. So you can think of it as a previous hash. Okay, so it is pointing to this particular block. Okay, and this is the state root. So state root is currently out of the scope of this particular course, but this has to do with your Merkle tree. Okay, but this is not a part of this particular course. Definitely I will discuss this in some other video. So this is actually the state root of that Merkle tree. And this is the nonce. Now currently you can see that nonce is 0 because now Ethereum has shifted from proof of work to proof of stake blockchain. That's why it is 0 here. Okay, and if you want to discover about this parent hash, okay, so if you will see the block number is 547, right? In the last, let me see this particular block, which is the parent block, and if you will see, it is 546, which makes sense also because this was the first block 546, then the next block will be 547, right? And here also you can see the number of transactions, and each and every detail is given in this particular block as well, right? So this is a great website, guys. If you want to explore about Ethereum blockchain, I will highly suggest you to visit this particular website. You can learn a great deal about blockchain on this particular website. So this is the base fees, this is the priority fees. So this is the market rate currently. This is the price of our ether. Okay, that's great. And these are the different things. Okay, if you want to learn about ERC20 tokens, definitely this is not a part of this particular course. We will talk about this in our Solidity course. Okay, but this is not a part of this particular course, and blockchain and everything is given in this particular website. And let's say if you want to search for a particular address, you have to simply search that address here. Okay, you have to just type the address here, and you can learn about that particular account address, about that particular block, the transaction hash, anything. So if you have anything having like transaction hash, block, token, or anything, you can have a look at that particular block. Okay, so that's great, right? So I hope you like this video. If you have liked this video, please click on that like button. If you are new to this channel, please subscribe to this channel, because I'm regularly going to make new blockchain courses on this channel. And if you want to join me on Instagram ID is given in the description, as well as our blockchain developer community Discord link is also given in the description, so you can join me there. Okay, so meet you soon in the next video. Till then, bye bye. Hello guys, welcome back to Code Eater channel. In today's video, we are going to talk about decentralized autonomous organization. So let us see what are they. Now, before talking about decentralized autonomous organization, let us understand this word, organization. How does a typical organization looks like? So if you will see, a typical organization looks something like this, right? We have a director. Under this director, we have some managers. Under these managers, we have some employees, right? So if director has some work, he will assign it to the manager. Then manager will assign it to the employees. And this is how an organization runs, right? In a hierarchical manner, that director is the supreme authority. After that, we have managers. And after that, we have employees, right? Now, there are certain tasks in any organization which are very repetitive in nature, right? In which we do not require human intervention. Like, for example, let's say there is a customer who has certain doubts related to the product. Let's say this organization is selling some product, and this customer has some doubts related to the product. Now, this organization can solve the doubt of the customer by two ways, right? First way is that this organization can, assign some person to that customer who will actually solve the customer doubt. Or what this organization can do is, this organization can have a bot, an AI bot, which will actually solve the doubt of the customer. And I think the second option is better than the first one, because it will not require any human intervention. So it will actually save a lot of money for this organization, and it will be a very fast process, right? Because we will have an artificial intelligence bot which will be solving all the doubts in a very much faster way, because customers more or the same will have the same doubts, right? So we can have documentation linked, or we can have some videos linked, and that bot will provide the customer with all those documentation and with all those videos, and customer can refer it afterwards, right? So what we can do is, for all repetitive kind of tasks in which human intervention is not required, we can install smart contracts. Now, these smart contracts will work just like an organization. The only difference will be that there will be no human intervention in running this decentralized autonomous organization. And as the term, if you will see why it is called decentralized, because it is on blockchain, our smart contract is on blockchain. That's why we are calling it as decentralized. We call this autonomous because we do not require any human intervention. So let's say if there is a task, we will assign that task to this smart contract. Now, according to the variety of tasks, this smart contract assign this particular task to this particular smart contract, and then this smart contract can assign the same task to this smart contract. So you can think of it like this smart contract is working as a director. Definitely all these smart contracts are the same, right? Because all these are actually programs. But just to make you understand this concept of decentralized autonomous organization, we can assume that this smart contract is a director. This is smart contract that you are seeing on the second level are basically managers, and at the end we have the employees which are actually working in this decentralized autonomous organization. And the beauty of this decentralized autonomous organization is it is very, very cost effective and very, very transparent, and total democracy is there because there is no human intervention. Let us see the difference between DAO and a typical organization, a traditional organization. So if we talk about DAO, right, it is totally democratized because we do not have any humans. So each and everything is done by the votes, and which are totally transparent as well. While if we talk about organization, it runs on hierarchy, right? Because there is a director who will be ruling the organization and he will be telling what to do and what not to do. If we talk about DAO, we require voting. But if we talk about traditional organization, it might be or it might not be the case. If we talk about DAO, no trusted intermediary to count vote, right? Because we do not need to depend on someone else for the counting of vote, because smart contracts are smart enough to count the votes. In this, we require some other person, some person who actually manually do the voting, counting of the votes and everything. So we are actually dependent so much on a centralized authority, right? If we talk about fourth, services offered are handled automatically. Right, because no human intervention, just give it a task and smart contract are smart enough, they will do your task. If we talk about a traditional organization, we have human handling, or what we can say is centrally controlled automation. If we talk about the fifth point, all activities transparent because smart contracts are totally present in the public space, so you can check the smart contracts, how the smart contract code is running. Each and everything is totally transparent. If you talk about a traditional organization, you never know what is actually happening inside an organization, right? It is totally private, it is limited, very, very much limited to the public, right? So this is the beauty of decentralized autonomous organization. And we will also discuss one case study where this DAO was used in order to raise fund, okay? And we will talk about that in the next video. But in this video, I hope you get what is the idea behind this DAO, right? Let me give you an example of this in this case also, like how this decentralized autonomous organization can be very helpful. So let's say you are here and you want to donate some money to this NGO, right? So in this NGO, because this NGO is an organization, right, which will have lot of number of people, which will have a director, manager, and so many other people will be involved, right? So this money that you are sending to the NGO can be utilized for good purpose and can also be utilized for bad practices, right? And we do not know like where our money is going. We do not know whether the director of this NGO is a good person or a bad person. We do not know, right? So what we can do is, instead of having this NGO as an organization where humans are running it, we can have our decentralized autonomous organization where we will write each and every rules that, okay, if this money is coming from, let's say, this person, and this person wants to donate this money for human education, so this money should go to human education only. Or let's say for child education, then it should go to the child education only. And the best part is that this organization will be totally transparent, so you can go and read it. And not only that, you can see all the transaction as well, that okay, if the money that you are sending to this decentralized autonomous organization, whether this money is actually going to the right account address or not. And this is the beauty of decentralized autonomous organization. But in the next video, we will talk about DAO Attack, which was the biggest attack, I think, and we will talk about that in the next video. Hi, in today's video, we are going to talk about the DAO Attack. So in the previous video, we talked about DAO, right? Decentralized Autonomous Organization. And we have seen that in a decentralized autonomous organization, each and everything, or I will say most of the work, is actually done by smart contract, right? And using the same principle of decentralized autonomous organization, an organization was formed by the name of the DAO. The DAO was an organization which was established in year 2016. And it was working on a very simple principle. Anyone who wants to invest some money to some startup, like it was working as a venture capitalist firm, which was actually helping others to invest in a particular company. So let's say we have certain group of investors, okay? So what they do actually, they buy some DAO tokens by providing some ether to the DAO organization, and they were provided with some DAO tokens. Now, these DAO tokens were actually used for the voting. So let's say if some investment proposal, let's say some startup is there and it says, okay, I am a startup and we need some money in order to, to run our startup. So people who will be having this DAO token, they were allowed to vote on this investment proposal, whether to invest for this particular startup, whether to invest for this particular company or not. So with the help of this DAO token, people were given this authority, this power to invest in a particular company or not. So what they do, they simply vote for a particular investment proposal, and if the investment proposal votes are, let's say, more than 50%, then definitely they go for this investment proposal. Otherwise, this investment proposal was rejected. So you can clearly see that it was a very simple concept, and it was very much successful also. Let me show you the timelines. So it was established, as I said, the DAO was established in 2016. So 34 2016 it was established, and by 15/5/2016, in just 15 days, the DAO was able to raise over 100 million US dollar, which was, record breaking. In so much less time, the DAO was able to raise so much high amount of money via crowdfunding. And 1 month after this raise, the DAO was attacked. There was some issue, there was some vulnerability in the smart contract of the DAO, because as I said, right, when we talk about decentralized autonomous organization, most of the things are actually done by smart contracts. And there was some vulnerability in the smart contract code, and that vulnerability was exploited by some hacker, and they were able to extract huge amount of tokens from the DAO smart contract, which was a very panic situation, because the investors who have invested huge amount of money in this DAO contract, they were losing this money. So this was a panic situation at that point of time. You can clearly see, right, US $100 million was raised, right? So a lot of amount of money was there in the DAO contract. The DAO community came up with a proposal that what should they do in order to stop this attack, and the solution that was accepted on 27/2016 was to go for hard fork, which we will talk about in great detail in the next video. After hard fork only, the Ethereum blockchain got split into two different blockchains. One was Ethereum Classic and the another was Ethereum blockchain, the core Ethereum blockchain. But we will talk about this hard fork concept in the next video. But before completing this video, before ending this video, I want to draw some important points to you so that you are not confused, because many of you guys might be thinking that the DAO was attacked means the blockchain can be attacked and the blockchain can be hacked. No, the blockchain was not actually hacked. The problem was with the code. Person who has written this smart contract code has not written this smart contract properly, and that's why this blockchain, or I will say this smart contract, was hacked. So the problem was not with the technology, the problem was with the smart contract code that was written by some human. So it is very, very, very necessary, if you are creating a smart contract, your smart contract should be written in a very secure way. Otherwise you will be losing millions of amount of dollars, because your smart contracts can hold millions of amount of dollars, right? So you have to be very careful. You need to have good developers who are actually creating your smart contract. In this video, we are going to talk about a very important topic, that is hard fork. So in the previous video, we have seen that the DAO smart contract was hacked and the hacker was able to extract out funds from the DAO smart contract. If you haven't watched the previous video, I will suggest you to watch the previous video on the DAO attack. Now to stop this attack, now to stop this hacker from extracting out the fund from the DAO smart contract, the Ethereum community came out with a solution, and that solution was hard fork. Now in this hard fork, what was proposed actually, that let us upgrade our smart contract, because our smart contract consists of some vulnerabilities, and due to these vulnerabilities, some hacker is able to extract out funds. Some people of the Ethereum community thought of that we should upgrade our smart contract. If we will upgrade our smart contract, then the hacker will not be able to extract out fund. But there were some other members who thought, okay, if we are going to upgrade our smart contract, we are actually going against the principle of a smart contract. That smart contract must be immutable. You cannot change a smart contract once it is deployed to the Ethereum or to any other blockchain. So two parties were formed. One who was suggesting that we should upgrade the smart contract so that we can stop the hacker from extracting out the fund, Another party who was saying that if we are going to upgrade our smart contract, it will be against the principle of our smart contract, that is immutability. So we should not upgrade our smart contract. And due to which only two blockchains were formed. One was the Ethereum blockchain, this core blockchain. This blockchain supported the upgradation of the smart contract, while this blockchain, this Ethereum Classic blockchain, said, okay, I am not going to participate in this upgrading of the smart contract, so we will split from here. And this process where you are seeing, right, that a single blockchain got splitted into two different blockchain, this process is actually called as hard fork, but you have to understand much more about this because there is another term also that is called soft fork. But we will talk about soft fork in the next video. In this video, let us understand what is hard fork and what is hard fork all about. So during a hard fork, software implementing a protocol and its mining procedures is upgraded. So the underlying software, the Ethereum software that people are using so that they can be the part of this Ethereum blockchain, that software is upgraded so that the desired changes can be made. Second thing is, once a user upgrades their software, that version rejects all the transaction from older software, effectively creating a new branch of the blockchain. And you will understand this. We will discuss about all these concepts in much more detail. Just don't worry for now. However, those users who retain the old software continue to process the transaction. So if you will go back in this example, this Ethereum Classic, who said that we are not going to upgrade the smart contract, they were following the old version of the software, while this new blockchain, after this point, this new blockchain was adopting a new version of the software. So that's why we see a split after this 1919999 block. And hard fork is not something that has actually happened to the Ethereum blockchain. Hard fork is something that has already done on the Bitcoin blockchain. In year 2017, August 2017, two different blockchains were formed. One was our core blockchain, that is Bitcoin core blockchain, and another blockchain by the name of Bitcoin Cash. Now, why we have these two different parties? The reason is very simple. This Bitcoin Cash community, this Bitcoin Cash party, they said that we should have much more size of the Bitcoin blockchain. Like if we talk about a typical Bitcoin blockchain block size, it is around 1 MB. And since it is around 1 MB, we have limited number of transactions inside a block, right? So this Bitcoin Cash community said that, okay, this 1 MB block is not suitable because we are not able to have more number of transactions in the Bitcoin block. Why not to upgrade the block size from 1 MB to 8 MB? But this Bitcoin community, this party, they said that no, we do not want that. We only want that Bitcoin blockchain block should be 1 MB because this is good. We should not increase it to 8 MB. But this community said no, we want to increase it to 8 MB. And that's when this split happened. At 478558 block, these two parties are formed. This Bitcoin Cash, who was supporting 8 MB block of the Bitcoin blockchain, and this Bitcoin that was supporting only 1 MB of the Bitcoin blockchain. And now let us understand this hard fork with the help of an example. So here we have this Bitcoin Cash blockchain who said that, okay, we are ready for the 8 MB block of the Bitcoin blockchain. And this Bitcoin blockchain, this our core Bitcoin blockchain, who said that no, we are not going to upgrade to block size of 8 MB. So these are the people who haven't upgraded, right? And these were the people who have upgraded. And I have given some timestamp. Definitely this timestamp can be in months or in a year, but I have just for the illustration purpose, I have 11 a.m., 12 p.m., 1 p.m., 2 p.m. Okay, so this is just an example to illustrate. And here we are going to upgrade the block size to 8 MB. So this community of Bitcoin Cash has upgraded 8 MB block, but this one has not updated or has not upgraded to 8 MB block. Now let us understand this with the help of an example. So this is the line after which people have a choice that they can either go to 8 MB block or they can remain in the 1 MB block. So let's say a 1 MB block is mined at this by this Bitcoin community, okay? And after some time at 12 p.m, let's say they again mined one more block that is of 0.7 MB. And since 0.7 MB is less than 1 MB, so they can mine this particular block, right? Now at 1 p.m, a block is mined which is of 7 MB. Now since this block is of 7 MB, so these people cannot mine this block, right? Why? Because they have not upgraded to the latest version of the software, right? This is what we have seen, right, in the previous video. While these people, they have upgraded to the new software, so they can mine a block of 7 MB, right? Now again at let's say 1 p.m. again a new block is mined by these people, which is of let's say 0.5 MB, and that's fine, right? But now you can see that we have a split in the blockchain, right? After this particular block, we can clearly see that we have a split. Now after this part, after this particular time, both of these community will mine the block separately. So let's say another block of 8 MB was mined by this community at 2 p.m. and at 2 p.m. a block was mined by this community of 1 MB. In the same way, again, some 0.8 MB block was mined by this particular community and 8 MB block was mined by this Bitcoin Cash community. And this process will go on parallelly. Means these people will not affect these people and these people will not affect these people, because now we have two separate blockchain. These people have actually upgraded the software while these people have not upgraded the software. That's why we have these different blockchains. And this is what we have learned about the hard fork, right? In the definition of hard fork, that there will be two versions of the software. The people who will go for the latest version, they will have a different blockchain, but the people who will be, in the old version of the software, who will be using the old version of the software, they will be still be using that old blockchain only. And this is what we are seeing in this particular example also. So I hope now you have understood what is hard fork, and all these 3 points are very clear to you. Now in this video, we are going to talk about soft fork. In the previous video, we talked about hard fork, right? Now in this video, we are going to understand soft fork. If you haven't watched the previous video, I will suggest you to watch that video before watching this video, okay? Let me present you certain points related to soft fork, okay? And if you are not getting those points, just don't worry. We are going to understand those points with the help of an example. For now, just have a look at these different points so that you can have a, just have a look, so that when I'm going to explain those things, you can connect the dots, okay? So just for that, just have a look at these different lines and you will understand this by the end of this video. So just don't worry, okay? So let's talk about soft fork. Soft fork are a change to the protocol, but the end product remains unchanged. Now, what do I mean by this line? It simply means that you are going to make some changes. Let's say if we talk about Ethereum. So you are going to make changes to the Ethereum protocols, means the rules and regulation on which Ethereum blockchain is running. You are going to change those rules and regulations, but the end product remains unchanged. Your Ethereum blockchain will remain the same. There will be changes, but those changes will not affect the product. So let us understand this. If we have talked about hard fork, right, in the previous video, where we have seen that after hard fork, we got two different Ethereum blockchain. First was this Ethereum blockchain and another was this classic blockchain, right? This Ethereum classic blockchain has its own community. This Ethereum blockchain has its own community. This Ethereum classic blockchain has its own cryptocurrency and this Ethereum blockchain has its own cryptocurrency. So you can clearly see that in hard fork, our end product, that is our Ethereum blockchain, got changed. Our Ethereum blockchain got split into two different blockchains. So we got two different products, right? But in case of soft fork, this is not the case. And you will understand this once we will see the example. If we talk about the second point, a soft fork is backward compatible. If we talk about hard fork is not backward compatible. Once a hard fork is done, as the name suggests, hard, so you cannot go back once a hard fork is done. But if we talk about soft fork are actually backward compatible, meaning that upgraded nodes can still communicate with non-upgraded ones. Means, as I said, right, soft fork is also going to change the protocol. So it is like you're updating your software. So after the upgradation of your software, the people who are going to use that upgraded software will be able to communicate with those people as well who have not actually upgraded their own software. So both of these different parties will be able to talk to each other, will be able to communicate with each other. Okay. Third point is that old nodes, not upgraded nodes, could still validate blocks and transaction, but they just wouldn't understand them. I understand all these things are so overwhelming, so confusing. So just don't worry. Let us see the soft fork with the help of an example. Okay. So let us understand this soft fork with the help of a game analogy. Okay. So let's say you are playing some video game. Okay. And to In this game, you have two different teams. First, team A. So this is our team A, and we have this team B. Okay, so you can clearly see that this is our team B. And in order to play this game, they need to fight with each other. So they have some swords given in the game. Okay, not in reality. They are doing everything in the game only. Okay, so just don't take it seriously that they are, fighting with sword. No. So this player, they have their own players, and this player can use this sword in order to fight. Okay, so you might have played these type of games. Now, after some time, the game community, means the company who was actually providing this game, they thought, why not to upgrade this sword? Okay, let's say this sword was weak. Okay, so they thought, why not to upgrade this sword to a new sword? Okay, and this is a more enhanced sword. It is more stronger than this previous sword. So they thought, okay, we will upgrade our gaming software and we will provide this latest sword to all the new players. Okay, to all the players who are going to join the game, as well as players who are already part of this game, they can upgrade their software in order to have this. And the change was made. But this team A, they said that, okay, this sword that we are using, fine by it, and we are comfortable to use it, so we are not going to upgrade our software. Okay, we are comfortable and we are going to play with this same old sword. While team B, they said, okay, this sword is much more enhanced one, much more stronger, so we are going to upgrade our software. And they upgrade software, so now they have new stronger sword. Okay, so team A using the old sword, while team B is using the new much stronger sword. But after some time, this team A started facing some problems. Since this sword is much more stronger than this sword, so team B is easily able to defeat team A, right? First, they are in majority, so they have much more players and they have much more stronger sword, so they are beating team A in a much more easy way, right? It makes sense. A much more stronger sword will definitely going to defeat this, old, weaker sword. So team A, after some realization, they said, okay, this is not working. Definitely we are comfortable, operating this sword, but we need to upgrade it. We need to upgrade our gaming software. So at the end, they need to upgrade from this old sword that they were using to this new sword provided by the gaming community. Now, you might be thinking, like, why I'm explaining you this whole story, right? What is the point of it? But you will understand this once we are going to take this same analogy in this soft fork example. Okay, so in this soft fork also we have two teams. One who is not ready, who are not actually ready to upgrade their software, and we have this another team who are in majority. So they are in majority, like team B. The team B was in majority, right? So they are also in majority and they are ready for the upgrade. And what is the upgrade? So this team A, or the team that haven't upgraded yet their software, they are saying that, okay, we are going to have 1 MB block in our blockchain. So we are going to mine block of size up to 1 MB. While this team B, they're saying that, no, we are not going to mine, block size of 1 MB. We are going to mine block size of up to 0.5 MB. That's why this 0.5 MB, right? So they are ready for mining this 1 MB, like block size of up to 1 MB. But this team B, they are not willing to mine 1 MB block. They are saying that we are going to mine only 0.5 MB blocks, okay, up to 0.5 MB blocks. So the mining process starts, and since this is a soft fork, both of the teams are in communication. This is what we have seen in the first point as well, right? That both of the teams will be in communication even though after soft fork. So let's say team A, okay, so the team who haven't upgraded their software, they mined a block of 0.4 MB, okay, at 11 a.m. And after some time, again, they got this opportunity of mining this 0.5 MB block. So they were able to mine this 0.5 MB block. After some time, let's say 1 p.m., at 1 p.m., they again got an opportunity to mine this 0.8 MB block. Okay, so this is totally random. So they are, they are lucky, I will say. So they are able to mine these blocks 0.4 MB, 0.5 MB, as well as 0.8 MB, because they are supporting blocks of like up to 1 MB, right? But at 2 p.m., at 1 p.m., actually not 2 p.m., at 1 p.m., at same time, our team B, team who have upgraded their software and who are in majority, they mined a block of 0.3 MB. Okay, Okay, this can happen, right? Because we have seen in the consensus algorithm video, right? If you haven't watched, please watch that video where I've explained about the consensus and everything. That it might happen that two nodes or two miners can mine a block at the same time. So in this case, this community, okay, so as both of them are the part of the same community, they are in communication. So in this community there was some miner who was able to mine the 0.8 MB block, and in this community as well there was some miner who was able to mine the 0.3 MB block. So it makes sense, right? This type of things happens in the blockchain community. There are so many miners and they might be mining at the same time. So this happened at 1 p.m. only, okay, in this community as well. After 1 p.m. at 2 p.m. again they got this opportunity. Team B again got this opportunity of mining a 0.4 MB block. Okay, this makes sense. And as soon as Team B mined this 0.4 MB block, Team A, this team realized that okay, there is a problem, and the problem is that this team B has the longest chain. Why? Because they have mined the 0.4, 0.5, 0.3 and 0.4 MB blocks, right? So they have in total 4 blocks in their, in their bucket. While if you talk about team B, or not team B, actually team A, they have only 0.4, 0.5 and 0.8 MB blocks, means in total they have 3 blocks in their bucket. So by the longest chain, as I have discussed in the consensus algorithm video as well, right, that by the longest chain rule, this block will be discarded from the blockchain ecosystem, because this block is not the part of the longest chain. Now some of you might be thinking, right, like, but 0.4 MB and 0.5 MB were not actually mined by team B. So why you are saying that 0.4 and 0.5 MB is actually mined by team B? See, I'm not saying that they have mined this particular block. The point is that both of these community are the part of the same community, right? And this is what we have seen in the soft fork video also, that even though after upgrade, both of these nodes will still talk to each other. They will still, participate in the validation and the, verification of the blockchain. So they are the part of the same community. So they have not, they have not split it like we have seen in the hard fork. They are the part of the same community. The only thing is that one of the teammate have upgraded the software while another have not upgraded the software. This is the only difference that is lying. So still this whole blockchain, the whole blockchain that you're seeing is part of the both of these people, right? But the 0.8 MB is not part of this community, right? Why? Because this 0.8 MB is a block which they do not support. So they said, okay, we have upgraded our software and we are not going to, we are not going to accept this 0.8 MB block. So it makes sense, because they have upgraded their software, right? So they will not calculate this block as the part of the blockchain, while this team will only accept this block as the part of their blockchain because they have not upgraded their software. So the whole community will discard this particular block, and you can clearly see that. Why? Because this team B is in majority, right? And we always go for the majority. So they will discard this particular block, and again the mining process will start. So let's say at 3 p.m. this team A again mined some block 0.5 MB, and then at 2 p.m. this particular, this majority team, that team B, mined this 0.3 MB block, and this process will go on. But here one important thing to note here is that you can clearly see that this blockchain does not got splitted, right? This blockchain is still the same, while in case of hard fork we saw that we have two different blockchain. Definitely it might look that okay, this blockchain is getting splitted at this point of time, but no, this is not getting split, because we are going to discard these blocks, right? And this is what we have seen in the game video as well, right? That after some time team A realizes that we are going to lose this particular game, so we need to upgrade our software, right? And the same thing will happen in this case as well. When this team A will see that okay, these people who are in majority, they have upgraded their software, so we need to upgrade our software so that we can also be the part of this game, right? So that we are not losing this whole game. So this is what actually happens in soft fork. And still, if you have any confusion, please let me know in the comment section of this video. I will definitely answer your queries. Hi. Now in this video, we are going to talk about ICOs, that is initial coin offering. Now to understand this definition, let us take an example, because I know this definition is a little bit technical and you might not get this definition. So let me give you an example to understand this definition. Let's say you go to a bakery shop, okay? This bakery shop consists of some delicious pastries and cake, and you find one of those pastries and one of those, cake, and you're like, okay, I need to buy this particular cake. It looks delicious to me. So you went to this bakery shop and you said to the owner, okay, I want to buy this pastry, and you provided him with the money. But this bakery shop owner said, no, I cannot directly provide you this cake. If you want to buy this cake, you need to buy some tokens from me, and then you need to go to the cake counter in order to get this cake. So instead, directly providing you with the cake, this bakery shop owner provided you with some tokens. Now, these tokens are something which you can use in order to buy anything from this bakery shop. Okay, so this bakery shop, this owner gave you these tokens. He said that, okay, with the help of this token, you can buy anything from my shop. You can go to a specific counter. Let's say if you want to go to buy cake, you have to go to the cake counter. If you want to buy a pastry, you have to go to the pastry counter, and you can use these tokens in order to buy this cake. And you said, okay, that's good, and you provided the money to the bakery shop owner, and bakery shop owner provided you with this tokens, and you use these tokens in order to buy this particular cake. Now, if you will see in this example, these coins that you are seeing right on your screen, these coins are basically known as tokens. Okay, and you might have gone to a bakery shop like this, right? You might have gone to. So if we will go back to the definition, tokens are a type of cryptocurrency that represents an asset. So if you will look closely, these coins, these tokens are actually representing a particular asset, and that asset is cake in this example, right? So tokens are a type of cryptocurrency. So they are also basically a type of cryptocurrency represent an asset. In this case, as I said, these tokens, these physical world tokens, are actually representing this cake or specific use. Okay, we will talk about it. And resides on their blockchain means every blockchain has its own token. Like if we talk about Ethereum has ERC20 token. Okay, Solana will have its own token. So every blockchain will have its own token. Okay, so this is the whole definition. This tokens definition, I think now clear, right? That tokens are a type of cryptocurrency that represent an asset. So remember this line, that tokens are nothing but these are cryptocurrency that are representing some asset. Okay, now if this definition is clear, let us talk about ICOs. Now let us talk about initial coin offering. Now, before talking about initial coin offering, let us understand what are basically IPOs. So IPOs are something that if you might have heard this term in the stock market. So let us understand that so that it will be much easy to understand what basically ICOs are. So, okay, so we have Jeff Bezos. Okay, so we have Jeff Bezos invested some amount of capital to Amazon, right? Now, when he invested this amount of capital into Amazon, because Amazon, as you all know, is a business, right? Amazon provided Jeff Bezos with some shares, right? Because let's say in the starting, Jeff Bezos owned the whole Amazon, so he has all the shares of Amazon, right? And how Amazon make profit? Amazon makes profit by providing service and products, right, to the consumers, and in return, Amazon gets some profit. So this is how Amazon makes money, right? Now, Jeff Bezos thought, okay, this is good, but I need some more capital. I need some more capital so that, I can grow my business at 10x speed. So what he did, he launched an IPO. Now, in this IPO, anybody can invest and invest to the Amazon. So these people who are part of the general public, they will provide some cash to Amazon, because Jeff Bezos needed some cash, right, in order to expand the Amazon business. So they will provide him some cash, they will provide some cash to the Amazon, and in return Amazon will provide them with some shares. Now, what are the benefits of this share? So when Amazon will give the shares to these shareholders, so these shareholders will have a say according to the number of shares they hold, right? So if someone is holding some, let's say for example 40% of the shares of this Amazon, so he will be giving, he will be having much more authority over the shareholders who have only 30% or let's say 20% stake in Amazon, right? Because he owns much more shares of Amazon because he has provided more cash to Amazon, right? So this makes sense, right? So this is how an IPO works. Okay, this is how a company makes some money so that it can expand, and these people who have invested some money to the Amazon, they have some shares so that they have, some rights over Amazon, as well as whatever profit Amazon will make, they will have their own shares. Now let us talk about an ICO. Now ICOs works exactly the same as an IPO. The only difference is that ICOs are much more faster because they do not require any kind of paperwork, or the paperwork that is required is minimal. No legal procedures, no huge documentations, nothing is required. You can launch an ICO right now as well. So it is so easy. While if you talk about an IPO, you need a lot of legal procedures required. It takes, around 1 year to 2 years even to launch to launch an IPO, or even more also, because a lot of regulation is there, a lot of, legal documents, a lot of formalities are there. But if we talk about an ICO does not require any of these things. They are very simple, they are very easy to launch. So if we talk about an ICO works, so again, let us say that Jeff Bezos is thinking to launch his business, Amazon. Now, instead of receiving some shares, what he will receive will be some tokens. So as we discussed, that tokens represent some asset, right? And in this case, tokens are representing Amazon. Okay. Now again, how Amazon will make profit, again service and products, and then by selling these services and products, Amazon will make some profit. Now again, Bezos thought, okay, I need some money so that I can expand my business. So what Bezos will do, he will launch an ICO. Again, people will come, provide cash to Amazon, that Bezos expand his business, and in return, these users, these people who are investing their cash to this Amazon, they will receive some tokens. Now, with the help of these tokens, these people again will make some profit. Whenever Amazon will make profit, they will make some profit. And definitely, when Amazon will make some loss, they will also have those losses, right? Because they are actually, investing to this Amazon for the betterment of Amazon. So if Amazon is going in loss, will also experience loss in terms of tokens. So tokens value will start decreasing if Amazon will be not working properly. And again, since they will have tokens, they will own tokens, so they will also have some rights over Amazon big decisions. Like say Amazon is thinking to launch one more business, or Amazon is thinking to launch one product. So the people who will be owning these tokens, right, so they will have some voting rights, and they will also decide whether a particular product should be launched by Amazon or not, or whether a particular services should be provided by Amazon or not. All these decisions will also go through these people as well, because they have invested their money and they also have some tokens, so they will also have authority, right, in order to say something whenever Amazon is taking some major decision. So this is what an ICO is all about. Simple, right? Just like an IPO, the only difference is it is very fast, no complex procedures, no legal documentation and everything. Definitely, if there are no legal documentation, it is so easy. Chances are high that ICO is a scam. So you have to be very much careful whenever you are investing in an ICO, or chances are high that you get conned. Okay, because ICO, as I said, right, there are no legal documentations, there are no legal procedures, so anybody from their home can launch an ICO. So you have to be very much careful whenever you are investing in an ICO. Okay, always read the white paper documentation provided by the company before investing in any kind of ICOs. Hi. Now in this video, we are going to talk about Ethereum 2.0. So let us see what it is. On 15th September 2022, Ethereum shifted from a proof of work blockchain to a proof of stake blockchain. So the mining concept that we have discussed in our previous video, right? When we were discussing how miners solve a mathematical problem and everything, right? I hope you have watched those videos. So all those concepts were related to your proof of work consensus. And now Ethereum is using proof of stake consensus. So now it is not using proof of work consensus at all. And now it is using proof of stake consensus. So now you must be thinking, like, why Ethereum shifted from proof of work blockchain to a proof of stake blockchain? And we will discuss about that also, don't worry. We will also discuss the difference between proof of work and proof of stake consensus. Okay. Like in proof of work, actually, we were having miners, right? In proof of stake, we have validators. So definitely you can call them miners, but in proof of stake terminology, you call them validators. Now, what these validators do? These validators stake some of their ethers to the Ethereum network. So this is your Ethereum network. You can think of it as a locker. Okay. For now, I'm just demonstrating it as a locker. So what they do, they stake some ether to the Ethereum network. So it is like you have some, let's say, some 2 ethers, and you are going to stake 2 ether to this Ethereum network. Now, once you will stake some ether to the Ethereum network, you are eligible, and now you can mine for the Ethereum blockchain. So like in proof of stake, miners were using, miners were solving some mathematical problem in order to solve the blockchain, that mathematical puzzle in order to mine a particular blockchain. In the same way, after staking these ethers, these validators can now mine for the Ethereum blockchain. Let's say this validator who has actually staked his ether, right, to the Ethereum blockchain, once he will mine a Ethereum block and he will add this Ethereum block to the Ethereum blockchain, the staked ether, the ether that he has staked to the Ethereum network, will be returned back to him. So the ether that he has staked, let's say he has staked 2 ether, just for example. So this 2 ether will be returned back to him, as well as he will get some commission for solving, or I will say for mining, the Ethereum blockchain. Okay, so this is how the validators make profit by this transaction fee. But if during the verification and validation of the block, this validator has done some cheating, for example, so if during the verification and validation of the block, other validators found that, okay, this validator has done some sort of cheating, then the Ethereum network will not provide the staked ether back to the validator, and he will not be receiving any kind of transaction fee. Like in Bitcoin blockchain, the block was discarded and the miner was not getting any kind of reward. In the same way, in Ethereum blockchain, the miner who will be doing any kind of cheating, or validator who will be doing any kind of cheating, that validator will not get any transaction fee, and the staked ether, the ether that he has staked in the Ethereum blockchain, will not be provided back to him. So he will be at a loss. So he have to be very much careful whenever he is mining for the Ethereum blockchain. So now let us understand this with the help of an example also. That let's say all these people A, B, C, E, F are validators who have actually staked some amount of ether in the Ethereum blockchain. Now the question arises, which of these people will be selected for the mining of the blockchain? Whether all will be selected for the mining of the blockchain? No, all of these people will not be selected for the mining of the blockchain, because in proof of stake, there is no competition between the miners. Like in Bitcoin blockchain, we have a lot of competition between the miners, right? Which miner will solve the mathematical problem first. But in proof of stake, there is no competition. Let's say if all these people have staked some amount of ether, then only randomly one of these people will be selected. So it is a totally random process. So in this total random process, if let's say A has staked some amount of ether, so chances are there that A will be selected, or chances are there that E can be selected. So it is a total random process. This selection process is total random. Anybody can be selected from the Ethereum blockchain network. So E can be selected, B can be selected, any of these people can be selected. But there is also one condition, means definitely anybody can be selected. This is definitely total random process. But in this also, the person who has the most amount of ether, the chances of getting selected as a validator are very much high. So if you are a person, let's say if you have staked 10 ether in the Ethereum blockchain and your friend has staked 20 ether in the Ethereum blockchain, so the chances of your friend getting selected are much higher than you, because he has staked 20 ether and you have actually staked only 10 ether, right? So in this case, your friend has a higher chance of getting selected. It is not that you will not be selected. There will be a chance that you will be selected, you might be selected, because it is a total random process. But chances of getting selected for the person who has staked most amount of ether will be much higher than those people who have staked less amount of ether. Okay. Now let us see the difference between proof of work and proof of stake consensus. So if we talk about proof of work, in proof of work we have miners, right? In case of proof of stake, we have validators. In proof of work, high performance hardware is required. So people need to buy, miners actually need to buy ASIC technology so that they can mine, so that they can competition of mining, right? So anybody who will be solving the mathematical problem first will be the winner, right? So for that, they need to invest huge amount of money in the technology. But in case of proof of stake, you just require your mobile or your laptop, and that is more than enough. If we talk about proof of work, it requires a huge amount of electricity. While if we talk about proof of stake, it does not require any kind of electricity, and that very simple, right? You can simply mine for the Ethereum blockchain using your mobile or your laptop. If we talk about proof of work, the more hashing power you have, the more blocks you can validate. So the person who will be having, huge technology for mining, he will be having the most hashing power, right? And since he will be having the most hashing power, the chances of mining a particular block are very high. While in case of proof of stake, the person who has invested the most amount of ether will be having higher chances of validating a particular block or mining a particular block. I'm saying mining again and again, so just don't be confused. I'm talking about validation only. Okay. If we talk about proof of work, we for attack need to happen, we need 51% hashing power, right? We have discussed all these things in the Bitcoin fundamental videos, right? I hope you have watched those videos. While in case of proof of stake, anybody who wants to have control over the Ethereum blockchain need to stake 51% of the stake amount. And that is very much, very high. Means just imagine the price of Ether is around, I think, $1,000 at this point of time. I just don't know. But 51% to stake 51%, seeing to the total Ethereum blockchain, number of validators, and let's say if each validator is only investing one ether, just an example, let's say they have 1 lakh validators, so total amount that you have to invest will be 51% of this 1 lakh ether around. That is, I think, very much high. So that's the case when it comes to proof of stake. If we talk about proof of work, competition is there, right? Everybody is competing with each other. While in case of proof of stake, there is competition. It is a total random process of selection, right? So these are the differences between your proof of work consensus and proof of stake consensus. So I welcome to our last video of this course, that is altcoins. What are basically altcoins? Altcoins are basically all cryptocurrencies other than Bitcoin. So if we talk about, Litecoin, Theta, USDT, Link, BNB, ADA. There are so many cryptocurrencies apart from Bitcoin, and all these cryptocurrencies come under the category of altcoins. Now you must be thinking, what is the need of so many different cryptocurrencies? What is the need of altcoins? Means cryptocurrencies apart from Bitcoins. Like Bitcoin was not enough. Actually, there are three reasons. The reasons why do we have so many different altcoins. First reason is application and uses. If we talk about Bitcoin, let's say Bitcoins only support transactions, right? We can only send transactions. We can send some Bitcoin to our friend, or our friend can send some Bitcoin to us, and this is how Bitcoin works. But if we talk about smart contracts, Bitcoin does not support smart contracts, right? And Ethereum as a blockchain supports smart contracts. So you can clearly see that Ethereum is supporting transaction as well as a smart contract, while Bitcoin is only supporting transactions, right? Second thing is protocol. If you talk about Bitcoin, Bitcoin has a different kind of a protocol. Protocol means rules, okay? So like if you talk about Bitcoin and Ethereum, both of them are actually using blockchain as a technology, right? But both of them works in a different way. If we talk about Bitcoin, Bitcoin uses proof of work. While if we talk about Ethereum, Ethereum uses proof of stake. And both of these consensus are different consensus, right? So this is the second reason why we have Ethereum, right? Otherwise, Bitcoin was more than enough, right? But since proof of stake is much more environmental friendly, that's why we have another altcoin, and that is Ethereum. Okay. Third reason is technology. So if you talk about Bitcoin, Bitcoin is using public blockchain, right? But if you talk about Ripple, Ripple is also a Ripple is also a altcoin, but it is using, different kind of technology. It is using blockchain, but it is not working on the principle of decentralization. All these different altcoins, like you can see that there are so many different altcoins, right? So all these different altcoins are basically developed because all of them have either different applications, different protocols, or they are using some different kind of technology. That's why we have so many cryptocurrencies. That's why we have so many altcoins. Otherwise, if we want only one application, that is only sending of transactions, then Bitcoin was enough. But since we require so many different things, that's why we have so many different altcoins. And with this, we have completed our course. So, congratulations. We have learned so many different things, right? We covered 3 different modules. First was blockchain, second was cryptocurrency, and the third was Ethereum blockchain. I hope you enjoyed this course. Please do leave a comment below. Any feedback, anything that you want to say, please leave a comment below of this video. I will be happy to address it. This is only for you. I hope you have liked this course. If you have liked this course, please click on that like button. If you are new to this channel, please subscribe to this channel because I'm regularly going to upload new blockchain courses on this channel. If you have any doubts or queries, you can comment your doubts and queries in the comment section below. I will be happy to help you there. And if you want to talk to me directly, then you can connect with me at Instagram. CodeEater21 is my ID, or you can connect with me at LinkedIn. Kshitij Web3 is my LinkedIn ID. And please do not forget to share your feedback. Thank you so much. Meet you soon in the next course.